Hey, you're muted.
We want to make sure that you follow these rules, that you make this event a pleasure for everyone, and let us know if something is not working out. Hopefully at the registration you already have seen the sign-up sheet for the office hours. If you want to talk to one member of the Bazel team or to some of the community experts, you can go there still during the 2 days and sign up. Also find us during the breaks if you want to talk to us. For communication, we have the Slack channel. There's a BazelCon chat room. If you're participating remotely, that's the place where you can ask questions. We will not able to answer them live, but we will make sure that speakers are also in that channel and can answer questions later. This is where we are today, in this big room. You found your way in, hopefully. We will have later some birds of a feather sessions in other rooms, and we will also have lunch in other rooms available, because you see it's a big group, and if everyone is queuing there, it will take too long. So I will show you quickly how to get there. So if you exit through this door and go 1 floor up, you end up in the first floor in the so-called moonshot lobby. There we will have food, and one of the BOF sessions will take place here in Moonshot. Should also be here at your badge. And then if you go up in the tower here to the elevator to the 6th floor, we have the Isabelli Tech Talk room. There's also food there, and there's some Bazel partner swag if you find your way up there. But only starting from 10 o'clock. Okay, I think that's enough talk from me, and I would like to invite Michal on the stage, our engineering director, to give the keynote.
Thanks, everyone. This isn't my first BazelCon. I actually was in New York in 2017 for the very first BazelCon, just shortly after I joined Google. But just over a year ago, I took over responsibility for the Google Build teams. That includes Bazel and Blaze. And so it's an honor and a privilege to be able to give you this keynote today. Bazel continues to grow. We're really, really happy to see this growth. One example of this is Slack, where people come together, interact, and help each other. So if you're not there already, take this as a call to action to sign up on the Slack. You can just listen in and see what's happening, or you can participate. Similarly, the number of release downloads has continued to go strong. And our GCS bucket is growing as well. We know that some of these metrics are driven by certain types of automation like CI, but it's still positive that these metrics are good. The majority of users are still on Bazel 6, but there's a significant fraction still on the older Bazel 5, and of course we're looking forward to Bazel 7 soon. We're happy to see that companies are investing in Bazel and building out their business on top of it. And we'll hear from a couple of them during the next 2 days. Let us know if you want to become a Bazel partner in the future. So if you have a company and you think a partnership is the right route for you, we're very open to that discussion. Now, there's a potentially slightly contentious topic here, but it's worth airing publicly. So one of the problems with all of these metrics is that they're proxy metrics. And so ideally, what we'd like to do is instrument the Bazel infrastructure itself to be able to give us some more accurate metrics. But of course, we're not going to impose those on end users without agreement and compliance. So there's actually a birds of a feather session about this at 10:45 today, if you want to join in that discussion. But we think we're at the stage now where we would like to be able to get access to more accurate information to make better decisions, especially with respect to deprecating older features. Understanding how much they're actually in use makes a huge difference in terms of how one might plan for that sort of growth. And Bazel is now quite a mature product in terms of its how long it's been released. And so this sort of consideration starts to become important. In addition, we'd like to collect information about Bazel crashes that would allow us to figure out how to prioritize fixing bugs that were causing problems for our end users. Feel free to engage in that discussion. We regard it as a decision that we'll make with the community, and we look forward to engaging in that. Bazel continues to be used at Google for important projects, and here we mean Bazel, not Blaze. So in other words, we have two types of use of the Bazel Blaze infrastructure inside Google. Most famously, our own Google 3 infrastructure using Blaze, which was the origin of Bazel. But we have a whole host of folks based on the Gerrit and Git on Borg ecosystem internally in Google, and many of those projects use Bazel. Kleaf is a very interesting example. We're building Android Linux kernel and its modules with Bazel. The individual kernel modules, i.e. drivers, can be built in isolation and in parallel, and in such a way it's very reproducible. So that lowers the bar for developing kernel modules for Android using the driver development kit implemented using Starlark. Partners seem to be happy with this build systems. That's the Android partners who also use it. In the long run, the DDK unlocks easier kernel version upgrades and will be able to contribute to prolonged device lifetimes. So it's a win-win for the Android ecosystem. There's lots of other examples, probably digging into the weeds a bit in some of our internal infrastructure. We have this thing called Pigweed, an open source collection of embedded targeted libraries made by Google and used by Google hardware projects that have shipped in volume. And they're transitioning to Bazel as the primary build tool. Like a lot of us, they like the hermetic builds and the fact that Bazel is used much more widely than GN, and they can share build rules with other projects. Today, Chrome OS can build most packages using Bazel by wrapping the packages in legacy build scripts, and can use those Bazel built-in artifacts to assemble OS images. So there's a major sort of migration happening of Chrome OS. And then Fitbit successfully has used Bazel as an intermediate step to migrate their workflow into Google 3. So like they were an acquisition, they come in, they transfer to Bazel, and then they transfer to Google 3, which is, they've done a lot of the heavy lifting already. We need the community, and we're very happy that so many of you are engaged here for the next 2 days. The bandwidth of Google's Bazel team is not sufficient to fully support the whole ecosystem. We need your support to help support the growth of the ecosystem. One example where we've already benefited from this support is the integration of Tinder's Bazel diff, cutting down on the number of test targets by 20% on average and 95% on docs-only changes. So the sort of things that we really are looking to the community to step up to help own are rule sets, extensions, tools, and plugins. And our current model is that we'll continue to be the primary drivers of the core. Starlark rules. So rewriting the formerly native rules has been a long and tough project that we've been working on for a number of years, but we're getting close to the finish line. We can sort of see the finish line. It allows us to have independent release cycles and ship improvements sooner, but it also importantly allows us to share ownership better with the community. So this year we made very good progress across all rule sets, and we expect to complete most of this transition in Q1 next year. You're probably aware that C++ and Java are harder than the other rules, and we have to continue their decoupling in 2024. We shared a new extensibility proposal early this year with the idea of having a base rule set that can then be extended in different ways. So the idea here is instead of needing to fork a rule set and maintain a completely parallel version, you can keep the common parts in a single place shared with more people. And the argument is that that will allow us to sort of manage fewer sets of rule sets over time. And we hope that that gets traction and that we get some take up there. We envisage the extension mechanism laying the groundwork for more community rule ownership. And we've started the implementation of the proposal and plan to use existing native Java rules extension as a playground to pressure test the idea and push the implementation forward this quarter. Ivo will talk more about Bazel rules and the implications on ownership tomorrow at 10 a.m. We're happy to see the surrounding community events around this BazelCon itself, starting with the community day yesterday. Hopefully some of you were able to join in with that. And today and tomorrow evening, the community organized happy hours are a nice contribution to the overall conference, and we hope to see you there. So looking back, as I mentioned, I was at the first BazelCon in New York back in 2017. And you could see this as an onward trajectory towards shared ownership of this flagship conference. In 2022, for the first time, office hours were hosted by non-Googlers, as they were the experts in these certain rule sets. In 2023, we've invited non-Googlers to join the program selection committee for BazelCon for the first time. So thanks to Bentley, Fabian, and Luis for your help. And in 2024, we want to go the next step and involve the community in all steps of planning. So let us know if you want to volunteer to be part of that planning process. We really appreciate it. In terms of transparency, Google can sometimes be a very big black box, and it's hard to understand what we're up to. But we've heard the feedback from the community that they want us to be more transparent about what we're doing. And so we're trying to address all of our internal processes and the way that we communicate. And we've recently published a general Starlarkification roadmap and timeline, as well as a timeline for other rules. We want to make sure to keep you up to date with quarterly community updates and more specific blog updates, such as the recent posts about Bazel Mod and Build Without Bytes. And we'll soon publish and regularly update a roadmap for Bazel 8. So I encourage you all to hold us to these promises and keep us honest. And we continue to be committed to the Bazel project and to the community. Another way to get in touch with us and the other Bazel developers and users are GitHub discussions. We enabled them earlier this year, and we saw that that seemed to be actually more engaging compared to what we'd seen on the deprecated Bazel dev mailing list. Now, we believe that they're a good place for having high-level design discussions, and we found voting options helpful for prioritization of open Bazel mod migrations. So we encourage you to be active on this relatively new channel. Feel free to own it and add your own topics and chime in. It's not just a communication channel for us. It's a way of the community organizing itself in a semi-structured way using the GitHub-enabled tooling. Earlier this year, we ran a survey to understand whether we should increase the frequency of our backwards compatible LTS long-term support releases. No real surprise, users generally prefer stability and fast delivery of features. We decided to keep the current de facto year-long release cycle for LTS, as it means fewer interruptions to coordinate major Bazel and rule set updates. A longer major release cycle helps us to bundle more meaningful features into the release, making up for the incompatibilities that users have to go through. Our next major release, Bazel 7, will be shipped soon. We've already created the first release candidate last week. Please take a moment to test your own projects with the release candidate and report back to us if there's any problems. We want to highlight two major features. Build without bytes is a mode where you only download the necessary artifacts to your local machine, skipping over intermediate outputs. This obviously can speed up the build process by our measurements, 40%, depending on network conditions. And while the mode has existed for years, we've actually revisited it, polished it, and we think it's ready for prime time usage. And it's going to be turned on by default in Bazel 7. One of the bigger problems we fixed is gracefully handling the case where the remote cache evicted an artifact by build rewinding. The second thing we want to highlight is Bazel Mod. So it's Bazel's new way to manage third-party dependencies in a consistent way. For Bazel 7, we've matured Bazel Mod, migrated Bazel itself to use it, and added lock file and offline mode supports. We've now enabled it by default, but you can still use the legacy workspace-based system if you wish, but we encourage new projects to start out with Bazel Mod from scratch. Thanks for your attention. If you could hold your questions to the end of the next session, which in some senses will be a deep dive into some of these highlight items, we'd appreciate it. But suffice it to say, I hope to bump into and chat to many of you over the next 2 days. And you're more than welcome here to Munich and to Google and to BazelCon. Thank you.
Just if folks don't have a seat, there are a few empty chairs on this side of the room if you want to make your way over there while we move between talks. Right. All right, so welcome everyone. I'm John Field. I manage the Build Tools team at Google, which includes everyone working at Bazel. I'm particularly happy to be in Munich for this BazelCon because Munich is where Bazel had its start. Thank you. So thank everyone here. I wanted to thank everyone for contributing so much to the Bazel community, both to the Bazel code base, by contributing to a rule set, by filing an issue, by participating in GitHub discussions. You've all added to the functionality we all get to use in Bazel, and also for taking ownership of community issues like maintaining a rule set, being a steward of a SIG special interest group, by leading a SIG meeting, by hosting a community event as we saw yesterday, or sponsoring a reception. So thanks to all the folks who made the community more vibrant by contributing in those ways. So I wanted to highlight a few other things. Mihal told you about a few big things we're doing. There's also a number of other things I want you to know about. One is memory optimization. So we've done a lot of work there. You might have seen some commits landing in this space. And the memory optimizations have resulted in a pretty big reduction in heap size. So retained heap between builds is now much lower than it used to be. So the blue line is the one that you want to focus on there. We recently launched Project SkyMeld. It's been in the works for a long time. It enables interleaved analysis and execution phases. This was a big deal. These phase distinctions were pretty deeply embedded in the code, but we managed to remove them. And by doing so, it enables faster builds and faster errors too, which is not a bad thing necessarily. And it will be enabled by default in Bazel 7. And if you want to try it out now, you can look at one of the rolling releases. We've also upgraded to JDK 21. As many of you know, JDK 21 includes a number of pretty major changes to Java, such as virtual threads, async execution, records, multi-line string literals. Our team has been very anxious to get to be able to use these features. We've already started using them. And in addition to the new language features on the Java side, it includes a much upgraded garbage collector, which enables reduced CPU time. So that's all good. Android, Rules Android is the rule set used to build Android apps. So we've heard from a lot of you in the community that it needed a lot more TLC. We've done that. We've increased the team focus on Android. We've actually increased the number of people working on Android. We've updated the timeline for our work in Android area. You could look on GitHub to see more. We've onboarded the rules set to get Bazel CI to make sure that other changes to Bazel are not affecting the viability of the rules themselves. We've integrated R8, the modern Dexer and optimizer for Android. We've eliminated a lot of crufty legacy flags that Android builds used to use, moved to modern general Bazel platforms, a lot of advantages from that. We're rapidly moving, as with the other rules, the native support for Android to Starlark, and Android local test is one of the completed pieces of work there. That's basically unit tests using Roboelectric on Android. A lot of other cleanups and improvements, but this is a rule set that we're giving a lot of time and attention to, and hopefully you'll see that not just now, but in the future. Basilisk is a great wrapper tool. If you don't use it already, you probably should check it out. We added a nice feature to Basilisk recently that enables you to do bisects. Basically, if Bazel is failing on a particular version, you can use the bisect feature with Basilisk to figure out which commit actually did the deed and thereby send us a better issue report. So check out Basilisk if you haven't, and especially the bisect feature. We've made a lot of changes to the way we manage issues, releases, and CI. We now have a dedicated team, hopefully you've seen evidence of that, which is managing our releases, vetting issues incoming, making sure issues get triaged more quickly and more accurately. We have things like a stale issue bot, so issues don't languish too long, hopefully. We do our best. We can always do better, but by having a dedicated team, we can stay on top of this better. We can now better backport features to earlier LTS releases due to better automation, and we have better flaky test detection and performance monitoring. So all of these things, don't really change the functionality, but make the functionality available to you sooner and hopefully in a more stable way. So it is now my privilege to turn the floor over to Toby, who didn't introduce himself earlier, but I'll say a few words now. In addition to his many engineering contributions to Bazel over the years, he recently took over as manager of the Bazel team here in Munich. He's going to talk, he is the future of the Munich team, and I want him to talk about the future of Bazel. So, Toby.
Thanks. Okay, let's talk about the future. I think the biggest thing we're working on is Bazel mod. To recap, with Bazel 7, we just enabled Bazel mod by default, which I think is a great milestone in the process. With Bazel 8, we plan to disable the legacy workspace-based system, but you can still enable it with a flag. And with Bazel 9, the plan is to remove the legacy system. For that, we need people to migrate. And that is, we realize that ourselves, that is a challenge, and we want to help you with that. We need rule authors to migrate, to make their rules available in our Bazel Central Registry. If you have issues with that, let us know, perhaps on Slack, and we are happy to help you out with the migration to Bazel mod. If you're a rule owner or a project that wants to migrate, we want to learn about all the pain that you feel, and we want to improve the tooling that we give you to migrate, and also documentation, of course. We have a few upcoming features. The one that I want to highlight here is the true repository cache. So the current repository cache is basically a misnomer. It's a download cache. You have to repeat all the work in the repository rules all the time. And that's not great. So Shudong designed a new true repository cache. And for that to work correctly, we have to add this directory watching API, because from Starlock repo roles, you may use these directories as an input, and to make this correct in your repository rules for the repo cache, that we know when to invalidate things, we need this new API. In Bazel 7, we added for BZL mod already in offline mode, but we want to go one step further and add a vendor mode where you can check in vendor all your dependencies in your mono repository. For the Bazel Central Registry, we have planned to improve the pipelines to test against the Bazel LTS tracks, so that's easier to see whether your rule set works with, say, Bazel 6, 7, and 8, for example. Hopefully it works with all of them. We have this Bazel features repository that you can use to help you with having one rule set implementation that works across LTS versions. And then more automation. I think when you update your rule set in BCR, it's still some kind of work, so we want to make that easier for you. SBOM, I don't know if everyone knows that, stands for Software Bill of Materials. So people want to know what went into the final product that you're shipping. That's basically it. And at Google and probably many other companies, we spent quite some time in the past year working on SBOM to comply with this executive order. I even have the number here, 14028. And the US government is mandating here that the software they purchase has an SBOM available. And that's of course something that Google itself wants to comply with, and probably it affects also you guys. And all the lessons that we have learned internally and with people in the community, with government organizations in the past year, they are going to end up in rules license. Tony will give a lightning talk tomorrow about that and go into more details there. Sandboxing has been brought up by you guys as a concern, as a performance overhead, especially on Mac, quite often. So we started looking again into this with a fresh set of eyes. Typically, the sandboxing overhead is proportional to the number of inputs. That's because we symlink each input, and we do that in sequence. So that's maybe something we can improve. But we tried other experiments. We looked into tracing. So let the action run, observe what inputs are read, and then after the action, let the action fail if it read more inputs than it should have access to. That failed for reasons I can't recall right now, but Pedro is here, and you can ask him when you bump into him. And in the same way, we try to avoid symlinks. Julio, a couple of years ago, wrote SandboxFS, which has sort of the same idea. You don't plant the whole symlink tree ahead of time, but you specify what's available for the action to be read. And the issue there is that too many rules don't work with that pattern. If they see more files in that directory and they cannot read all the files in that directory, they will fail. So we were quite optimistic to make this work with Sandbox exec and Landlock on Mac and Linux, but both of these experiments failed. Now, looking forward in the future, we want to still improve performance there. We will look into IO Uring and also virtual threads to speed up things, to plant all these symlinks concurrently and to make things faster there. And also Pedro put out just last week, if you go to Bazel Discuss, an idea how to improve our stashing for sandboxes, so that once you created a sandbox, the idea is that the next way around, a lot of the symlinks you can reuse, and making that a little bit smarter. That's the idea of that proposal. Please give us feedback there. We have planned quite a number of things to improve how macros work. So historically speaking, macros are a little bit like Wild West. So these macros are just essentially functions with side effects. And that's never great to have such a thing in the declarative language, right? So by the end of the loading phase, Bazel is even no longer aware that these macros existed, so it's not tooling friendly either. So we decided to look into symbolic macros. They form an entity of their own. This will allow for better interaction, for example, with query. And then going one step further, we can be lazy, and lazy is always a good thing. So we don't want to create nodes if we don't have to create them. So that's resulting in obvious resource improvements, both in RAM usage and CPU. And then we consider also lazy loading of BZL files. So imagine you have a build file where you load multiple BZL files, you request a target from that build file, and for that target, you don't need any of the loaded BZL files, but you currently still execute all that BZL code. Or load all that BZL code. That's not great. And finally, all of this is these symbolic macros are going to help us to be more tooling friendly. So where you currently could decide, okay, I have a convention, symbolic macros will help you with that because they force you to adhere to something. And that will be helpful for tools. Murali will talk tomorrow about build file automation, and for things like that, it's really helpful to have these symbolic macros. Remote execution, what we have planned there is, while build without the bytes already helped us to reduce the network traffic by a lot, it takes away some of the convenience that you have now when you download all the files. All the files are there on your disk, and IDEs or other tools can access them, especially for debugging purposes. This is really useful. So we heard you loud and clear that you want to have this output service. We had some discussion there on the proposal, whether it's actually something you need or not. So we heard you there, we accepted the proposal. Tiago and Chir are looking into that proposal right now. They have some ideas to make it even more useful. They will talk about this in the BOF session. You should be there and talk with them about this proposal and how to make this work for you, because we're doing this work not for Google in particular, we're doing this work for you guys. The issue on GitHub, if you sort the issues by thumbs up, the issue with the most thumbs up is cleaning up the disk cache. So we are finally addressing this issue. And while we're doing so, we're also looking in all the other caches and seeing whether we can set size limits and clean them up in a way that is useful for you. And finally, I think we have seen that yesterday at the community day that debugging cache hits is an issue, and that's important for you guys if you use remote execution. The execution log is one mechanism to do so, but it suffers from a few problems, and we want to address at least this size issue and performance overhead issue, and give you some more tooling to compare to exec logs and to understand where things go wrong and why you don't get the cache hits you desire. We got this nice swag yesterday, the flag cards. I think it's a 52 card deck. Bazel has 1K flags roughly. And we understand that this is an issue for many of you. Bazel has a steep learning curve that comes up in all the DevSat surveys we do. Thankfully, Alex is helping us with overhauling the Bazel build examples, but that's just one part of helping you to reduce the learning curve for Bazel. We want to try to remove flags that are not necessary. That also helps us to reduce the complexity of the code base. Lukas started a big effort there, removed, I think, 100 flags or so. But I mean, it's just a drop in the ocean if you compare it to 1K flags. What we want to do, and I don't see Ulf here, but I want to talk to him about that, is to write up a flag summary for you. Because out of the 1,000 flags, there's probably just 50 that are actually relevant for users. And we want to work with you to write up a good documentation for those 50 flags and recommend those to you. And all the other experimental flags, that's nice for power users, but the ordinary user doesn't need to deal with them. Code coverage. We also heard yesterday that code coverage is an issue for Bazel. It has, unfortunately, insufficient documentation. There's some confusing flags. Some people would even say they're mystery flags and attributes there. It's unclear how to make this work from Staller correctly. Bazel only handles LCOF data. So what we want to do is fixing baseline coverage. Charles put out 2 documents on GitHub discussions recently. Please have a look, engage with him, and check out his proposal for a new API that would work cross-language, where you specify converters in a new provider, and after text execution, Bazel would call these converters and then merge all the things together. And hopefully that addresses the pain points that were mentioned yesterday as well. Let me finish off with what Lukas recently said is a wild idea, which is not a 10x idea, but a 1/10 idea. So Bazel or Skyframe keep a lot of state in memory. We do that to be incrementally fast. But it's also wasteful at times. We keep a lot of state in memory, and we don't use all that state all the time. So the idea is, let's define a working set. And if we have that definition of a working set, we can use that to decide which nodes in the graph to actually retain and which nodes could be dropped. So the nodes that we would retain are in the reverse transitive closure of the working set. And the assumption is that in the happy case, you're editing just files that are relevant for your working set. And these files and nodes are then enough to keep incrementality and be fast. And in the unhappy case, well, we're out of luck. We have to recompute the nodes that we are missing. In the worst case, redo the full analysis. So that's, of course, very speculative. Talk to us, especially Lukas. Maybe you can raise your hand, our UberTL. I think this is something where we need feedback from you, whether you think this is a viable idea or not. There's plenty of smart people here in the room. And this is not the only place where you can discuss with us. In general, I think we are encouraging you to come up also with ideas like this one, where you say, hey, I have this wild idea. Could we do this in Bazel? Let's have this discussion either on GitHub or Slack or in person the next 2 days or at any other community event. We are one community. With that, let's start with Q&A. maybe I can ask Yun to distribute a few microphones. If you have questions, raise your hand and we will give a microphone to you.
Hi, just on the optimizing Bazel RAM usage. There are some flags to let Bazel manage jobs RAM usage better, but they don't seem to be particularly filled out yet. Can you talk about the trade-off between Bazel's memory usage and the jobs memory usage?
So I assume you're talking about local action execution?
Local memory resource, yes.
Yes,
something like that,
yes. So yes, that's one of the things we also want to look into. So traditionally, we have this resource manager in Bazel, which is used to decide whether to schedule an action locally or whether we have the resources to do so. And that was ignorant of Bazel's own memory usage, and also used a lot of heuristics to decide how much RAM or resources that action uses. And our plan is to make add Bazel owns RAM usage to the calculation, and B, not take the heuristics for granted. So look what's actually happening on the system. Start with the heuristics, but then adjust it over time. There's another question here. Sorry.
Great. Hi. I was just wondering, with regards to sandboxing, have you looked into maybe borrowing a few ideas from the remote execution environment? Because quickly setting up environments with lots of inputs is kind of all we do over there.
I'm happy to talk about that with you, and probably we should loop Pedro in that conversation. Let us know what ideas you have.
Oh, yeah, we can talk about that later.
Hi. So there has been multiple different build tools that is similar to Bazel get released in the last year. So I was wondering if you guys has taken a look at any of them and felt inspired by any of the features that you guys want to bring into Bazel 8.
Of course, we had a look. I think you're talking about bug 2, I guess. So of course we had a look at bug 2, and there are some features which are definitely compelling. Talking, for example, about dynamic depths, which is something that Bazel doesn't have. The issue there is that there's a lot of hidden contracts in Bazel that assume this is all static. So it would be a major project, and we currently don't have a real plan to invest there unless there is like the big motivation why this is really necessary. So we have not seen the need for this at Google so far, but if you convince us, maybe we can reconsider. And if you have other features that you saw where you think, okay, this should be in Bazel, let us know.
About telemetry, are you going to provide like pretty comprehensive legal documentation? Because obviously there's going to be insight from legal teams on that to make that conversation easier to have for teams about enabling that. I'm imagining it'd be some kind of flag.
So we are at the start of the discussion right now. We're not there at the point talking to lawyers yet. Of course, we have to involve lawyers at one point. I think at this point, it's more a discussion with you as a community to figure out what you're comfortable sharing in what forum, where, and we want to have this discussion later in the BOF session and hopefully come to an agreement that helps both you and us. It's really also helping you guys if we understand what's the feature adoption, for example. And then at a later step, we find out what's the legal framework and how it's going to work.
What's the roadmap for C++ module support?
I
And
don't
not
know.
LLVM modules, but proper C++ modules.
I can't answer that question. I don't think Evo is in the room right now. So bump later into Evo and ask him that question.
I'm asking because it dominates my uncached CPU time, basically.
Okay, well, that's a fair point.
Hi, I'm Yi from ByteDance. Just curious about, is there any more official stance or sort of semi-official working relationship with Apple? Because there has been, I've seen a lot of people doing hacky stuff in that area. So just curious if there's more like official collaboration.
I'm not aware of any official collaboration there. Maybe John can answer this question.
There isn't official collaboration. We know folks at Apple. We talk to them. We have a dedicated team at Google who works on all things Apple, including our contributions to Apple Build. It's a complex space. I wish we had a nice airtight contract that said, you know, whenever Apple does X, Bazel will do Y to track X. It's not that simple. But we do our best to listen to requirements in this space. We bring them to our colleagues at Google and Apple who work in this. So let us know. But it's complicated, right? So talk to us though, and we'll do our best to help you.
Very quick, sad one. Any investment in Windows support?
Actually, at the current moment, we don't have a big investment into Windows support. We do some critical bug fixes if they arise. But I mean, if you're interested in helping out, that's very welcome.
Not loving it.
I guess I can also say something, but there's no active like involvement in developing new features. For example, sandbox support for Windows, but we'll promise not to regress any support for Windows. Like if someone develop a new feature for Bazel, it should work on all three platforms, right? Yeah, but I know Windows has been difficult. Our test coverage hasn't been so good compared to other platforms, but we'll just keep it running. But if you are willing to contribute, very welcome. We'll take your PRs. Yeah.
Hey, thank you. Oh, there's one more question. Okay.
All right, maybe this is a little bit off topic. Our team is very happy with Bazel and we earned a lot with it. But what about developer IDE tooling support? More closely, VS Code extension, which feels a little bit abandoned at this point.
This is some of the things that we cannot support. Like this is something where we would ask you as a community to own that, to own the plugin support for IDEs. Hopefully, the build server protocol makes things easier, as we heard yesterday, to write once and use it in multiple IDEs. Okay, with that, I'm handing the stage over to Benjamin from Enchflow for the next talk.
All right, thank you for the introduction. Good morning, everyone. I think I think because my body is very well acclimated to some unholy combination of Eastern Australia time and California time, which brings up nice thoughts of tropical Pacific islands, especially given Munich weather today. But at any rate is quite distant from UTC +2. So if I say something that doesn't make sense, it's me, not you. And I think you're all, I'm happy to be here at my 7th BazelCon. And I think you all should be very happy to be here too, because I understood the tickets for this event were slurped up quite quickly and the secondary market was totally vicious. So I hope you didn't have to like injure anyone to get in here. Yeah, I work at Enchflow. I've given, and we kind of specialize in road execution and visualization of build results with our build UI. This talk is not really about that, but I'd be happy to talk to you about those things too. And It's great, again, also to be in Munich despite the weather. You know, I thought this would have happened a lot earlier because, you know, half of the Google Delays team is here in Munich. But recently I was looking at my Bavarian holiday calendar, and I realized they must have so much scheduling difficulties to like get enough contingent stays to actually have a conference, because there's just so many holidays here in Bavaria. Like just to give you a sample, right? There's like the normal like Western like sort of like Christian ones like New Year's Days and Christmas, and then there's like weird ones which you probably would only know if you are a Catholic, like Maria Himmelfahrt. That one is also a favorite of 10-year-old boys learning German. And there's also extended musical performances, which you can't, and of course down here there's the famous Oktoberfest, and we're just kind of getting out of the consequences of that. So, but yes, I'm glad that we finally managed to schedule this to come here and talk about build tools, and one in particular, which historically have been kind of a sad, neglected space, which is strange because almost anyone in software engineering has to deal with build tools constantly, but we don't want to talk about it. It's just kind of a lot of sublimated rage. And like here's a quote about that. Build systems are sadly an unloved part of the software ecosystem, very much a means to an end and seldom the focus of attention. So this comes from the introduction to a paper called Build Systems a la carte. So when I first saw this title, I thought it was going to be an anthropological study of every single medium-sized company that I've worked at, where it seemed someone early on had gotten a menu of build systems and then ordered every single one. But I think that would be a very interesting paper to read, but it's still yet to be written. Instead, this is a paper that surveys a whole bunch of build systems from Make to Bazel to even Excel, which you may not have known can be construed as a build system. And the authors sort of figure out in a crystalline way what the goal of a build system should be, you know, like correct incrementality, and they figure out how all these build systems have to work in order to achieve that, and come up with sort of the theoretical underpinnings for build systems. So it's a very clarifying paper to read if you have spent any time working on build systems. There's some very nice ideas in there. I think we even have a author attending BazelCon. So Neil, are you here? Hi. Good work, sir. You might also see, if you, like me, spent a lot of your youth in the toxic cocktail of Ayn Rand and Haskell. One of the other authors is one of the Haskell Simons. Great paper, but I have to say there's parts of it which just make me cackle. Like there's quite a lot of it is devoted to classifying build systems into applicative and monadic build systems, and what that means. And when I get to this next part in the paper, I always laugh because one of the things they do is re-implement all the build systems they discuss in terms of their little Haskell framework. So you come to this, which is the Bazel reimplementation, and like, oh, I mean, you know, 3 lines of Haskell to reimplement Bazel. Like, why do we have hundreds of thousands of lines of Java? Let's get rid of that and start using this. So this is very, very elegant. I also really like the subtitle of the Build Systems a la carte paper, Theory and Practice, and I think those are 2 concepts between which the interplay is very interesting. You know, sometimes we have a whole mess of things, practical systems that we use, and with a few clarifying theoretical insights, a lot of what we have to do in practice can be simplified. But at the same time, when we are working in practice, building systems, sometimes those elegant theoretical ideas don't translate quite so cleanly into the real world. And I think there's a lot of interesting play between the joints, and I like to look in that. So this talk has kind of a similar meta structure to my one last year, where I find something just that I find interesting about Bazel, and I pull on that thread, and then I see what we find. So last year I was talking about this weird misfeature called shared actions, and this year I'm going to talk a little bit about a Skyframe, which is a much bigger topic, and you could talk for 45 hours straight about. So it's just going to be kind of a little core sample. But I keep in the back of your mind this idea of theory and practice, and how those two talk to each other. In practice, you always have to worry about error handling and user interfaces and performance and memory usage, especially memory usage in the context of Bazel. So you may have seen in the previous talks, John and Toby, memory usage of Bazel is something that clearly preys on the minds constantly of Google engineers. And I have this theory that in the basement of Google, there's a whole army of gnomes who spend their days looking at heap profiles. Lukash is the gnome. Yeah, looking at heap profiles, and they scratch their long white beards, or Lukash's short, attractive beard, and they say, if we spent 3 months refactoring this subsystem, we could save 0.2% memory. And then someone's obliged to spend 3 months refactoring that subsystem. And so I didn't realize there was all these talk about memory usage, and I'm sorry for making fun of the little gains. But of course, if you do that enough, you can achieve some impressive overall usage. So John says that there's 25% reduced Bazel memory usage. I saw this comment in GitHub where someone said it's more than 30%. I'm not sure which one is the true one, but incorrect. So congratulations. I'm sure the rest of the alphabet soup is frantically working to cut down that margin, but enjoy your temporary victory. That's the nature of developer tools. All right. So the topic of this talk, Skyframe. So I feel like this is a thing that most Bazel users know by name and stack traces, which are printed to the console. But if it turns out, if you go and type this into Google, you'll see that the people who have the best SEO for Skyframe are this place that makes glass sliding doors. And they're actually not, they're located in Switzerland, like a few-hour drive from here, in a place called Frauenfeld. So this is, overall, I enjoyed looking at this website. There's like these classifications of sliding glass doors. There is one thing which really upset me, though, which is that apparently like the marketing language that you use for sliding glass frame doors is exactly the same for technology, right? So Skyframe sets new standards of technology. In cooperation with universities, Skyframe continuously strives to develop new innovative solutions from which the basis of truly visionary ideas for timeless spatial concepts. Like it's just like marketing gobble. Like you could be selling Bitcoin or like build tools or any sort of thing with like, did they get Mark Andreessen to write the copy for this? So after you're done feeling enraged about that and you like type Bazel to your search terms, you'll eventually find that this is the thing which has like a nice overview page somewhere in the Bazel documentation. Basically, the gist of that page is that Skyframe is the parallel evaluation and incrementality model of Bazel. So in some sense, it reifies the ideas that are from the Build Systems a la carte paper for Bazel. It's the part that makes Bazel a correct incremental parallel build tool. And so to kind of ease you into like what Skyframe actually looks like from a Bazel internals perspective, I wrote a really silly implementation of Skyframe in Python. So my implementation of Skyframe here is on the right of the slide and in this evaluate function, and you can see it's very simple. Basically, you pass in something called a key, which you want to evaluate, and then we check to see whether the key is already in the data dictionary, and if it's not there, then we compute it and stash in the dictionary. So it's basically a little memoization function. And then over on the left-hand side, I have my computations that I'm going to use in my little SkyFrame here. And so I have two computations. I have the file key computation and I have the concat files key. And so the file key has an argument, which is a file name. And then when I compute it, it just reads that file and returns that as its result. And then I have the concat files key computation, which takes two file names as its arguments and returns their concatenated contents. And the interesting thing about this is it does that by recursively calling into the evaluate function with the file key computation, which is able to return the contents of files. So sort of the idea is once I've done one of these computations, it's kind of cached in the data dictionary, and I never have to do it again. All right, so this is like the core idea of SkyFrame. And if you go look at like the implementation of SkyFrame into Bazel, like you'll see that it's 15,000 lines of Java, and this is not even the test. And you know, Java famously has a lot of logorrhea, but that doesn't account for all of it. And because in real life, in practice, you have to do quite a lot more things than my silly Python implementation. So among them, you have to worry about concurrency and detecting cycles and how to invalidate things that change and error handling and replay messages and batching and blah, 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 garbage collection. So all of these things have to be in play at once in the Bazel SkyFrame. And to give you a sense of what it looks like actually in Bazel using the real SkyFrame, here is what my concat files function would end up looking like in SkyFrame. So basically in SkyFrame, it's a framework for building a graph of computations. And each computation has some inputs, and then the computation does some work and produces them outputs. And in the course of doing this computation, it can depend on other computations in the SkyFrame framework. And that kind of induces a graph structure on the web of computations. So in the concat files function SkyFrame real version, you can see we still have this compute method, and rather than calling evaluate, we're past this class called SkyFunctionEnvironment, which has a useful getValue method, which we can pass other Sky keys to. And then finally, at the end of the function, we again concatenate the values from the file subkeys and return a result. You can see there's also these null checks, which makes it look like someone has been wanting to write Go in their Java. And it seems a little like line noise, but this actually gets to a very key implementation choice that was made in SkyFrame. And that arises from, if you're implementing SkyFrame, what do you do when a value that someone requests is not yet available? So in my evaluate function, it just recursively calls in to get the value that's needed, essentially blocking the caller. And that is certainly an implementation choice you can make. But when you have tens of thousands of these computations in flight, you don't necessarily want to be blocking OS threads or having tens of thousands of OS threads. So that's kind of a limitation. And so what you can do instead is you can just tell the caller, sorry, I don't have that yet. We'll call you back later. And so that's what SkyFrame returning null means. And so if you are writing a Sky function and you get null back from SkyFrame, you have to return null yourself, and SkyFrame will call you back later. And that operation is called a restart. And that has a lot of implications, which I will discuss a little bit more of later because it's quite an interesting topic. And just again, to emphasize how similar my Python implementation was in a way, was that like all of the data of SkyFrame is ultimately stored in a giant map called known map, just like the Python implementation buried there in memory graph impl. All right, so let's talk about how Bazel actually works on Skyframe. And to do that, we need to discuss a little bit of a fiction that Bazel tells you, which is the notion of Bazel phases. And so you may have absorbed some of this from Bazel documentation and other talks. Bazel says it has 3 phases: loading, where packages are actually, the build file is parsed, and you get a list of targets. And this is the thing that you can look at if you run Bazel query. And then there's analysis, where rule implementation functions are actually run and actions are created, which you can look at using cquery. And then finally, there's execution, where Bazel shells out, calls remote execution systems to actually produce the artifacts that you want in the build. So why do I say this is a polite fiction? Well, my understanding is that the original implementation of Bazel, like these, were actually all very distinct phases with like separate implementations. But it's kind of bad for performance to actually have like these synchronized points in your build. If you're building 2 unrelated things, like you don't need to wait for the loading for one to start doing the analysis or execution of another. So shortly after Bazel was released in 2015, change was actually made to allow loading and analysis to happen in parallel. Yeah, that was also work. Then recently, it was much more complex to merge execution into these 2. I think it took about 2 years at least to do, but that flag was finally flipped a few weeks ago to allow execution to happen in parallel with all these. So it's basically a lie that these are distinct phases, but because Bazel had like exposed these implementation details essentially for such a long time, Bazel kind of has to pretend to have these separate phases. It's still kind of useful to think about it when you're talking about the Skyframe, Bazel on Skyframe implementation, because each phase essentially has like a core Sky computation that is actually implementing its functionality. So in loading, there's something called package function, which basically takes in a package and produces a package object, which has a list of targets and a bunch of other data about the package in it. And analysis, there's something called configure target function, which takes in a label and a configuration and produces a configured target. So the providers of the target and also its actions. And then finally in execution, there's unsurprisingly the action execution function, which takes in some actions that you want to execute and produces their artifacts by actually running the user actions. And so one other comment is that I've been talking about Bazel on Skyframe, and sort of Skyframe is the abstract framework. So it's like a separate Java package. In theory, you could like implement your own spreadsheet application on it. But my understanding is that Bazel on Skyframe and Skyframe are independent in sort of the same way that Belarus is independent from Russia. Like, not you know, Skyframe knows its master. So, one thing I did want to dive in a little more about is restarts, and one thing immediately that's a little bit interesting about Skyframe is that, or restarts, is that while most of Skyframe is very much hidden by Bazel, again, except for stack traces, restarts do show up in the UI, at least historically, in one place, which is external repository fetching. So I don't know how many of you have actually seen Bazel printing out restarting. And that actually means that the Sky function that evaluates external repositories is going through a restart. And so not only is this unpleasant because that doesn't sound like a thing that should happen when you're downloading stuff or unpacking, but sometimes it could also mean that you would actually refetch archives multiple times, so it would have pretty negative performance implications. And that was also pretty recently fixed an experimental mode was added to maybe fix it. Okay. So I have the Bazel team up here like telling me that nothing is good. So people are thinking about it, right? Yeah. Okay. Okay. The other thing about restarts is that they have this almost theoretical problem, which is that if you have, say you have a really stupid Sky function like this, the concat many files function you got tired of too, where you basically fetch tons of files and at the end you finally concatenate them. Well, suppose none of the dependencies are available for this function the first time it runs. Then you'll find out that you need the first, Skyframe will find out it needs to fetch the first file, and then this function will be suspended, and then it'll be called again, it'll get the first value, but it won't, then Skyframe will learn about the second value, and so on and so forth. And so this is kind of like a classic way to get quadratic behavior. And of course, many Sky functions are not written in such a stupid way. And Bazel got by for a very long time, just kind of ignoring this problem. But eventually, about 2 years ago, someone added a formal way to cache state across Skyframe restarts. And the way that works is that there's this other method on the Sky function environment called getState, and that returns to you either a new state object if this is the first time you've been called, or one that's been cached if you've already been run, and you sort of get to define your own state class for your Sky function. You can put whatever you want in there, and then you can, later in your Sky function, you can see if you've already computed something, and if so, avoid doing work. So one thing that's a little sad is, we're keeping more memory around, which means the memory gnomes will get upset. So this change also was accompanied by one to drop the state if Bazel feels like it's under memory pressure to keep the memory gnomes in the basement happy. But of course, this seesaw can go both ways. The other thing I find funny about this is that Nathan clearly does not live in a country with enough holidays. Poor guy. Who doesn't love spending Boxing Day writing Skyframe patches? Yeah, so as I said, the seesaw goes the other way, and eventually someone earlier this year had to add a way to limit the number of times the caches are dropped due to memory pressure, because otherwise it wasted too much CPU time recomputing things that could have been cached if you weren't dropping the caches. So this is a beautiful instance of practice being very messy. The other thing which is a little icky about the Skyframe state thing is that for complex Sky functions, which of course the ones you're most interested in caching the results in, you can have these very long state structures. Of course, there's a combinatorial explosion of the number of things that could be null or non-null in the state function. And so it can be very difficult to figure out what would actually be available on the state function after a particular set of restarts. So another thing that happened this year was the introduction of state machines for Sky functions. And I have to, whoever wrote this, wrote the most beautiful documentation for it. It's better documented than most Bazel external or user interface things. It's this beautiful document with a tutorial on how to use state machines. So I just want to spend several minutes almost praising this, because more people should do that, and it's such an exception for much software that its internals are documented this well. But basically, the state machine is a way to express, using the state machine abstraction, of course, all the computational states that your Sky function can be in. Of course, in Java, you need to have lots of classes and callback to do this. But basically, you end up define a state machine and has a step, and then the step can depend on sky values or other state machines, and then when those are done, you get to accept their results. So it's a much more structured way, and it ends up breaking up those giant state classes. I don't actually think that readability was the main reason that this thing was introduced. It also solved some like very obscure problems with artificial synchronization points in sky functions that were hard to fix otherwise, but I found the readability part to be quite an improvement over the old states. It also, in the documentation, it has this really interesting diagram, which is supposed to, I think, express how you can have a whole tree of state machines connected to each other. To me, this looks more like a really difficult IQ test or a really futuristic design of a sliding glass door. My final kind of observation on all this, as I was thinking over this, in conclusion, is that we have all these things nested with each other. We have state machines in our sky function forming a big tree, and then that's running on top of SkyFrame, which is kind of this parallel evaluation framework, which you couldn't fit into a state machine sort of extension. Of course, this is all running in the JVM, which is translating bytecode into machine code for the microprocessor to use. And microprocessors, of course, are notorious for doing their own set of magic and translations behind the scenes. And of course, finally, there's the operating system, which is running all your threads and so forth. So apparently we can just not help ourselves in putting more machines inside of our machines. And it's turtled all the way down. Something I find pretty interesting. And with that parting thought, I've been asked to leave a few minutes for Q&A. And if you celebrate Reformation Day, happy Reformation Day. Thank you.
Hi, if you would start from the beginning of implementing SkyFrame to be written in Java, how would you structure the code to be easier to restart and not to have memory issues?
Well, until very recently, as John was mentioning, Java did not have lightweight virtual threads, and so that's a thing that you could think about using instead of this restart architecture. I mean, and that's it's not even a given that would work though, because like if you have a virtual thread, then that's like a whole stack that you have to keep in memory, and we know using memory is bad. So I think that would have its own issues. And there's also if you have a language which has stackless coroutine transformation, for example, Rust, you can use that to have a similar sort of virtual thread kind of architecture. So those I think are your main choices, and they both have very important trade-offs.
And one question about it, like, would it make sense to make like a byte code machine for the SkyFrame, or it would not simplify things?
I think that most SkyFrame's computations are sort of large enough that the amount of time that you spend in SkyFrame, or I guess it depends on what the reason that you were doing that it would be. I'm not exactly sure.
I'm just asking if it makes something simpler. No?
Oh, I don't think it would make something simpler. There's someone behind the pillar there.
Could I ask, Benjamin? Just a few years ago, I think you referenced to SkyFrame before, and I think you mentioned that. Hello. Hello. It's just Anyway,
I'll
a few
repeat
years
it.
ago, you referenced Skyframe, and you said that you heard somewhere that inside Google, that conversation is already on the server. So have you figured it out? And feasible at all, or just
Yes. Okay. So the question was, I mentioned several years ago that there may be another implementation of. Did I mention that at talk, or was I just to you? Another implementation of Skyframe where Sky stuff can be like cached remotely, or it's running on the server side. I would say one of the funnier things about Skyframe is that many of the classes within the Skyframe framework have a comment which says only public for use in alternative evaluator implementations, and there are no alternative evaluator implementations in the Bazel repo. I kind of feel like I should not say more on record. There is a keyword called skygraph, though.
All right. Did you have a chance to look at the other implementations of Blaze that maybe are also using Skylark or Starlark, how they are doing this stuff?
Yes. So, and I mean, actually, you should look at the build systems a la carte paper, because this is one of the major things that is discussed, and they kind of figure out how every build system is doing it. So, for example, a Buck2 uses async and await in Rust, which is kind of the Rust compiler then is providing the stackless coroutine transformation. But the other thing is, like, memory is a universal problem for everyone. And I saw someone was busy like optimizing the size of closures in Buck2. So, you know. All right. Well, thank you very much again for your attention. And I guess we get a break now.
Thanks, Benjamin. Now it's time for a break. There will be coffee all around. So you can get coffee here, you can get coffee in the first floor and in the sixth floor. You have to decide what you want to do next. Up next in this room is multi-platforms built with remote build execution. And in Isarwali, sixth floor, there's the BF session around telemetry.
about Bazel and RBE, right? That's a wonderful job. I have no complaint so far. But yeah, I'm very biased. I think BuildBuddy is the best in the market, right? As a customer, you're gonna save a lot of money talking to us. So yeah, one day a customer came to us and say, "Hey son, we got a bunch of Windows CI machine lying around, and they're already using BuildBuddy for Linux. And is it possible to convert some of these CI machine, bare metal, right, into BuildBuddy RBE worker, which is our BuildBuddy executor, instead of running local CI for hardware optimization, because bare metal is very expensive, right?" And we went to work. So yeah, BuildBuddy will start support Windows RBEs very soon. We are currently testing it internally, right? This is on top of our existing Linux and macOS support, and it will be released pretty soon as a standalone build. But today, I'm not going to talk about Windows support. I think Angelo folks going to have a really dedicated session about Windows sandboxing tomorrow. I'm excited for that, right? What I want to talk to you about today, which is supporting Windows on BuildBuddy executor in our existing code base, does come with some cost, right? It's not free. First of all, it's an additional platform. I will talk about platform a little bit later, but it's an additional to support on top of our Linux and macOS for the build and release matrices. Second, we have to introduce a new set of specific Windows-specific dependencies, right? And in the future, maybe more, because we need to support better sandboxing for Windows as well. Third, most engineers on our team don't use Windows day to day, right? So it's really hard to test and to develop Windows-specific features. So yeah, these are some of the challenges that we are running into today. So these are CI/CD pipelines currently. They are very specific to Linux and Mac OS, right? Each of these run on separate platform, which is Linux or Mac OS, or some enable RBE, right? And if you take a really close look, these are actually graph, right? These are not really CI/CD pipeline. From a zoom out perspective, they are actually graphed. So I went to thinking, why don't I just convert them into Bazel graph, right? We just heard about Skyframe. Should be easy, right? So yeah, if we could just introduce a single node, right, convert everything else into nodes in Bazel graph, then I could just do everything in Bazel. What is so hard? So I went to do some research. I opened up Bazelarium, which is essentially our development documentation. And in our development documentation, there is a secret incantation that is not very well known because we don't use that very often. But this was written by the core member of BuildBuddy long times ago, right? And this bash command essentially let you run a build from a Mac laptop on Linux remote executor, Linux environment remotely, right? And this was really new to me because when I onboard onto BuildBuddy, I can only build the entire repo on my laptop locally. Like I could not build it remotely on Linux. So this was very new. I was like, why don't I use this every day, right? So previously, I took it out for a spin. I tried to run the command, right? Previously, from the same Mac M1 laptop using this new set of Bazel flag, I was able to build artifact for Linux, run tests against Linux environments. Better yet, I could run most complex integration tests that we have against real database, Postgres and MySQL, because we run most stuff on, we run those complicated integration tests on Firecracker micro VM, right? And these are faster too, right? Over my local Mac M1 laptop. So with RBE, I could build all the target, test all the targets, run integration tests in Firecracker. A clean build and clean test is a lot faster compared to my local MacBook. Guess why? Because we have a lot more CPU to spare, right? Over on the RBE side, I was running with 1,500 cores compared to my M1 laptop, 10 cores. So yeah, how does this all work? What do this particular flag do to enable this magical experience that I could just use 1,500 CPU core for a single build within a few minutes, right? Is that all you're gonna need? And this led me down to a long path of reading and researching in different Bazel primitive and how they fit together. And yeah, there's the main topic of the talk today, Bazel platforms and friends. And yeah, disclaimer, not everything I'm talking about today is rebuilt, right? Some of them have yet to be built, and hopefully we will be able to finish by the end of the year. So first of all, let's talk about platform, right? Platform is actually a set of a collection of constraint values. What is a constraint value? A little bit on that later. Execution properties specified by the users, right? These execution properties will then later map to our remote, to our RBE action scheduler to schedule the action execution on the right hardware machine, on the right workers. Right, so that's what execution properties is normally for. Here you can see is matching, is telling the scheduler to match the action of this platform with a Linux machine with different isolation options, right? We support Docker, Firecracker, Podman, etc., and container image, which is like the image that we're gonna convert into a Firecracker file system, so that we could run your action on top of it. Straightforward enough. So what is constraint value? So we need to start with a constraint setting, right? And constraint setting, you can think of them as enum, right? They are used to describe the underlying properties of your execution system. For example, if you're running some stuff on different OSs, right, on a different CPU, compiler, linker, then your constraint setting will be an enum for each of these types, right? Then you have constraint value, which are the value of the previous enum, right? So for example, for a constraint setting for operating system, you can have different constraint value, Linux and Windows, CPU, x86, ARM64, etc., right? And yeah, Bazel platform is a combination of these values grouped together, right? It represents the underlying system of the execution, and it let rules author declare the requirement of the execution on top of your build file. Right? And yeah, rules and toolchains consume this value later. Click. Clicker. Hello. My clicker doesn't work because my speaker notes might be too long. Just 1 second. All right, I would use a laptop instead.
You want me to stand here and
all right, yeah. So yeah, how does platform work in practice? In the good old day of local execution, you have two scenarios. The first one is very straightforward, right? You have the host platform and the target platform, right? You compile a binary on Linux, and then you can run that binary on Linux. It's very typical. Later on, there would be folks who want to develop for Windows and Mac OS, but don't have the CI budget for Mac OS lying around. So we invented cross-compilation, cross-build, right? So you can use a Linux machine with the right toolchain and the right SDK dependencies to cross-compile a binary and cross-link it targeting Windows and targeting Mac OS, right? So these are cross-built. Now, with remote execution, these are a lot spicier. Now, the execution does not happen on your own machine, right? You have the wide range of flexibility to choose which kind of platform you run your action on, right? You want to run your build on. So you can basically stand from a Mac OS laptop, execute your action, your build on a Linux platform, targeting either Linux, Mac, or Windows, free of choice, right? So things get a lot spicier and more interesting. So go back to our original desired build graph. Theoretically, you can actually construct a multi-platform build graph using host to exec cross-platform, right? Because purple over here is essentially, let's say, is my Mac OS laptop. Then all these orange, blue, yellow, green, whatever, is a different execution platform running remotely on a cloud server somewhere. I should be able to do that, right, theoretically. And then later on, maybe I can introduce different interdependencies between different platforms. And a lot of these being, some of these are even being developed as of yesterday. I was looking into Skylib and, sorry, the platform repository, and I saw some sign of this from Bazel team. But yeah, what is stopping us from accomplishing this? Problem number one, toolchains are hard, right? I was the person who created a GitHub discussion on how we are missing default CC toolchain that is hermetic and easy to use. Right now, there's no such thing exists. Bazel toolchain is very complex, especially Java and CC toolchain in general. Moreover, these toolchains are mostly made by the preconception that host platform and execution platform are the same thing, right? But with RBE, that assumption is no longer whole. We can actually use a lot more, effort into improving this entire ecosystem in general. And yeah, many rules only register host toolchain because they relies on repository context OS to detect the current host toolchain to set up the toolchain. So yeah, if you're not familiar with toolchains, then this is a pretty good example of how it works. Ignore the gray out stuff. Only the highlight stuff is important, which is a toolchain would often have to declare itself that is execution compatible with a certain set of constraint. Those are constraint value, and then target the stuff that it produce would be compatible with different platform, right? So having these values right is very important. Yeah, aside, you can find, yeah, these help Bazel automatically select the right toolchains when you want to execute. This is a pro tips, right? If you're setting up a toolchains, copy what RulesGo is currently doing. In RulesGo, it's very flexible. You can register multiple set of toolchains, right? Each gonna generate different set of execution and target compatibility, and all these toolchains will be registered to Bazel, and Bazel will pick these toolchains automatically. And the best part, these are lazy loaded, right? So if you don't use them, they will not get downloaded, and therefore your build is still fast. So you can theoretically declare 100 set of toolchains, right, and use only one of them, and you would only have to download a single one. So yeah, register more toolchain. Please don't register your toolchains using repository context.os, because these come with the specific implication that the execution environment is the same with the host, right? Which make it really hard for remote execution to adapt. Pro tips number 2: avoid execution to target execution and target differences in cross build. The reason is that with remote execution, you can actually just set up multiple different execution machines and then produce the target there, right? So previously, you would have to cross-compile. Let's say you're targeting Windows, you're gonna have to download the entire toolchain and compiler for Windows. I think Windows has a very specific CC compiler that you need to download with the entire glibc that is compatible with that, and then you cross-compile it on your Mac OS. to a Windows machine, right? Now you don't need to do that because setting up a remote worker is really cheap, right? So you could just theoretically spin up a Windows VM, run a build there, and automatically scale it down so that you no longer need to use it after a while. Obviously, this comes with the implication that you need to be very familiar with RBE system. So yeah. Another food gun is we run into specifically some of the old rules that have not been platformization, like CC2Gen Suite, still rely on some of the old flag, like minus CPU or host CPU, right? Or cross two tops, right? So if you run into these problems, consider setting CPU and host CPU specifically to make all of these works. Yeah, we run into this as well because these are predate the platformization of some of these rules. Another pro tips, enable, this is actually an experimental flag. I think there will be a talk after mine that is specifically about this, but experimental platform in output dir. What this is gonna do is that it's gonna change the naming convention under your Bazel out directory to include the target platform inside it. And the nice thing about this is that you can actually switch between local execution and remote execution seamlessly, so that, let's say if you're offline, you're on a flight, you don't have internet, you can still build locally, right? And then when you are off your flight, you can enable internet connection again and build remotely, all within the same Bazel JVM without like having to discard your entire Bazel out and then rewritten them again, which is expensive. Right? Yeah, and next talk, I think Fabian and Bazel team will talk a little bit more about this. Oh yeah, this is my favorite. Set UI action zone, because you are using RBE. You should be able to see more, right? So yes, this just increase the length of your terminal output, which personally I think it looks better. Our pro tips, use BuildBuddy. We have great UI, right? We display the, no, seriously, we do have a customer who find our UI very valuable, especially when you execute your action remotely. We provide the entire sandbox telemetry, so you know what's going in and out of your action, so that you can actually troubleshoot cache misses and missing input, slow execution, cache poisoning, that kind of thing. We even record everything that goes in and out of the remote cache, and then we display it back to you so that you could have greater telemetry into that. And yeah, all the timing profile and stuff for remote execution. So yeah, what is the application of multi-platform builds today? Oh, my emoji is not rendering, right? Yeah, so multi-platform build keep developer really happy, right? I'm using it on a day-to-day basis. It's really fast. It helps me run the most complicated tasks without having to push the CI to run it for me, right? We have seen customers who are leveraging this to run a range of mobile device, like different Android SDK, iOS smart watches, smart TV, etc. Right? You could leverage Bazel to set up the most complex build environments out there, right? Another trend that we have seen is that there are a lot of companies with custom hardware, that is commodities, AI companies, right? Machine learning, or custom microcontroller with FPGA. Those could be defined at the platform, and Bazel could help you run that using remote execution. And that's about it. That's my talk. I will be taking some questions if there's any.
Hi, thanks for the talk. I was wondering how big the impact of like the network latency and bandwidth is, and for example, how would it work with a distributed team? Would you need multiple like builders distributed globally as well?
That's a really good question. So let's take it one at a time. What is the impact of network latency? I It depends, right? As most answer to this kind of question, it depends on your scenario, it depends on your situation. But with built with other bytes, it's very minimal, right? Because you already load everything in your local setup. It's just a matter of you having to upload your input to the remote execution platform. And most of the time, it's going to be the delta, which is what you have already changed locally, right? So yeah, it's very minimal. For global distributed team, that's a very good question. It's challenging, right? We have heard from several different customers about using different remote cache system, trying to synchronize between them what is the right source of truth. To be honest, it's really depend on your constraint, right? It's like, if you look at remote cache and remote execution, that's from a scale, it's actually a database, right? So everything, every constraint that apply to a distributed database apply to the remote cache. And yeah, you're gonna have to scale it the same way, which is, you know, cap theorem, that kind of thing. So yeah. Oh, for the camera, hello? Oh, question.
Hi. BuildBody is offering products for remote caching, remote execution, and the UI you just showed. I'm always wondering like how the adoption rate for those features of Bazel is. And for sure, you only have the experience with your own customers, but could you share maybe a bit like how many are using remote caching versus remote execution versus the build event protocol? Are those adopted at the same percentages, or are, for example, a lot of people using remote caching and remote execution is not that much used?
That's right. It really depends on your use case. We have, as I shown earlier, we have a wide range of different customer from the semiconductor industry, banking, right, even internet company, right? So depends on your use case. You see different usage pattern. Depends on what rule set you are using. You also see different usage pattern because some rule set actually don't do RBE at all, right? Some rule set like stuff related to Apple is very expensive to run RBE, right? Because you actually have to run it on Mac OS environment, which we actually manage, right? So it's hard to comment on that. In general, what I would recommend customer usually do is that try out the BES, the build event system first, because it's the easiest to onboard. You only send us the telemetry that Bazel emit, right? And that is usually very anonymized. We're especially comfortable for companies that are not used to sending source code to a remote system, and then remote cache, and then remote execution. But yeah, it really depends on different use cases. I think we have 3 more questions.
Thanks. You had on the definition of a platform, you had the CPU and OS as a target compatible with, but you also had target settings. I wonder if you have any advice on when to use which one to represent like what a particular target platform offers or has to offer.
Oh, this is really good. To be honest, we are still in the process of figuring this out, and we are discussing this internally just like a few days ago on a PR that you could go and read. But essentially, the idea that we want to move forward with is that we want to make sure that all of the properties that we are offering on our remote execution platform is implementation details. And then we want to encode those implementation details in exact properties. And then we're going to provide a set of config setting and config value. Config setting, constraint setting and constrict value. I keep getting those messed up, to higher level user. So for example, we run isolation sandbox on Firecracker, Podman, Docker, Bash Shell, etc. Those are implementation details, right? On a higher level, what user often interested in is, can my test, is the execution environment have a Docker daemon for me to run Docker Compose for my test? That's a big use case for our customer, which is running Docker Compose in a Firecracker micro VM. So we want to provide that as a higher level API. So we are still iterating through this design. It's not yet set, but I think that's the high level idea. Thank you.
Yeah, maybe it goes a bit in this direction. First of all, thank you for the talk. For the platforms, as you said, there was before this cross tool top, and basically like now we have a new way. But still, it's a little bit intermingled. Like you still have some very corner cases where you still have to rely on the old behavior. And basically also like in the last Bazel versions, there has been quite some cleanup where some places it was called host, but in reality it was the exec platform and stuff like that. And basically I wanted to ask you like, first, like how happy you are with the current status now. I think that quite a lot has been done. I think that there's one last step missing, but I wanted to know your opinion on that. Yeah, and then basically it's like, do you know if there are any plans, or I don't know if you have been talking to anyone from the Bazel team about finally getting rid of the all platforms topic?
Yeah, this is a really good question. In general, we are still going through the platformization ourselves, right? So the details has not been yet set. I'm pretty happy with it, right? I was able to get rid of all the cross-tool tops and host CPU and all those flags in favor of just registering a set of execution platform in the extra execution platform flags, right? And you could also register it in your workspace, but I find it less dynamic. We could talk on Slack about that. We don't have, we have yet to talk with the Bazel team about what their plan is, but in my general assessment, I think we need to do something about the CC2 chain on the side, because that's very difficult to set up in general. There's not a lot of good documentation about it. So a lot of things are just like magical incantation as far as I can tell. So yeah, if we could like work something out as a community to support that, because I'm pretty sure Bazel team has yet to set a target on that. So yeah, I think it needs to be community-driven effort. We have been, to be fair, we have been looking into Uber Zig CC2 chain. It does have some of the problem I described, which it used repository context.os to register itself, but I think that's fixable. And yeah, it's going to require some work. Yes, please.
In the interest of time, I think
yep.
to wrap up, and please find your
yep.
speaker if you have other questions, and hopefully some of your questions will be answered in the next.
Yep, thank you.
Works. Yeah, I think it might have been the speaker note situation.
Okay.
Okay, great. Okay, thank you for that talk, and thanks for all of the questions. The next talk is going to be about faster cross-platform builds by Fabian, Ara, Greg, and Tiago. It is works. Forward.
Hopefully this will be a nice complement to the last talk. If the last talk is speaking about Bazel's ability to integrate builds with different kinds of platforms and all different kinds of ways, and the state of that and how well that works and how that doesn't work, this talk is focused on some inefficiencies in the performance of this model and things that we're trying to do to maybe address that and help that a little bit. So obviously Bazel users are fairly, I think, enthusiastically trying to do builds, Bazel builds in all kinds of different multi-platform environments of all different variations. But they have noticed some surprising inefficiencies when they try and do these builds, that they don't always operate as quickly as they hope they would. There have been different, I think, specific reports and sort of kinds of complaints about things that are going not working as expected when doing their builds. But I think the general sort of binding pattern across all these complaints is trying to do the same sort of build, mixing platforms, either the platform that you're running the builds on, or the platforms that you're targeting the builds for, that you're trying to build your apps for. And especially trying to do that with technologies or languages that are ostensibly platform independent, where this sort of thing shouldn't really matter for those languages. Like Java is a very prominent example in Android. So I think what users reasonably expect when they're building, say, platform independent languages across multiple platforms is that you should be able to mix and match platforms, and you shouldn't have to do extra work for those languages because, again, they're platform independent. None of this should matter. In practice, it does matter, and users do see that build work is redone when it doesn't seem like it should have to be redone, and that causes, I think, fair complaints and dissatisfaction. Why do Bazel users even care about any of this in the first place? I think probably one of the most common scenarios that I've seen looking around on GitHub is development shops where the developers are working on MacBooks. I think this is being referenced a little bit in the last talk as well. And they like to have a system where they could run cheaper CI systems using cheaper Linux machines, run the CI systems, and then developers can come into the workday at the beginning of the day and get the benefits of that CI having run and being able to basically get cached results when they start running on their Macs. And that doesn't always work as expected. But probably more fundamentally is, we're ultimately talking about waste. We're talking about build actions that are running more often than they conceptually need to, which ultimately translates to slower builds, more resource utilization. And if you're an organization that's paying for your compute costs in some way, then more money that you have to spend. Again, for no real good reason, because we're talking about scenarios and kinds of build actions where this sort of thing shouldn't be necessary. So why is all this a problem in the first place? Why doesn't this stuff just work already? If you're building Java, why should any of this matter? Java, the whole promise of this and similar languages is now this sort of thing should matter in the first place. So why does this matter? Okay, so it all comes down to caching, I guess. Like many things in Bazel and build, there's a lot going on in this slide here, but I guess the gist of it is Bazel fairly reasonably tries to cache as much build work as possible to try not redo build work when it doesn't have to. And it probably, I think this is a pretty complete diagram of what's going on across the build system here, but I guess the key things I might point out on this slide are just that this happens both within a single user's workstation. So if the same user does the same build 2 times in a row, they don't have to redo work that they'd already done before. And of course, it also happens across multiple users and across multiple workstations when organizations have some sort of remote setup with a remote cache or remote executor system. And that's, of course, the basis of trying to be able to efficiently do builds and scale builds across large projects. So in order to do that, in order to cache effectively, you have to know if 2 actions are the same. I think a fairly intuitive way to think about whether 2 build actions are the same or not is essentially, maybe a slight simplification, but essentially, if you see an action and you've seen that same command line with that same inputs, then that's the same action that you've run before. Or if you've seen that you run that same action with the same command line, the same inputs, you have that in a cache somewhere, then you can just return that value from the cache instead of having to rerun that action again. I think that's a pretty intuitive sort of definition of whether or not you're seeing the same action or not when you're looking to see if you have a cache hit. And I think it works fairly well, and it's essentially the model that Bazel applies and powers caching. And it works reasonably well, but it does run into a little bit of trouble when we're mixing platforms. So you can already see on the slide here, probably most prominently, even if you're just looking at what the command line of the action is by itself, in practice, that command line includes platform-specific information in it for various reasons that this talk will get more into as we go into it. Because of that basic fact, right, changing the platforms will pretty much automatically change the command line that you're actually running for an action, which is starting to create problems for that simple model of whether an action is cache shareable or not. So in this slide here, right, we have two examples of two actions which should be able to share the same cache hit. It's the same exact action. It's running some hypothetical Java compilation, both being run on Macs using some shared remote cache or remote executor system. And in this case, all the machinery is exactly the same, and everything should and would, in fact, be able to properly share caches. So in this example over here, you only need to run one of the actions and get the outcome of running both of them. But if you switch that out, going back to this common CI scenario, where if one of the machines is now a Linux machine running some CI or whatever, doing whatever it's doing, it's a Linux machine and not a Mac machine, then what happens in practice is you're staging, you're still running the same Java compilation, but now you're doing it with different Java compilers, because even though Java is platform independent, that doesn't mean that the Java compiler, which runs on the host machine, is platform independent. It's not. The Linux version of this is going to be running a Linux version of the Java compiler, and the Mac version is running a Mac version of the Java compiler. And what ends up happening is that information is reflected in the paths, and the command lines are different, and we don't get a cache hit, and we can't share the results. Even worse than that, we could conceptually clean that up and just try and name those compilers, put them in the same path so they look like they're the same, even if they're different binaries, but and make the path look the same. But that doesn't change the fact that they actually are different binaries with different digests. So even if the command line was the same, the actual inputs to these actions are legitimately different. They are not the same action in a trivial way. We know that it's ultimately the same thing. It's intended to be the same thing. It's intended to be the same output. But from a simplistic view of whether actions are the same, if you're not aware of the special properties of how the Java compiler works, these are actually legitimately different actions, and these results can no longer be shared. And this is pretty direct reason why the CI issue that a lot of people have experienced happens, when why people can't share the work of their Linux CI systems when they're running builds on their MacBooks. So this issue, Tiago has been looking into and has been working on some feature work to try and address this when the host platform that you're running the builds on varies, even though the outcome is ultimately the same. And he's worked on a feature called cache key scrubbing, which he's going to get into later in this talk. And that's intended to improve this and address this sort of dilemma and make the caching logic a little bit more intelligent in this regard. And then there's another variation where even if you are using the same host machines, even if you have two different builds, both running on a Mac or whatever, the same machine, even if you're targeting different types of architectures. So one of the builds is building an app for a Mac, and the other one is building an app for a Linux machine, and they have different architectures that they're targeting. Again, it shouldn't matter to the extent that we're compiling something like Java files. It shouldn't matter. We should still be able to share the results, but we still have the same problem that while the inputs to the actions won't be different in this case, because in this hypothetical example, both of them would be using the Mac version of the Java compiler, the command lines still are different because Bazel, for reasons, embeds information about the platforms that you're targeting into the paths of the outputs. And that's highlighted in the slide over here. I won't get into the reasons myself, or we'll get into this a little bit more when she goes more into what we're trying to do about this. But there are reasons for that. And it then creates these same complications where as things stand now, these two actions cannot share the same cache hit. Running on the same machine, running platform independent logic, but targeting different platforms, can't share the same work because of the way that Bazel constructs the paths in the outputs. I also might add really quickly, and I think our other speakers will get a little bit more into this. This also applies not just to platform information. It also applies to build rules that use transitions. So if transitions are something that you pay attention to and that you find interesting or like, but sometimes find frustrating with some of their performance implications, this also speaks to that issue as well. So we have an experimental feature that Fabian, Ara, and I have collaborated on, which we call path mapping, which is attempting to address this side of the problem. So I think that's all I have to say. I'm just basically introducing all of this here, and I'm going to pass this on now to Ara, who's going to go into more detail about path mapping and how that's supposed to work and hopefully help the situation.
Thank you, Greg, for the overview of our problem space. Hey, everyone. My name is Ara. It's actually my first time here speaking at BazelCon. Super happy to be here, and it's a pleasure to meet everyone. So I'm going to talk about path mapping. Let's first, for context, let's first understand where does Bazel store the build outputs and why. So the number one criteria is safety. So when we decide where we store the build outputs, the criteria is safety. That means we cannot allow two actions that produce different output to write to the same path. And if we do that, it will create a race conditions. So for example, if we have an ARM compilation of mylib and an X compilation of mylib that produce a different output, and we allow them to write in the same input, the same output path here. And then later on, the ARM link of my binary needs this specific output. So which one does it get? So this whole situation right here is called action conflicts. And in Bazel, we do have checks to for this scenario and fail the build with such conflicting actions. So to remedy this, we add the CPU information into the output path to distinguish the different outputs. But doing so could harm the remote action cache because the path here is directly related to how action caching works. So the remote action cache is a map that maintains a map that has the action digest as a cache key, and the action result metadata is a cache, the value. And the action digest is a hash function of the whole command lines that include the input files path, its content, and the path of the outputs, which are most relevant to the context of output path mapping. And so in these two black boxes you see here, these are the example of the paths that a command line of an action could contains. And on the right side is a action that cross-compiled to Linux. But because you see in the CPU informations and the compilation mode highlighted in red and oranges here are different from the two action, and even though they result in the same output, the action on the right side that cross-compile to Linux does not benefit from the previous work that was done by the first actions. And to help with this problem, we introduce path mapping. So I'm gonna go back and walk you guys through where we integrate path mapping into our current flows. So when a user sends a build command to build a target, Bazel breaks that into multiple actions. And then for each of these actions corresponding spawn object, which is a subprocess that will be invoked by the remote executor. Oh, sorry. And so if the action declares itself to use path mapping, then a path mapper will be created with a spawn. And the responsibility of the path mapper will then remove the information that was highlighted in red and oranges here out from the command line, simplifying it to look like this in the black box. And because these paths are rewritten on the command line, the remote executor then responsibility tends to stage the input files at the paths that were rewritten. A few things that I want to note here that you see the path here on the command line in this example are in this perspective of remote executors. So after the remote executor returns its output, Bazel then mapped this into using the same the full path name and so that it could continue to exist with the rest of the build outputs. So this means that when this feature is on and user do a build and after that you examine the Bazel, you still see the exact same path that has the CPU or compilation mode information that we saw before. And the second point is path mapping only merges paths that are differed by paths but not by contents. So this is considered safe, unlike cache key scrapping that Tiago will get into in the later sections. And the third point is not all actions are qualified for path mapping. Therefore, currently, we maintaining a list of action mnemonics that we apply path mapping for, mostly just at Java and Android rules. So in this slide are the example of actual impacts on real projects that are in Google 3. So on the left side is the YouTube Android app, and on the right side is a Play Store Android app. And so the nature of this experiment is very controlled so that I only see the benefit of output path mapping alone and not together with other caching system. So you see for the YouTube one, it consists 15% of Java library and Android library rules. And we see an increase in number of action cache and a 25 reductions in both time. And then for the Play Store, we see 11% of Java and Android rules with nearly 40% reduction in both time for subsequent builds. So right now I'm gonna pass over to Fabian, our collaborator, to talk about state of thing in Bazel. Thank you.
Kara. Thank you. Okay. Hi, everyone. I'm Fabian. I'm the non-Googler working on this project, and it's one of the interesting examples of, well, very interesting and challenging rabbit holes that you can get yourself into. So 2.5 years ago by now, some people at my company complained that they were recompiling Proto C 16 times. I mean, we're not Google, so the scale is not that large, but 16 is a lot. So I looked into it and I saw that this was caused by rules go using transitions that leak into output paths. And then fast forward, I'm here talking about a way to sort of solve that, hopefully. And in line with Benjamin's talk, we'll now go from the theoretic section that Ara talked about to how you can actually use path mapping today in Bazel. And the good news is that the latest RC, so RC2 and RC1 of Bazel 7 are actually pretty good. And you can start using most of this, not everything, but most of this today. There's one experimental flag that you need, experimental output paths. And if you set that to strip, that will enable path mapping globally, which then allows action to opt into it, because we can't opt every action into it. Not every action may be compatible with it. And then, as I mentioned, you need some kind of cache. So you need to use remote cache or disk cache to actually make use of this feature. Otherwise, it doesn't give you much. And you need to use the supported execution strategy, because we need to do some kind of dynamic remapping when we stage something for execution. This needs to be something, essentially, think of symlinks. So we need something that does symlinks. So that excludes any kind of unsandboxed or local execution. So on Windows, for example, you can only use this with remote execution, but that should work on all platforms. And unfortunately, there are some multiplex workflow issues that I'll get to. And as I also mentioned, the most prominent example of well, platform-independent build results is Java and everything, like, think of everything JVM. So far, we've focused on Java, and path mapping there works for essentially everything. So it applies to the full compilation actions. It also applies to this Bazel concept of header compilation that's sort of supposed to flatten your build graph. And it also applies to some bootstrapping actions that are a bit less relevant. And it should just work. So if you use the flags from the previous slide, it should just work with one caveat. So remote execution just works. Unfortunately, the default compilation mode for Java is a multiplex unsandboxed worker. That's a mouthful, but relevant bit, it's unsandboxed, so it doesn't work. will improve that. So far you need to pass this, no experimental work, and multiplex. Here's an end-to-end example. So if you want to try this out on Bazel itself, you can just use all these flags, and then you build in the default compilation mode, which is fast build. And if you do that, and then later on, you switch to compilation mode opt, which is reflected in the output path, you will get cache hits for essentially all Java actions. So that's one way to give it a try quickly. And you can see if you look at the command lines that you run, that this is essentially just because we dropped this config part out of the flags, out of the path. And now the important question for rules also is, how can I now apply this to my rule set? For example, rules Go would want to use it, and probably rules Kotlin as well. There are two ways. You can do this in Starlog. You can provide a well-known execution requirement, support path mapping to show that your action is compatible. Or you can do it from the CLI. If you just want to try this out quick and dirty, you can enable it for a certain action based on the mnemonic. And this is incrementally correct if you toggle this. So for example, if your action depends on debug symbols that reference paths in debug mode, you can selectively not pass in this execution requirement in that case. I'll quickly go to the slide. There's essentially one rule that tells you whether your action is compatible with path mapping. Good thing is if you follow these rules, Evo will like you because memory consumption, the memory gnomes will be very happy. This aligns pretty well. If you use structured command lines, you avoid eagerly creating command line strings, that's pretty well aligned with making your action compatible with path mapping. So there are some don'ts and do's. General rule is everything that has full paths in it that mention this configuration prefix, you should only let the args object for structured command lines construct lazily and don't do it in your rule implementation. Yeah, these are the detailed things. Some things will only work in the full Bazel 7 release, not yet in the latest release candidate. So let me go over the future plans. Java is pretty done. There are some corner cases that we need to look into, but I hope that those will be addressed for the full Bazel 7 release. And then the next step, I mean, I'm also a maintainer of Rules Go, so Rules Go, it's transitions. Well, we feel sort of responsible for also applying it there. And then I will also look into and talk to the rules Kotlin maintainers to maybe have a full Starlog end-to-end example of JVM compilation using this feature. There's one caveat, so there are some location expansions that are problematic because they're not structured, they're just strings. That's something that we'll try to approach and tackle a bit more comprehensively. Yeah, and then there's also an application to Bazel mod where this can also reduce rebuild churn caused by updating dependencies. Yeah, and your feedback is very welcome. Please just give it a try. And I'll hand over to Thiago.
All right. So I'm going to talk about another feature that we're introducing in Bazel 7 to facilitate cross-platform builds. And we're calling this feature cache key scrubbing. So let's recall this scenario from earlier, where we have a single project built on two different platforms. On the left, we have a developer building the project on its macOS laptop. And on the right, we have a CI pipeline building it on a Linux machine. And notice that only the execution platform differs between the two builds because the compilation output is a jar file, which is platform agnostic. However, and Greg has already explained this, because the Java compiler is a native executable, it has a different path and also different content on each platform. And therefore, if you do a build on Linux, populated cache, the cache will not be hit by the macOS build that you go after, or vice versa. So let's recall again how we store action results in a remote Redis cache. We have this thing called the action cache. It's a key value store of action results. And the key to these cache entries is something we call the action digest. And this is just a hash of a protocol buffer message similar to the one on this slide. And for simplicity, I'll just call it the cache key going forward. Note that the key contains every detail that could possibly affect the action execution. So it's the input paths, the digest of the input paths, and the command line arguments. And again, this is a very simplified example, but in this simplified example, you have an action that compiles a Java source file into a jar using the platform-dependent Java compiler, and the bits in red are sort of the platform-sensitive parts of the cache key. So scrubbing is a process by which the platform-dependent details are erased from the cache key, so you can have a uniform cache key across execution platforms. And in this example, we are applying two transformations. First, the platform-dependent Java C input is omitted from the key entirely. And second, the command line arguments are rewritten into a sort of platform-agnostic version. And if we do this, then we can use the scrub key when reading from or writing into the cache. And so this way you can run a Linux build, populate the cache, and then later run the quote-unquote same build on Mac OS, and you will be able to hit the cache, hopefully, because they're both using the same scrub key. There's one additional problem. Sooner or later, you're going to have to upgrade the Java compiler to a later, possibly incompatible version. And this version might not be able to share the previously cached results produced by the previous version of the Java compiler. And so to make it possible to disambiguate between the cache entries for these two versions, the user-supplied salt may be included in the key. And this is just like a completely opaque string. It's JDK 18 in this example. And this is completely controlled by the user. We're not going to interpret it because we want to provide maximum flexibility around cache invalidation. I'll just mention very quickly, this is really only about storing and retrieving entries from the disk or remote cache. It does not affect Bazel's internal model of correctness. It does not affect how the action is invoked, because the recent command line would not work at all. And so it has a practical consequence, which is that you can make local modifications. It will still trigger a rebuild, even though you might hit the cache anyway. And toggling the scrubbing on or off will not by itself invalidate the local results you already have. How do you set up scrubbing? You pass in a configuration file, which is a protocol buffer in text format, and we're going to take a quick look at what that looks like. So here's what it looks like. Configuration is a list of rules. A rule is a transformation and the set of actions that it applies to. The matcher describes which actions are affected by the rule. Actions can be matched by mnemonic or label. Both can be given as a regular expression. In this example, we match all Java compilation actions for targets in the main repository. And the transform describes how the cache key should be scrubbed. List of inputs to be omitted, list of string replacements to apply to the arguments. And then finally, the user-defined cache salt. I'll just mention very quickly, because I'm running out of time, apart from the configuration file, there's two flags that you can use to make scrubbing a lot more effective. First, you should consider defining a custom host platform and using its name as the configuration prefix. This is the platform in output there flag that was mentioned earlier in the previous talk. And second, you should normalize your environment variables, because as it stands, you cannot scrub them. This is something that you have to do through some other means. This is a very experimental and low-level feature, so it comes with a couple of caveats. First and foremost, scrubbing improves performance at the cost of correctness. So scrubbing too little will prevent the cache from being shared, which is bad. But scrubbing too much might cause cache entries to be incorrectly shared, which is also bad. As it stands, basically, the user is responsible for ensuring that the configuration is correct. And coming up with that configuration is sort of a trial and error process. It might also have to be, whatever configuration you come up with might have to be adjusted on a toolchain upgrade. And for more information on how to set it up, you can look at the flag documentation and the protocol buffer format, which is in the Bazel repository. So while we believe that this current implementation of cache key scrubbing successfully addresses user needs to some extent, I'm also going to acknowledge that user experience right now is far from perfect. This is just a starting point to this feature. I'll briefly mention some aspects in which this could be improved. First, we're currently lacking good tools to pinpoint the root cause of cache misses, which is important because of that trial and error process that you would have to go through to write the configuration successfully. And this is something that we're actually planning to address in the coming months by rethinking the way we do the execution log. Next, we envision that maybe in the future, the toolchains themselves might be able to provide configuration rules so that users don't have to write them themselves. Finally, scrubbing is currently not compatible with remote execution. This is not, in principle, impossible. It's just that we would have to modify the protocol, and this is sort of, the conversation is wider than Bazel here. It has to involve the various implementations. And I think that's it. I'm not sure that we have time for questions, but thank you.
Thank you everyone for these talks. If you have more questions, you should find your speakers during lunch. The break will be just 5 minutes. Come back in for a block of lightning talks. See you soon. Yeah. So I will hand you a mic and a clicker. The clicker is just what you would expect, forward, backward. The laser forward, backward. I'm gonna open now presentation with the latest speaker notes. Yeah, so if we hit forward, you'll see it, and the speaker notes will show up there. You should stand between the platform and the speaker notes because how far? Because I can stand anywhere between the and the other side. Yeah. Are you the same price? Yeah. I think you will want to see
Helen, can we try something? You just stand over there and see if the lights are too blinding. Is it okay?
Okay, great, amazing. Where's the last one? I want to know.
You two are having it. So yeah,
all right, folks. So we have 3 product pitches coming up. First up, it's Helen and Ulf from Engflow. Welcome.
Hey everyone, and thanks for having us. I'm Ulf. I worked at Google Munich right here in this office where I led Bazel development for about 10 years. Now I'm the CTO and co-founder of EnchFlow, which we originally incorporated just outside of Munich. Together with Helen, we're going to give you a whirlwind tour of both our founder story and our product. We might even get some customer calls while we're at it.
I'm Helen, CEO and co-founder of EnchFlow. I'm based in New York and worked at Google helping companies adopt Bazel. As the former startup and bank CTO, I'm actually quite familiar with 8 to 24-hour long builds. And so when Ulf gave me this opportunity to create EnchFlow together, I saw it as my calling to deliver on the commitment that I made to you all at the very first BazelCon, which were to bring the developer experience, discipline, and a powerful technology platform to increase productivity and happiness. All right, so we got the mission. An engineer who led Bazel, Laszlo and Sarah, our founding engineers. What more do we need? 4 months, sweat equity, a pool of cash from our savings to last 1.5 years, and friendly coaches at Expreneurs Incubator in Munich. By June 2020, we started testing our remote execution software with potential customers.
So from the start, we were designing for ease of maintenance and scalability. In particular, we wanted to have no single point of failure, so we could roll the cluster, at any time without downtime. And two, a dynamically adjustable worker pool, so we can add and remove workers at any time. We also wanted to have fast scheduling. From previous experience, I knew we wanted to have around 1 millisecond with a distributed scheduler. And today we've load tested our software to about 8,000 actions per second per pool per scheduler. So want more, get more.
In July, we started testing and already had one enterprise customer using us for production workloads. Actually, we had 2 first customers, which made questions like, is anyone else using your software, really easy to answer.
Oh, customer call. Your Java builds are taking longer with remote execution than on a single machine. Well, Bazel's persistent workers keeps the compiler running on the local machine, which can make a single action like 10x faster. Now, we added support for remote persistent workers, which do the same thing, but remotely, and we also upstreamed the client-side support to Bazel.
As a team of Bazel experts, we recognize that Bazel isn't the one build system that's going to rule them all. No offense, Bazel folks. So we built a platform that can be used by everyone, starting with builds compatible with Remote Execution API, which was designed by our engineer, Ole Rosenfeld, while working at Google. And as we signed a deal with Brave browser, multiple companies using Chromium came to us. Today, with support, Bazel, Bug 2, Chromium, Goma, and RE client, Sung, CMake, and are working on more.
So the UI. The target tree viewer, which you can see on the left side, dynamically loads the target tree from the server. It shows your built-in test results, and it can easily handle more than 100,000 targets per invocation with prefix search. The action viewer on the right side lets you dig down into individual actions and browse their properties, results, as well as input and output trees.
With a robust platform like this and paying customers in a year 1, it was time to scale. As not your typical Silicon Valley founders with access to investors, we had to get creative. This is Sarah. We called her our founding intern. She pitched EnchFlow to alchemists, giving us exposure to mentors and top VCs. And by the end of our 2nd year, we raised funding from Andreessen Horowitz. Sarah now graduated from Stanford and is currently pursuing her own AI startup. Go, Sarah.
Ooh, hey. You're trying to debug a performance issue with your build? You're currently looking at the target tree? Okay, then please switch to the Performance tab. We integrated the Bazel Invocation Analyzer, which we showed at last year's BazelCon for quick checks. And we also have the EnchFlow profiles, which let you dig into really every microsecond spent server-side and show you the end-to-end build as a flowchart with a lot of resource usage details. Want to know how much CPU and I/O your test used? It's all there.
Over time, we signed some very hungry for cores customers. This scale made cloud costs really noticeable, and so we implemented new capabilities that became a competitive advantage. Our customers migrated from competitors, saving at least 20% or more in cloud costs alone.
Ooh, this is an important call. Hey, you're currently only building 10% of your code base with remote execution, and you're worried about the cost as you get to 100%. So fortunately, the cost increase is typically sublinear because of how monorepos work. You know what? We'll run a full load test with up to 100,000 cores, and you can see it for yourself. And also for the second cluster that you're running on the East Coast, we're enabling cross-region cache replication. So the result of this load test, which we did, was that the cost increase was about 3x and not 10x. So we were all very happy about that.
But do we stop here? This is big code, and it will continue to grow. So we're investing by giving you APIs so you can build your infrastructure on top of them, and new tools as part of the bigger platform, and by consolidating your build and CI.
So you want to run CI actions inside of the cluster for network proximity and to use our autoscaler. Yeah, I can see how that could reduce your cloud cost for CI by about a factor of 2. And yes, absolutely. We can replace your GitHub, BuildKite, or Circle CI runners with autoscaled, automatically managed instances. Can we combine CI runners and remote execution? Yes, absolutely. They are better together. Remote execution can improve your performance, your cloud costs, and your security. And in many cases, it does all three.
Found alive, always taking calls. There's a lot to do and lots of competing priorities. So from our early days, we implemented this prioritization framework. Happy team, happy customers, and more happy customers. Everything we showed is created by this team. Without a happy team, we have no business. They're experts who created Bazel, Gazelle, our client, and made major rules and other open source contributions. Together, we built a sustainable business with a product that customers rely for their daily development and production.
Since we started EngFlow 3.5 years ago, we're very happy to say that we've had 100% customer retention. We're very grateful to all of you, and we're working very hard to keep you happy.
And we're expanding the build community, as you saw, by educating and bringing folks together at our events, partnering with Salesforce, Datadog, CodeThink, Aspect, Tweak, Gradle, and open source creators of Build Farm, Build Barn, and Bug2. We're also sharing Bazel expertise with all of you. Last month, we launched blog.engflow.com that includes best practices, migration deep dive, and of course, everyone needs a snake. Now, this you may want to take a photo of. There's a lot we're offering here, and for super low price with the BazelCon package. We'd like you all to succeed with the Bazel migration, share our deepest expertise, and train so you can build that internal knowledge in-house, and give you tools that get you there fast and reliable and sustainable results, so that you don't have to retool later or unmigrate because of hermeticity, incorrect rule adoption, SBOMs, or remote execution incompatibility. And so sign up for, by December 15th, and we've got a super low starter pack as well. Customizations are also and add-ons available with EngFlow and our consulting partners.
I'm really excited about this one, Helen.
It's hard work to build a company, and as we become more successful, there will be more competitors entering the space. But we wouldn't be here without your love and trust in our team, our product, and our company, which is created by core Bazel engineers who will continue to push the boundaries and bring new capabilities to you. With these capabilities, we're meeting you where you are, bringing the powerful platform, and making sure that you all can save on your cloud costs and build times, up to 50% savings on cloud and 8 to 64 times faster builds.
And of course, keeping your engineers in flow with EngFlow.
All right, thanks, Helen and Ulf. Now we have Alex from Aspect. Welcome.
Thank you. Not my slide. There we go. Hi, everybody. I'm very excited to be here at BazelCon once again. I've got a lot to talk about, so I'm going to dive right in. Aspect is here to make Bazel better for you, and the first way we do that is with workflows. So this is a talk in two parts. Workflows comes out of this original Bazel blog post from when 1.0 was released, and it says users have reported 3x test time reductions and 10x faster build speeds after switching to Bazel. And the key words to look at here is users have reported. So the Bazel team was not promising you these things. And in our experience, you know, we want to know who these users actually are. Like, is anybody getting this performance? Yes. Here's Max. I don't know if he's in the room right now at BazelCon last year, and reported a pretty fantastic result. The year before that, we heard from Tencent. The year before that, every year at BazelCon, there are talks about how some company has managed to get some of these benefits. And what we saw as Aspect went to over 40 companies now to help them adopt Bazel is that most of them were not getting those benefits out of the box. So, I mean, obviously all of you are using Bazel. How many of you had the sort of performance improvements that were promised when you first set it up? Okay. That's more than I expected. Okay, maybe less, about 10 hands maybe. What we saw, so this is at VideoAmp. Here's a commit where somebody added a single line to a markdown file. So this ought to be a very fast rebuild, and it took 4 minutes, which was totally not acceptable. Here's another customer here. This is the 99th percentile slow case, which is another one we look at. This is the pathological case where most of the actions really are cache misses. Unfortunately, the number is exactly in between these two screens here, but it took, I think this is a 21-minute build to rebuild everything. So this was supposed to be a highly cached build. So why was this one so slow? And of course, the answer to this is subtle. So for a number of companies, we helped them develop a CI solution from scratch. And there was a lot of work to do. So you can read it here in this blog post. What are some of those steps? And I'm sure some of your companies have already gone through the work of building a custom CI solution that makes Bazel super fast. The first thing that you find that you have to do, of course, is to avoid having ephemeral runners, because Bazel is fast when it has a local cache. Most CI systems are not based on this. They are based on the assumption that the build tool is incorrect and stale build results is the main problem that you have. And so they always start up a pool of workers. Each worker starts up, does one build, and terminates. And if you just follow this instructions from your CI system, you'll probably end up with a build like that that's very slow. Of course, Bazel is meant to be correct, and so it is okay to reuse runners. And so you want to do the opposite. You want to host warm workers talking to a remote cache so that they are able to share intermediate artifacts. And so is that it? Is that the end of the talk? No, I still have a few minutes left. So let me tell you, no, that's not the end. That will still be a slow build. The reason is that there's a long list of de-optimizations that occur on CI. Don't have time to go to talk through each of these, but essentially, in the analysis phase, Bazel is building the dependency graph. That needs to be cached in the JVM, and so restarting the JVM or discarding that cache will slow you down. Having a low cache hit rate, there's already been talks at BazelCon and yesterday's community day about how to avoid doing too much execution because you're not getting the cache hits that you should have. There are mistakes in how you host an individual machine that will make Bazel slow, and then there's also mistakes in how you host a cluster of machines because, of course, you want your builds to be elastic and scale in and scale out. So you have slow 99th percentile builds where a new machine had to boot up for that build. Remote execution, of course, is a great solution to a certain set of problems. We think it's the performance optimization of last resort, and there's a few reasons for that. One is that it doesn't help with most of the problems I just described. Those are problems that happen during the loading and analysis phase. It's not enough to just send all of your actions off to be remotely executed. It's fairly broken in the sense that you will have to go through some work to make sure that the rule sets you're using are compatible, especially if the host and execution platforms are different. And many people's builds are not hermetic enough to run on remote execution at the beginning. So there's some on-ramp cost. And finally, it can be expensive because if you're using remote execution just to paper over the problems that you have hosting Bazel itself, then you're throwing more machines at it. And in some cases, there are rule sets that will make this problem even worse because things like rules Docker accidentally had really huge inputs, and those, if you aren't very, very careful with either build without the bytes or keeping action execution local when the inputs are local, then those things will be sent over the network. So, of course, this being the product talk, we have a solution for this. We've deployed this at 15 companies now. It's called Aspect Workflows, and the idea is that it runs on your cloud and on your CI. We're not asking you to migrate anything. It is co-managed. We carry a pager, and we don't make money if your builds are slower, so that's good. We want to make your builds faster instead. We offer a 1-month trial, and this is generally the point where we're able to prove to you that not only does it make your builds faster, but it actually pays for itself. So we always help our customers to calculate the savings that they're getting on their cloud machines at the end of this trial, and don't expect them to proceed unless we're able to save them money overall. So let me just revisit some of those slides from earlier. So when we looked at this markdown change, this sort of no-op build became 2 minutes faster here. If you look at our documentation site, you'll see on the homepage, we had a 5-second rebuild, and so one of our customers said, "Holy moly," which is a really nice, concise testimonial that we were able to present on that page. Going back to our 99th percentile build, this one became about 2x faster, down to 11 minutes. And sort of putting it all together, we did a comprehensive case study at Coda. Originally, they were spending about 10 minutes average and sometimes over 30 minutes on their 99th percentile builds. And the cost was the equivalent of 2 software engineers that they could have hired if they were able to reduce the cost of running on CI. So their compute costs were 2 SWE equivalent. So the solution, we did our 1-month trial. We proved to them that it had good stability, uptime, that the developers were able to transition. And the results we got, not making it up, are exactly the ones from the Bazel 1.0 blog post. So we went from 11 minutes to 1 minute, as you were promised, 10x speed up. We went from we had a 2 to 3x speed up of their typical builds and tests. What was not mentioned in the Bazel 1.0 blog post, they reduced their compute spend 67%, even though they were adding more and more targets to their Bazel build, and so increasing usage during that period. And they said we went from having significant limits in CI and tools to where the limits are now just in our code. So the infrastructure layer is not their problem anymore. Okay, I have a few minutes left, and so I want to tell you about the other half of what Aspect does, which is rule sets. I went and checked on the Bazel Central Registry, ran some quick JQ. We have published 1/3 of the releases that are on the Bazel Central Registry. We are very serious about supporting all of you through our open source efforts. We maintain our rule sets to a very high standard. We believe in high quality SEMVer, so these are 1.0 means it. We have really good documentation. We put a lot of effort into how we do releases to make things fast. We have over 20 rule sets now, so this is the picture as of before BazelCon. The announcements I have for this year, Rules TS, the TypeScript support, has added a TS proto library. You can watch Matt's talk at the end of the day tomorrow here about Rules Py, which is a layer on top of Rules Python. You can watch Derek's talk at the end of tomorrow about our Bazel lib repo, which is a foundation layer. We just added a new tar rule based on BSD tar. We have a partnership with ChainGuard, which makes super secure base images, and so Rules AppCo is a way to build these on Alpine. And then Rules AWS and Rules Lint are over there in the experimental corner. I just want to point out Rules Lint in particular is pretty exciting because when we pair it with workflows, we're able to put the lint results along with the suggested fixes in the next release. Will show up in your code review. Doesn't require changes to rule sets or to build files to be able to lint them. And why am I saying Bazel lint? Is that a lie? That's not actually a lie. We have our own CLI, and so we can actually add the lint command to Bazel through either a plugin or building it in. Our CLI also has more pre-compiled version of Gazelle, so you don't have to build Gazelle yourself in your repo. We're adding more languages there. We have a docs command to pop things open in your browser. We have an init command to make a new workspace. We have help. Bazel also has help, but ours is helpful. I know. I don't mean to dig on the Bazel team. I appreciate all of their effort very much. I appreciate all of you for coming to BazelCon and listening. Thank you very much.
All right, thank you, Alex. Next up, we have Jim from GoPutty. Welcome. Thanks.
Hi, everyone. I'm Jim. I'm a software engineer at BuildBuddy. This is less of a product pitch and more of kind of a demo via screenshots. I'm going to be talking about some tooling that we've built to help you find like weird, slow, bad builds, stuff that uses a lot of cache, stuff that's just downloading stuff slowly, things like that. Well, before lunch if you're watching remotely, so if it seems like I'm in a hurry, that's what's going on. This is a question I kind of ask myself randomly when I have a CI run, like probably like once every couple of months. You know, it used to be like 8 minutes, now it's 15. And the question is, what the hell happened? When did it happen and why? I feel like it's always kind of been a while that your builds have been slow by the time you notice something like this, because, you know, it's like things can be noisy. Sometimes the thing takes a few extra minutes, something like that. And you say, just kind of like ignore it, right? And you like move on with your life until one day you're just like, this is way too much. What do I actually need to do to fix this? When did it go wrong? And so what we've had for a while now is this little trends page in BuildBuddy, which basically has every build that you've ever streamed to us via BES. And you can just kind of like see the number of builds you've been running for like, you know, the last few years or whatever. The build duration, we have stuff for action cache hit rate and download speed and stuff like that. And if you look at this build duration graph down at the bottom here, you can see like, yeah, we have gotten a lot slower. This is our actual data from our repo. You can see we've had a few bumps over time in the last like 5 months. I'm going to talk about the one over on the right there, which was nice because when I was getting this talk ready, I needed an example, and it was something that was happening, and I found like when I was getting the talk ready. So okay, we found some random build where like P90 build times went up by, what was it? They like doubled. They went from like, what, like 10 minutes to like 20. That's bad. Basically, you know, at this point you're like, okay, I'm gonna like hunt for like whatever the slowest builds were. I'm gonna like maybe go dig through PRs, look for something that was bad. But this is like every like CI pipeline that we run. All we know is that things just kind of got slower in general. So like finding this is kind of a pain in the butt. And so this is all just kind of a like feed into what we've built here, which is this new little button up at the top of the page there. That's this drill downs page. And if you go to that, you get this little heat map. And if you've used observability tools before, this might look familiar. Basically, this is the same as the build duration graph that we were looking before. You can kind of see the same spikes. Each cell in the heat map corresponds to some number of builds that you run. And you can see kind of, you know, over on the right there is that little block we were talking about. You can see things kind of spiked up a bit. And now what you can do with this is any section of this graph, you can kind of just zoom in. And so we're going to zoom into just 1 week of data. And you can kind of see, okay, cool, on September 8th, everything was fine. And it's maybe a little bit faint up on the projector here, but you can see these kind of zones where all of a sudden, on like September 12th, things got a lot slower. And so what we can do is we can basically just highlight a section of this chart. And when you let go of the mouse, we pop up this little series of bars down at the bottom here. That's a bunch of dimensions of the builds that you're looking at. And so basically like the build pattern, the repo that you're actually building on, the host name, the user, stuff like that. And each bar in here, the green bars are the things that you selected. The purple bars are the things that you didn't select. And so like kind of right away, you can see in the little pattern section, this is all like workflow runs for us. You can see this bare metal test target corresponds to or accounts for 75% of the really slow builds, even though it's only like 13% of our builds overall. Just as a point of comparison, our like kind of like WebDriver test suite is 17% of our builds overall, but it's none of this really slow stuff. And so like right away, you know, okay, cool. If nothing else, what's slowing us down right now is this bare metal test suite that we have. And so what we can do is we can actually click directly on that bar and it will add a new filter to this UI. And so you can see that the key map updated a little bit. Now we're just looking at these builds that correspond to that single workflow. And now to go even a little bit deeper, we can kind of highlight all those slow builds again. Now that we know we're looking at something that's actually like what's contributing to our problems, you can go down the page and just find a list of invocations that are the ones that are actually slowing things down. And so you can just kind of like go click through to all these. And since this is a 10-minute talk, I'm going to just jump ahead, and I picked an easy example. This is just a flake. So what we had going on was somewhere in one of our CI pipelines, something turned into a flake. It was taking 10 minutes to run instead of like 2. And that slowed us down a whole bunch. And so if you really wanted to make sure that it was actually mattered, if you go through the actual invocations and you look at our little timing profile, you can see that there's actually only one action running for the entire 15 minutes. And there's basically no CPU usage going on. It's just a weird deadlock in the test. And so it was pretty easy from here to just kind of like go and fix the thing up. So that's pretty much the thing. Basically, it's not just build times. You can go and mess around with like cache hit rate, download size and speed for invocations. If you're using RBE, you can look at how long things are queuing for, execution time for those actions, time spent uploading and downloading inputs and outputs. Yeah, oh, and I guess one more thing. We have all these little drill down types, and the other thing that we have that's really cool is you can just set arbitrary text labels onto builds. So you can basically just say, like, if you have something that you know is special, but there's no real way for us to sort of identify it from the build stream, you just slap text onto it and find it later in our UI. Just as an example, this is the exact same window, only looking at action execution time. And so you see this little region show up all of a sudden around September 12th. And if you highlight it, you can go in and see, no kidding, it's the exact same set of tests that was what became flaky, and they all take 10 to 15 minutes. And if you go through to the actual execution details page, you can see timeouts for things that are taking 15 minutes and giving up. If you really, really wanted to go deep into stuff, you could go and look at the actual execution details for the action and see, like, if anything weird had changed about arguments, environment variables, stuff like that. I think the coolest thing about all this is that it's just in our cloud offering. So if you point your build event stream at us, this will just work. This is all running on top of an OLAP database. So if you're doing like millions of builds, no big deal. Just point it there, it'll work. We keep the data for all time unless you tell us not to. So basically you can, if you found out that your builds got slow like 6 months ago and you want to know exactly when it happened, so you don't have to go hunting through all of your PR history, you can kind of narrow it down to like a 5-minute window when things went bad in your CI pipelines, and it'll be there. And pretty much everything that I mentioned is available as a Prometheus metric. So if you're really into that and you like to get alerts when your builds get slow, you can do that. Personally, I think it's noisy, but there you have it. Yeah, that's kind of it. So try it out, come talk to us. We're hosting happy hour tomorrow night. I think it's pretty easy to get to. It's right outside that door there. I think you have to sign up. So I think there's I think we put a page. What was it, George? BazelCon. Yeah, if you didn't hear that, it's okay, because you're probably not going to come to happy hour anyway. We have a Slack. You can email us, talk to us anytime, find me at lunch, whatever. Yeah, thanks a lot.
All right, thank you, Jim. So that concludes our day one morning session. Now it's time, everyone's favorite time, it's lunch. So we have three venues for lunch, sort of. There's the ground floor 10X area where you had breakfast. There's also one floor up, the first floor, out this door, up the stairs. And then also at Ether Valley on level 6. You can go up to level 1 and take the elevator. And then we'll come back to 10X. 10X. We'll come back to 10X in an hour or so for more talks, more goodies. And then also Moonshot and Ether Valley will both have a BOF session. There's also swag in the Ether Valley area. So go there to get good stuff. All right, see you everyone back here at 1:30. Thank you.
micro VMs. So I'm sure a lot of you have seen this comic before. And the good news here is that this is much less of a pain point with Bazel. My builds are much faster now. Has Bazel completely fixed all of my productivity problems? Not quite. I'm guessing that this version of the comic is just as relatable for a lot of you. So a situation that I frequently find myself in is I've just finished some code and pushed it to GitHub. And before I add reviewers, I figure that I should probably wait for CI to complete. But of course, it's running kind of slowly. And so I peek down at my phone. But that, of course, completely drags me in, and I end up spending more time than I intended. And by the time that I look up, I realize that CI has failed, maybe due to a linting failure. So I fix one line of code, repush, CI starts again. This time I might wander to the kitchen for a snack. And eventually I wander back to my laptop, realize that CI has failed again, this time due to a unit test failure. And so on and on this process goes, dragging on for a lot longer than it probably should. So this has led us to an important question that I'm sure lots of companies also face. How do we make our CI workflows fast every single time? Using Bazel in your CI pipelines is a really good first step. So a good CI pipeline will minimize build times and compute resources. It'll let you run jobs in parallel, and if a single job fails, it'll fail the entire pipeline, so you're not wasting any resources. And if this sounds familiar, it's because that sounds a lot like a build system, and these problems are exactly what Bazel was meant to solve. But if you're anything like me, you might have a pretty short attention span. So what if you need your CI to be blazing fast? Unfortunately, even with Bazel, even with remote cache and RBE, your CI might be slow. Preparing a CI runner to execute a workflow takes time. It has to build or pull the image, clone the Git repo, and once the Bazel build has started, Bazel has to do the analysis phase and make network requests to the cache. And the analysis phase has been a particular pain point for us at BuildBuddy. For large repos, this can take several minutes, and it's especially tricky to preserve because it lives completely in memory. Here's a sample CI run. From a Bazel standpoint, this run was actually pretty successful. You can look at the cache tab and see that there were a lot of cache hits, and building and running our entire test suite took 6 minutes, which isn't bad. But here, you can see a lot of the inefficiencies that I mentioned. You can see that we have to clone the Git repo, and the first time we run the Bazel command, we have to download it and start the local Bazel server. And the analysis phase takes 1.5 minutes. For a 6-minute build, this is 25% of the entire build time. You know that really satisfying feeling where you rerun a build on your local machine and the second time it's basically instantaneous? Well, we wanted to build that for CI. So we decided that we would clone our CI runners. So after we've done the slow work of preparing a CI runner once, we wouldn't have to do it again. New CI workflows will be assigned to cloned machines that have warm Bazel instances. And this worked. This approach helped us save several minutes per CI run. Now, the majority of our CI runs complete in just seconds. We saw an 8x reduction in the median duration of our CI runs. And something really important to call out here is that this is compared to other workflows that are also using Bazel. So our baseline is using Bazel with remote cache and RBE on GitHub runners. So our CI pipeline was already fast, and we were still able to make it 8 times faster. This graph helps visualize the performance benefits of our cloning approach. So we call our CI product BuildBuddy workflows, and you can see it on the left in the teal. And you can see that the majority of our BuildBuddy workflows complete in 30 seconds or less, while basically the fastest run on a GitHub runner takes 2.5 minutes. Here's another example CI run, but this time it was assigned to a cloned machine. You can see that we don't have to install Bazel or clone the Git repo, and the analysis phase is much faster. So remember the first time, the analysis phase took 1.5 minutes. This time it doesn't even take a second. And the total build time is only 9 seconds, which is way faster than the 6 minutes that we saw before. So in order to implement this, we use Firecracker, which is a virtualization technology created by AWS. And we chose Firecracker for a few key reasons. First, we liked that it's been battle tested by AWS Lambda, which reassures us about its stability and its scalability. Firecracker also provides really strong isolation and security guarantees. So this was important for us because we run CI for multiple companies on the same executors. Firecracker micro VMs are also lightweight. While a normal VM might take a couple seconds to boot up, a Firecracker micro VM can boot up in just a couple hundred milliseconds. And another important feature is that VMs have a lot more couple functionality than containers. So anyone who's ever tried to run Docker in Docker knows that that is extremely painful. Running a container inside of a container is really hard. But a lot of companies have complicated Docker setups in their CI. And so we wanted to make sure that we could support that easily and that people would be able to easily configure their CI runners by bringing their own Docker image. And running a Docker container in a Firecracker VM is much easier. Another really cool feature of Firecracker is the ability to snapshot. A snapshot lets you capture the entire state of a running VM, including both the disk and the memory. So when you load that snapshot onto a completely different VM, which is a completely different machine, it'll have the exact same state, including that hot Bazel cache that we want to preserve. Another cool feature of snapshots is it lets you serialize VMs to disk. So let's say you wanted to reuse a Docker container. You could pause it and resume it, but the paused Docker container would still have to run in the background, which continues to use memory and CPU. And these are much more expensive resources than disk. Disk is also much more resilient to host machine restarts, and the contents are shareable across the network. So there's really no way that you can transfer a paused Docker container over the network in the same way that you can transfer a file. So let's imagine a sample CI run. When the workload comes in, you have to start the micro VM, build or pull the image, clone the Git repo, and do that expensive analysis phase in the build. Let's say this takes 6 or 7 minutes, even with Bazel. Now let's imagine a second CI run is triggered. Even if this is assigned to a completely different executor, with our cloning strategy, it'll be much faster. We can load the snapshot, but now we no longer have to prepare the build because it's already on the machine. And syncing the Git repo and the analysis phase and the build are significantly faster. So like in the example I showed before, this could be something as fast as 10 seconds. But of course, performance improvements this good can't come too easily. And there were definitely some pain points with Firecracker snapshots out of the box. Snapshot files are really large. A single disk snapshot can be over 20 gigabytes. And this makes them expensive to transfer, copy, or even just write. We literally had to run 4 times as many local SSDs just to handle the writes initially. And this makes them really hard to efficiently reuse. It was too expensive to create a copy of the entire snapshot file, so we made the snapshot files mutable. If a cloned VM wanted to use a snapshot, it would directly write to it. And I'm sure, as you can imagine, that approach is not scalable at all. That means that only one cloned VM can start from any given snapshot at a time, because if multiple VMs were using the same files, they would clobber each other's changes. So if you have any additional CI workloads greater than the number of snapshot files available, the additional workloads would have to start on slow, clean runners. And in practice, it wasn't actually feasible to share these snapshots over the network because they were too big. So during executor scale-ups, all workloads that were assigned to the new machines would have to start on slow, clean runners because these new machines didn't have the snapshot files locally. Another problem we faced was we frequently had to throw away our very valuable snapshots, and this would exacerbate this clean runner problem. To be safe, if one of our CI runners had an error, we would just throw the snapshot away because we didn't want to risk corrupting CI runs that could get assigned to this snapshot. But this problem was especially bad during executor restarts, which would break the running task stream and generate errors. So when we had a machine restart, we would essentially throw away almost all of our snapshots, making all subsequent CI runs a lot slower. And machine restarts can happen at any time, whether from deployments or automatic Google Node upgrades. And in a lot of situations, we actually like that we can treat our executors like any other resource that we can spin up and throw away at will. And you would want your system to be fault tolerant throughout that, and ours just wasn't. So we wondered, what if we could split our snapshot into more manageable chunks? Then we could store them in a remote cache that would be much more resilient, and we could do cool things like compress the chunks for even more efficient storage. The problem is the kernel expects disk and memory to look a certain way. So if you attach a disk to a VM, the kernel expects the disk to be there. The kernel wasn't built to do fancy things like serve compressed blocks from a remote cache. So we realized that if we wanted to do cool things like clone VMs over the network, we would have to implement this ourselves and manage disk and memory access. Then we could store the backing data however we wanted. So we introduced user fault FD to handle memory access and Fuse to manage disk access. As a quick memory review, when a process requests memory, the kernel assigns virtual memory to it. So while the process treats this like data that lives in RAM, it isn't actually guaranteed to live there. Often the underlying data will live on disk, and this abstraction was created because it lets processes use more memory than the physical limits of a more expensive RAM chip. When a process tries to access a virtual memory page that hasn't been allocated, it triggers something called a page fault. And this is where the kernel goes to disk and actually copies over the underlying data into memory where the process expects it to be. So let's take an example. We have VMA with a warm Bazel instance, and we take a snapshot of it. So this dumps this massive snapshot file into disk. Now, when we have a cloned VM trying to access its memory, this will trigger a page fault. Control is transferred to the kernel, which will then go to disk and bring the data from disk into RAM, and then resume the original process in the VM. By default, the kernel handles page fault. User fault FD is a technology that lets developers handle page faults in user space. So this lets you define custom behavior for how your memory is loaded. And that would let us serve memory blocks from a remote cache or add any custom implementation that we wanted. This is the exact same diagram that I showed before. I've just replaced the kernel with the user fault FD handler. So in this situation, the UFFD handler is responsible to going to the disk and copying over the relevant data to memory. But because this is user implemented, we now no longer have to hold the assumption that the underlying data lives on disk the way that the kernel expected. We can now replace this with our caching layer. So we can split up our snapshot into smaller, much more manageable chunks and store them in a remote cache. And this flexibility gives us a lot of power. For example, we can compress the data, and it also minimizes data duplication and lets us utilize our powerful caching nodes, which are optimized for data transfer in a way that our executors maybe weren't. It's also much more scalable. So even if we were somehow able to share our local snapshot files on disks, at most a couple VMs or different machines would be able to access it at any given time. But with a remote cache, we can have an infinitely scalable set of VMs trying to fork from the snapshot at any given time. And these VMs can be on completely different machines, letting us reach our goal of cloning VMs over the network, which is pretty cool. On the disk side of things, we use Fuse, which stands for File Systems in User Space. So just like how UFFD lets us capture memory reads and writes, Fuse lets us capture disk reads and writes. So the overall architecture looks about the same. The way that you set it up is just a little different. We can mount any number of Fuse-backed disk images to empty directories on the VM, and it'll just treat them like any normal disk. And when the VM is trying to access the disk, instead of transferring control to the kernel, which would go to the disk, the kernel will transfer control to a Fuse server. The Fuse server can then be configured to call callback functions that are user implemented. So this is where we can implement our custom caching code. And the flexibility that we get from UFFD and Fuse is really exciting because it unlocks all of this future optimization work. So for example, we can be more efficient in how we chunk our snapshot files. Right now, we just split the snapshot files into equal-sized chunks, but we can use something like content-defined chunking to be smarter in how we break them down, which lets us minimize data duplication even more. We can also be smarter in how we match an incoming CI workload in a snapshot. So you can imagine we can use something like creation time or whatever. And so even if we've never built a commit before, we can try to match it to a snapshot that will minimize build times as much as possible. And we'll also be able to dynamically save snapshots in the background. So right now we have to wait for the VM to finish execution, and then we serialize the entire thing to a snapshot, which can be slow. It can take a couple seconds. But with something like user fault FD write protection, we can capture writes as they happen and dynamically update the remote cache chunks. Yeah, so a lot of hard work has gone into this. So I thought I would finish off my presentation with a little demo. So here I'm triggering a CI workflow from the command line with our execute workflow API. And you can see that this is for the build buddy repo, and we're running the test action, which builds and tests our entire test suite. So here I'm copying the invocation ID so that we can view the CI run in our UI. You can see that this takes a little time because we have to prepare the CI runner. And we're doing a lot of that setup work that I mentioned before. So we're cloning the Git repo and all this other stuff. And at this point in the demo, you might be a little bored. And this is probably where you would start to get bored in a normal CI build as well. So this workflow ended up taking 6 minutes and 2 seconds. Here, I run this same workflow again, but this time it gets assigned to a cloned runner. So you can see in the logs at the top, it says syncing existing repo, showing that we did in fact get assigned to a cloned runner. And you can see that the build has already completed. And this time, the build only took 20 seconds. So the good news is that if you want to take advantage of all of our hard work, you can use our Workflows product. And the basic version with out-of-the-box Firecracker is already live in production. And while this version isn't perfect for some of the reasons I mentioned, it's still pretty good. And we were able to significantly speed up our CI with this. In most cases, our CI runs were still completing in seconds. And we just launched our over-the-network version with Fuse and UFFD and Dev. So hopefully that makes it to prod soon. And something cool about our workflow product is it's easy to integrate into pre-existing CI pipelines with that execute workflow API that I used in my demo. So if you don't want to migrate your entire pipeline, hopefully this makes it a little smoother. But also, if you don't want to use our product, we completely understand. And all of our code is publicly available on GitHub. So if you're curious or you want to try and roll your own, we encourage you to check it out. It's pretty gnarly, but pretty cool. And of course, Slack us with any questions. Yeah, so finally, I just wanted to shout out the Build Buddy team, and especially Brandon, who I primarily worked on this with. Does anyone have questions?
Yeah, hello, thanks for the nice talk. I wondered if you write into the snapshots while the VM is down. Doesn't that lead to unexpected results? I guess, I mean, like usually if you run on an operating system, you wouldn't expect the disk to instantly change like below you. And I guess that would kind of feel like that from the point of the VM.
Yeah, you mean if we're like dynamically capturing the writes, how that will affect future runs?
No, I meant like for the old version where you basically, after the run, write to a snapshot image. And then, as I understood you, while this is called, you actually mutate that image to update it to a new state. And then you start a new VM from that. And I just wondered how to make that safe, because it sounds interesting for other things.
Yeah.
But I wondered if that isn't problematic.
Yeah, so we would, when we pull down the snapshot, we have a local version of all of the chunks, and we have copy on write implemented to ensure that writes from other VMs won't clobber the snapshots that other VMs are already using. Is that answering your question? Sorry.
Not really, but probably it's too complicated. I think this is already the new version, right? But okay, I think near me there was like another question.
Yeah, perhaps a bit related to that. I was kind of curious, did you have a look at using copy on write file systems like, or file systems with built-in copy on write capabilities like ZFS, or I think ButterFS has it too, for this problem?
Yeah, we did. And right now our VMs are using the ext4 file system, which doesn't inherently support copy on write. And so we were considering whether we should just migrate file systems or just consider another approach. And we ended up deciding to just implement it ourselves because of all of the additional flexibility it lets us have.
And one perhaps related question, like how are you actually running these? Are these Firecracker VMs running in a nested virtualization context, or are you running these on bare metal hosts?
They're running on bare metal hosts. Yeah.
Thank you. Very interesting talk.
Okay. So first of all, I think it's super impressive that you guys implemented UFFD. I'm already like implementing Fuse is like, oh, okay, cool. But like, I guess you have your own kernel module or something for UFFD. And yeah, I think this is like real engineering. I really love that.
Thank you.
Although I do want to zoom a little bit out, and if I understand correctly, basically what you guys are doing, you ensure that your Bazel server is like a long-running process, and you don't have to pay all the time for the restarting this process and do the analysis. How do you handle different build configurations for the same CI jobs?
Yeah, so in our snapshot key, we hash the configuration. So if you have a different configuration, you would get a completely different snapshot.
Okay, so it comes out of the box. It's not.
Yeah.
Cool.
Maybe it's a clarification question first, but so you said
if I understood right, you have sort of a base VM run, and then you snapshot that and you replicate it to generate multiple runners. And then if those run in parallel, they're going to generate separate state. Do you end up merging this state back into one, or how do you decide which of those becomes the basis sort of for the next state, and how does that affect performance?
Yeah, that's a good question. Right now, just to keep it simple, we basically only update the master state when the master branch has a successful run, and we just have this one version of it. We want to support it so that if you're making a lot of changes on the same branch, we could also have a snapshot for that specific branch. Yeah, and of course, there's performance trade-offs for this. We could try to update it less frequently, but then that would mean that the subsequent runs maybe aren't as fast because we're not getting the updated changes. So yeah, for our personal use, we're just going to experiment it and tweak it and see how things look.
I also have a question. I think it's check. Okay. I think it's quite common that people are still using Docker containers to insulate like a development environment, but that also means that people cannot just start using this way that you proposed with Firecracker. So the question is there an easy way to migrate quickly from Docker to Firecracker?
Yeah, so one of the reasons we chose Firecracker is that it's actually really easy to run a Docker container on Firecracker because a VM is essentially a full machine, so it's really easy to just run your Docker container there.
Yeah, I'm just not fully following how we can later access Bazel server if it's running inside of container, but I guess I should just try it out and see it myself.
It should look exactly how you're running Bazel in your Docker container currently. You're just moving it from whatever runner it was currently on into a Firecracker machine. Okay, cool. Thanks, everyone.
All right, thank you, Maggie. That was an awesome talk. Now, coming up next, we have Sushane. I don't know how to do this. Okay. Yes, okay. Welcome.
Okay, see if I can do stop classes. Okay. Hi, folks. I'm Sushane, tech lead for Stripe's Build Infrastructure team. Stripe minted its first remote Bazel service back in 2018. We've been investing in our homegrown services since then. I'm excited to share how we've tackled some of the most interesting challenges that we've encountered along the way. So let's kick off with a quick recap of Bazel remote caching and execution, just to get everyone on the same page. This will be a bit remedial for some of you, so just bear with me a little bit. So remote caching allows the Bazel client to avoid redoing work that's already been done. Yeah, we all know that. It communicates over HTTP or gRPC with the remote cache endpoint that provides two gRPC services, the Action Cache service and the Content Addressable Storage service. The Action Cache service lets Bazel store and retrieve cached actions. Right? The Content Addressable Storage service, also known as the CAS, lets Bazel store blobs indexed by their checksum. Right? Stripe's Action Cache stores results in DynamoDB, and our Content Addressable Storage stores blobs in S3 or DynamoDB, depending on how big they are. So remote execution, on the other hand, allows the Bazel client to distribute build and test actions across multiple computers. Aside from like the standard performance and efficiency things we get about from that, it also avoids like the classic, yeah, that works on my laptop, doesn't work on your laptop problem, because actions are executed on this standardized environment that users can't directly control or impact. Bazel can communicate with the remote executor gRPC endpoint using the execute RPC. Under the hood, our remote executor endpoint is a scheduler that load balances across an underlying fleet of workers. That's not super uncommon. So with that background out of the way, everyone's on the same page. Let's talk a little bit about Bazel infra at Stripe. Our Bazel remote infra is responsible for running tests and builds for Ruby, Java, TypeScript, Go, and half a dozen other languages. You name it, we're probably building it with Bazel at Stripe. So everyone hates waiting on builds, For example, our TypeScript devs, they're used to their blazing fast native tooling that's powered by some bespoke incrementality baked into it. We execute 80 million actions remotely every week. Making them as fast as we can is crucial to providing like a delightful user experience for everyone. Even our service infra relies on Bazel through remotely executed Terraform builds. Keeping our builds reliable, regardless of external downtime, is critical for us. Even if like Oregon were to sink into the Pacific, we want our builds up, right? So every calendar year, our remote actions execute for over 100 years in aggregate, and our users expect minimal disruption throughout this process. Go services underpin our security. Even a single poisonous instance across the 65,000 vCPUs that run remote actions could allow an attack against our in-house certificate authority. So a secure foundation for our builds is just non-negotiable for us. So we've got 3 major goals that I've laid out: performance, reliability, security. So for the rest of our time together, I'll take you on a bit of a whirlwind tour through some of our more novel approaches to challenges in each of these spaces. So we'll kick this off with security. Remotely executed Bazel actions, they have to run somewhere, right? So to amortize the startup costs and the overhead of supervising all these actions, we reuse trusted workers across multiple actions. A single worker can run dozens of actions at a time concurrently, and hundreds of thousands of actions during its lifetime until it gets shut down and recycled. Sandboxes are how remote execution systems manage all of this stuff. So each action executes in its own sandbox. They're a key mechanism for ensuring actions are isolated from a security perspective, but they also have a bunch of user-facing benefits. Like Kubernetes deployments that you might be familiar with, they also have like resource and file system isolation. It means that actions just don't have to worry about noisy neighbors and the problems that those cause. So until late 2020, our execution service relied on gvisor, Google's user space container sandbox. But as we brought more languages into the Bazel fold, like that slide before, gvisor just couldn't keep up with what we wanted. For example, running a single Ruby unit test that immediately succeeds and didn't do anything, took 6 seconds under Docker and 10x longer in gvisor. We narrowed down this issue to gvisor's file system overhead. Languages like Ruby and Java, they resolve imports by linearly scanning through a load path or a class path. In that Ruby test file, we observed over 600,000 file system syscalls, searching a load path over 500 directories in that 6 seconds or that 60 seconds. So the file system overhead emulation, it led us to gvisor. Sorry, led us towards Firecracker. Firecracker's micro VM approach improved our security posture by further reducing the attack surface just to the Linux KVM, and it solved our problem with close to native file system performance. As you heard earlier just now, it also gives some other really powerful capabilities to the table. So that's that one. One of the benefits of Sandbox is improved hermeticity control, right? So we don't want actions making arbitrary requests to the internet. It harms their reproducibility, it harms their determinism, and it provides a vector for all the supply chain attacks that we're all scared of. But it turns out, like in life, we just can't always avoid the internet. It's pretty sad. For example, we have these integration tests, right? They want to use browser stack to render our front ends on a bunch of devices. The prospect of maintaining a bunch of iOS devices is just not very exciting to us. So these tests need access to these browser stack APIs. So here's an example of how our users would declare that this specific target's actions can access the browser stack domains. Pretty straightforward stuff here. For each Bazel action that requests internet access, we spin up a TCP listener inside the micro VM that acts like a simple SOCAT, the blue box here. The SOCAT just shoves bytes into this VSOC, a mechanism for network communication between a VM and the host kernel. On the output end of the VSOC, we connect a dedicated instance of the smokescreen library, an open source connect proxy. It's orange box here. This per action smokescreen then proxies over to this other instance of smokescreen at the VPC level, which in turn proxies to the internet. So it's proxies all the way down. So this SOCAT-esque TCP listener here is exposed to the action environment itself through the HTTP proxy environment variable. This is a standard environment variable. All HTTP clients kind of know how to use it. And that just makes actions work out of the box that want the internet. But only those domains, right? So at this point, you might be asking yourself, why is Sushane making such a big deal about security and then allowing any action to just talk to the internet, right? I could tell you that CI jobs that run tests, that only run tests can access the internet. But that really shouldn't satisfy you, right? Wouldn't the remote cache that we talked about allow other jobs to access these internet poisoned actions? So that's where cache tags end up coming in. So to make that more concrete, the orange CI job here should have access and should be allowed to read this cached remote cache entry that accesses the internet. But the green job shouldn't, because it ends up producing some binaries that we end up deploying to production, right? Unfortunately, a naive remote cache would permit both of these things to access this cache entry. So here's where tags end up coming into play. So rather than being indexed by action digest, like we saw earlier, map from action digest to result, our action cache is indexed by action digest and then a set of tags. So this network tag here denotes an action that required network access. Kind of straightforward there. When fetching actions from the result cache, Bazel clients can specify a set of tags that they're willing to read. In a header, a remote cache service filters the existing cache results with a subset operation. So by injecting a tag without the network header, our green CI job is prevented from reading this poison cache entry we talked about, poison, I guess. And the orange one can, since it has that network tag. So we've got more than just network, right? Our insecure tag denotes an action that was built locally rather than remotely. So it can't be set trusted in any sensitive situations. In the future, we plan to use tags like containerd to denote actions that were built with containerd. It's kind of like Docker. Containerd is a less secure sandbox, which could offer performance improvements for tests and a little bit cheaper. So at the end of the day, we're much less worried if tests do something kind of wonky, and the worst case is an attacker modifies whether test passed or not. Not a big deal. So the tags just aren't namespaces. That's not quite what they are. A single action can have multiple tags, right? By default, we tag our actions with the environment that they're built in, like QA or prod. Our QA users often send QA comma prod so they can access action results and cache results from both QA and prod. A prod reader that sends containerd and network, for example, can access results that were built with containerd or use network access, or both of those two things. So let's switch gears to reliability. We've got some pretty fun tricks up our sleeve here. So you read that right, time traveling. Okay. On the 1st of January 2020, this test started failing, along with like dozens more just like it. We call tests like this one time bombs, since they go boom whenever the calendar ticks to a specific date. Plenty of tests fail at UTC midnight, the day they're introduced, and I've even seen tests that fail only on leap days. Yeah. We used to take bets on how many of these would fail every New Year's. And that was really fun for our skip. It was a lot less fun for us when we got paged on New Year's. Users were pretty happy. They just couldn't merge their PRs, right? Fortunately, Bazel remote execution provided us an opportunity for a highly leveraged solution to this problem. So with a single exec property inside the platform used for remote execution, type container clock time, Bazel clients can convey a desired starting clock time for actions. Here, you can see we're traveling to August of 2029. Since our sandbox is powered by micro VMs, we could translate that exact property into a call to the set time of day syscall within our init process. This one weird trick, it eliminated time bombs once and for all for us. So Bazel's remote downloader is another one of our core reliability mechanisms that we have. So you might be familiar with the experimental downloader config flag. It tells the Bazel client to rewrite URLs before making an HTTP request. So we don't quite use that. Instead, we use the experimental remote downloader flag, pointing to a gRPC implementation of the remote asset API. This gives us a lot of leverage, talk about it in a bit, especially in combination with this very, very succinctly named flag, experimental repository cache URLs as default canonical ID. Okay, got that out. One breath. Okay, the remote asset API, it works by having the Bazel client issue a fetch blob RPC, step one here, with the URL that it wants to download. Then the downloader service goes and pulls that blob from somewhere, for example, from Artifactory, and it writes to the CAS. That's step two. And then it returns the size and the checksum. If the blob isn't already if the blob's already present in the CAS, it skips the write. So then that allows the Bazel client to read that from the remote cache with 3. So this API, it isn't too fancy, right? But it gives us just the knobs we need for reliability. For example, we can force that all our downloaded blobs have a checksum in the source to ensure deterministic downloads. With the canonical ID flag, we also get to ensure that the checksums match the URLs, even better. We're also resilient to upstream downtime. You might remember earlier this year when github.com changed its git archive checksums. Since our downloader is backed by a caching proxy like Artifactory, we didn't even notice this problem. Finally, we hide the actual artifact sources from our users. This is proxy things like S3 objects and transparently change our backends. No one notices. And so finally, what you've all been waiting for, performance. Let's dive into some of our system's features intended just for performance. We'll kick off with one of the user-facing features, integrated tracing. You might be familiar with Bazel traces. You can create them with the -- profile JSON flag and open them up in something like the Perfetto UI. You might also be familiar with distributed tracing. We support both of these for our builds, but none of them cover the bits of execution our users are most interested in, the action itself. It's just one big opaque span in this honeycomb UI here. So that's where the first part of our integrated tracing support comes in. Using the stripe/tracing exec property, users can specify an HTTP address and/or a gRPC address. Then we automatically spin up servers at those addresses that accept Chrome trace event JSON. That's the same format that Bazel traces use. Here's a minimal trace that our JS infra team added to their Webpack builds. They are actively using traces like this to debug performance issues. Now, our execution service exposes these traces without interfering with the action's actual outputs. Right? If the traces were action outputs, on the other hand, actions would become super non-deterministic because these traces have things like timestamps in them. And that would totally wreck our cache hits. So that's not all the stripe/tracing property supports. Google's Perfetto system isn't just useful for making those pretty traces, right? It also provides a toolkit for system-wide tracing and profiling that plugs directly into the Linux kernel. So we support transparently kicking off Perfetto within an action and configure it together perf events, process stats, ftrace events, and system stats. Each of these 4 modes is configurable straight in the exec properties for our users, as you can kind of see here. And I have various little knobs to enable and disable little features. So here's an example trace from one of those 4 modes, ftrace. This trace is from a JavaScript test action. There's 8 cores for its micro VM. And you can see the details what every core is up to. Lots of fun colors there. On the other hand, like the process struts mode thing I mentioned, it includes memory, I/O, and CPU usage for each process within the action. I'd say that even just this ftrace thing here gives you like 4 orders of magnitude more information than we were seeing earlier with one single blob, just nothing in there. So our users are currently enabling these on an ad hoc basis when they kind of want to figure out something about some action that doesn't quite behaving right. In the future, we hope to support them just enabling it straight all the time and providing some kind of sampling configuration. And then we can sample that out and we can spot regressions over time. Traces can be pretty expensive. So switching to something that's more behind the scenes. Action merging is one of our simplest yet most effective strategies. Basically, if someone's already asked for an action to be executed, just wait for them to do it instead of doing it yourself. Sounds pretty simple, right? Here's an exaggerated example just to show you what it looks like. We've got 2 sequential commits to the main branch that edit 2 unrelated projects, commit A and commit B. Say commit A edits a project with a single action that takes 20 minutes long, like a long integration test or something. Now commit B's build, it's got to run that too, since it only ran 5 minutes later. It's not cached yet. Kind of sad. So we can do better than this. With action merging, commit B's execute RPC blocks on commit A's RPC, reusing its result and resulting in both builds completing simultaneously at that 10:50 a.m. point. So commit builds B's build is now 25% faster. So there's a lot going on here, but our action merging implementation is actually pretty simple. It's powered by optimistic locking in Dynamo and some polling on top of that. Here, execution A started first, and it took an exclusive lock after 15 seconds of executing. Then it refreshes its lock every 15 seconds afterwards until it's done at 2 minutes 15 seconds. On the other side, execution B, it found a lock because execution A was already well underway. It started waiting on it and checked the lock every 5 seconds, and it didn't expire, and it got it back at 1 minute 45. It also was able to reuse those results from DynamoDB. So if the initial check didn't reveal an existing lock, or that lock expired at any point, execution B would have just given up on waiting and done the work itself. So action merging is a big performance win for our users. It's obvious enough for end users to notice just by looking at build durations. It's also a huge efficiency win, reducing our load on our executors by 20%. But it's not quite perfect. If a flaky test happens to be merged across 5 builds, you suddenly have the impact magnified 5x of that one flaky test. We've also seen other correlated failures, like flaky resource suggestion on build targets. So we're exploring some hedging strategies to kind of mitigate that a little bit. So one idea is like if 8 clients tell us to do the same thing, we'll execute it 4 of those times and then pick the best one of those 4 times. So we've also identified that our implementation leaves some efficiency and some performance on the table. In our Java Scala Python monorepo, up to 15% of actions are unnecessarily repeated, and we look at them afterwards. So we're thinking of moving action merging into our scheduler rather than our executors, and that would allow us to hopefully eliminate that waste and implement some of the more fancy hedging strategies that I just mentioned. So the next strategies we'll discuss are motivated by actions with a lot of inputs, and you might know what's coming here. It's like a black hole filled with node modules directories, right? So huge swaths of our actions have input roots with over 500,000 files, right? Getting these files into a micro VM is a lot easier said than done. Sort of one way of doing it. We'll talk about another one. LVM snapshots are our first line of defense here. So let's first go the traditional way. So like sandboxing with like Docker. So first thing, your build worker goes and downloads a bunch of blobs into this thing called the blob cache, and they're named based on their checksum, kind of similar to how Bazel's remote cache is laid out. Then your worker creates an input route with hard links. We'll call it a hard link forest. For example, a file here called foo, just a hard link back to the file here with its content. Finally, create a bind mount to make it so that the hard link forest is visible within the action sandbox. Unfortunately for us, bind mounts aren't quite possible with Firecracker and KVM virtualization in general. Because the guest and the host don't share a kernel, they're completely disconnected. So this is super fast. We still want something fast, though. So we settled on LVM snapshots. LVM stands for Linux Volume Manager. It's kind of like a partition manager, but a lot fancier and built into the host kernel. So the first 2 steps here are unchanged. But instead of bind mounting, we use LVM APIs to create a copy on write snapshot of this hard link forest. The snapshot's block device is then attached to the running VM, Firecracker VM. It's kind of like how you might stick a USB port into your a flash drive into your PC's USB port. So this lets us transfer gigs of data across hundreds of thousands of files, just a couple hundred milliseconds, without using any extra disk space. But we can even really transparently GC blobs here because the action at the end of the day is using a snapshot, right? So this strategy isn't perfect for everyone. We're exploring some alternative solutions. For example, non-sensitive actions could just execute with containerd and use the bind mounts that we talked about. We could also use fancier file systems like NilFS that allow snapshotting built into them, and NFS network file systems and things like that. Especially for actions with fewer inputs, that could be particularly helpful. So let's step away from fancy Linux features for a second. Let's talk about our tree cache. So we'll kick this off by talking about the remote execution protocols, more esoteric RPCs, the get tree RPC. So the get tree RPC takes a root directory as its primary input. Then it returns a stream of leaf directories by recursively walking the given root directory. As far as I know, the Bazel client does not actually use this RPC, but it's pretty critical for a remote execution worker. Our implementation uses it to unfurl a action's input route so that it can create a file system for the action to run inside of. So unfortunately, serving this get tree request is pretty tough for large directories. Our naive implementation took over 10 seconds for single RPC for like large Ruby vendor directories, pretty similar to node modules, but for Ruby. So here's an example of a tree on the left where a single file, badge.tsx, changed since the previous actions execution. Every other branch in the tree hasn't changed. The list of flattened directories in each one could be safely used. So that's what we did. Directories that aren't too deep in the tree are cached in DynamoDB as a map from that directory's digest to a digest of the flattened tree, and those flattened trees are stored in the cache. This dramatically reduced the cache fetches we needed to respond to a large get tree RPC. But this wasn't quite enough to fix it. We also switched to walking this tree serially to walking each level of the tree in parallel with a worker queue. Each worker either fetches the unfurled tree from the cache, the tree cache, or recursively descends. With both these optimizations in place, we saw a 20x improvement in get tree latency, hovering around 500 milliseconds at the end of the day for large trees. So the final stop of our random walk is another fun Linux feature, SquashFS. SquashFS is a read-only Linux file system. Imagine if you could just mount a compressed tarball and arbitrary processes could read directly from that. So we found that large trees like node modules continue to pose performance challenges, even with that LVM snapshot thing we just mentioned. Building these Merkle trees inside the Bazel server and checking for missing files in the cache for every single action were both expensive operations that just didn't scale well for us. So our solution was adding Bazel targets that create SquashFS images of directories that don't change frequently. Here's a partial MK SquashFS readout for a node modules directory. It shows that we went from 108,000 files in here to a single file, and the compression eliminated almost a full gig of disk space. So targets are responsible for telling us how the SquashFS files that they want should be mounted. They're specified through an exec property, either directly or indirectly. Indirectly is required when the set of mounts isn't known at loading phase. The exec property looks a little bit generic, but really we only support SquashFS mounts. After parsing a list of mounts, there's just a couple steps left for each SquashFS. First, we do some Linux shenanigans to get a loop device and bind the SquashFS to it. Then we create some temporary directories, the blue things here. We mount the SquashFS, the lower directory, and then create an overlayFS at the destination with these three directories. OverlayFS is just another Linux file system that basically allows for unioning multiple file systems. It's how container image layers are usually wired together. The overlayFS mounts allow Bazel actions to write to these directories, even though SquashFS is a read-only file system. So you get writes even when you would otherwise. So with our node modules example, the node runtime never even notices just running files from a SquashFS, and everything just works transparently. To our surprise, some of our largest actions actually experience a 10% speed up relative to running natively completely outside of Bazel. We think this is due to SquashFS providing improved I/O locality. For small files smaller than 4K, a file system block, SquashFS is actually going to compress those together for you. In our JS builds, we also saw a 50% drop in memory usage, which we're all happy about. This was entirely attributable to smaller Merkle trees. Finally, the hard link forest that we talked about can require an order of magnitude fewer hard links, a lot fewer syscalls. So we've talked about security, reliability, and performance. There's always trade-offs when it comes to these goals. But we've worked really hard to get the best of all the worlds in our builds. It's safe to say that Bazel doesn't always cater perfectly to the workloads that our users are interested in. Fortunately, the flexibility of the remote execution protocol allows us to build custom features into our services that really push the envelope of what's possible. By working closely with our users, in particular all of our Stripes language teams, we're able to focus on building what's most impactful. We found time and again that these power user features we built are quickly adopted by other teams as well to improve their builds. Thanks for listening. I hope you're inspired by something that we've tried out. I also wanted to give a quick shout out to all the individuals and teams at Stripe that have contributed to our remote build services. We've had major contributions from our JS infra team, our Ruby infra team, and our security teams over the years. I'm just here talking about all of their great work. Any questions?
I would just speak it. Hey, oh, no. All right. Hi, I just want to ask in detail about the cache tagging. You said those were sent to the remote server using a spatial header. How do you define that headers in your build for specific actions?
So it's not per action, it's per invocation, because the security model is basically that if you end up having a pipeline or a job read something insecure, it's basically poison for the rest of its life, right? So that's a gRPC header. The format is just a proto that's a string of tags, basically. If you don't provide that header, you default to just like your environment. So you can read things that are built with your environment securely without network access, without any shenaniganry. That's what you get to read. But if you get to specify more, then you get to read more interesting things that might break some invariants that we like.
Can I ask a question? This is pretty amazing stuff. How long did it take you to build all this, and how big is the team?
I think that our team is about 10 people, but a lot of this stuff has been built up over the years. I wouldn't say it was built up in any like specific big master plan, right? It isn't that bad. Yeah.
I have a question over here about the overhead of gvisor. Do you think that the overhead you see with gvisor is specific to that implementation, or would you see a similar kind of overhead with any mechanism that involves like say like NFS or Fuse or anything where you're like virtualizing file system access?
So I don't know. We haven't tested this yet. But the problem with gvisor in particular is that it's user space file system implementation. That's similar to Fuse. But there's also a process jump between things. And gvisor actually released a different version of their file system, v2 or something. Just wasn't good enough still. And yeah, we'd have to try NFS. We'd have to figure that out. We're curious, but
thanks.
Hi there. Oh yeah, this, here in the center. Yes, yeah, that's where I am. So I was wondering, with all those optimizations you have in place, what sort of like the ratio of time being spent on input root population versus actually executing the action? What's the overhead?
it's a good question. So for actions that run a longer time, we don't really mind as much, right? But we have a lot of actions that want to run like for say 10 or 15 seconds, right? And if we spend 10 seconds populating the input root, they're gonna be like, why am I using this Bazel thing? It's trash, right? And so we wanted to get those actions to be able to talk. We're talking like low single-digit seconds at the upper end for those.
I had a question about the tracing. So we are showing the sort of within action tooling specific tracing. I'm wondering, how is this done? Is this like tooling specific instrumentation, or how does that work?
So the system traces I mentioned, they're from Perfetto, right? We don't have to do anything. We just let Perfetto write the files, and then the Perfetto UI can then process the protobuf that those write. For the application specific ones, yeah, the action under load has to be able to produce these traces and push them to us. But a lot of folks are already integrating Chrome events trace style. So all we have to do is, instead of write to a disk, just push to the server, done.
Over here. All of this sounds pretty nice. Where can I see any of it?
Yeah, I think it's you can come to Stripe. You work with us. But yeah, I think we're totally open to people trying to implement the same stuff. We're happy to help. I don't know if we're necessarily thinking about open sourcing any of it. At the end of the day, a lot of this stuff is not super complicated to kind of sure buddy could implement it in like, I don't know, a month or something. So hopefully they're inspired.
I guess the follow on to that is that it seems like you've done some interesting things that allow your clients to control things like the tracing APIs, and the SquashFS identification. That seems like it might be something publishable as a standard. Is there anyone working or that we can reach out to sort of seek the ability to publish a set of standards for, instrumenting remote execution in that way?
That sounds really interesting. I mean, we'd be happy to chat about it. I think that either tracing is one, and mounts and remote actions would both be really interesting. I've heard a little bit about remote execution v3. Maybe that's something we could toss in there. Pretty cool.
All right, thank you for saying. A lot of very interesting tricks. Where's the clicker? Okay. All right, so folks, we have another, I think, 15-minute break, yeah, until 2:45. So after this, we have, so obviously more talks here, and then also the IntelliJ and C-Line Birds of a Feather session in Isra Valley. Also more office hours, that's happening. That's one floor up from here. So if you're interested, go join the office hours, talk to the Bazel experts there. Until then, see you back here.
Hi, hello everyone. I'm Kai. I'm so excited to be here to share our journey of migrating a multi-platform game engine to Bazel. So we have a lot we want to share today, so let's just get it started. So I came from the Evil Echoes team. Evil Echoes is a space game developed by NetEase. It's powered by our in-house engine named LeoX. So LeoX has a long history since 2009. And since last year, we decided to improve its build system. So Evil Echoes has a very small development team. We have only 20 developers joining the migration, and nearly only half of them were working with LeoX. This affects our migration in two ways. On one hand, we have limited resources. So as you can see, we had to do some pretty hacky stuff to work around some issues we encountered. But on the other hand, having a small development team means that we can easily adjust our workflow, which made our migration easier. So before Bazel, a full build of LeoX engine took us more than 20 minutes. If we updated some rendering-related code, which happens quite frequently in game development, the build time was 14 minutes. So as you can see, this greatly impacted our productivity. So we decided to find a new build system to improve it. Now, here are the challenges we faced. LeoX targets iOS, Android, and Windows platform. And we sometimes need to compile part of the engine on the server side, which is Linux. So that's 4 different target platforms. In order to build an iOS app, we need to use macOS plus Windows and Linux. That's 3 different host platforms. On the language side, LeoX mainly uses C++, so we have more than around 2 million lines of C++ code. We have very few Java code to interact with Android system, and likewise, we have some Objective-C code to interact with the iOS system. Now, software development is very complicated, so we need the profile and the debug tools provided by IDEs like Android Studio, Xcode, and Visual Studio, especially when you target the mobile platforms. So we need the build system to can be integrated into all these 3 IDEs. So with all these requirements combined, it looked like an impossible task. So imagine how excited we were when we found out Bazel's homepage. And it's almost as if it's tailor-made for us. And we were very pleased to find out Bazel lived up to all its promises. So in February last year, we wrote our first Bazel rule. The first fully Bazel build version took us 3 months. Then we spent another 2 months to add the IDE integration and remote cache support. We added the remote execution support for iOS and Android build with the build farm in the following months. In October last year, we finally released our first Bazel build version to the players. And we finally got some time to work on the custom remote worker for the Windows platform. I will explain it later. And finally, at the end of the last year, we had remote execution set up for all 4 targeted platforms with build bar. Now, after moved to Bazel, the Windows full build time dropped dramatically from 27 minutes to 4 minutes. For iOS and Android, it's even faster with 2.5 minutes. So this sounds like an unfair comparison because there actually low build happened with all the remote cache hitting. But this did save us a lot of development time for real, especially for our CI jobs. Now, when we do update the rendering code, the incremental build time dropped from 40 minutes to 4 minutes. And I need to mention that this build was running on a remote cluster composed of 3 Mac minis. So if we throw more Mac minis into the cluster, we can further cut down the build time, but that's with the hardware we got for now, and we are quite happy with it. So let's start the migration. Before Bazel, LeoX uses CMake to generate Android Studio, Xcode, and the Visual Studio projects to build for each target platform. all the C++ dependencies are managed by Colab. It's a very simple setup. So we want to migrate seamlessly from CMake-based solution to Bazel without stopping the normal development. So we decided to move the CMake library targets one by one to Bazel. So after we moved a library to Bazel, we use the CMake import library target to import it back into the CMake generated projects. This library target is further depends on another custom target, which is responsible for calling the Bazel build command. So in this way, we get a hybrid build system. So the local developers still use the CMake to generate the projects, but some of the libraries are already built with Bazel. Now, Bazel already also need to share the third-party dependencies managed by Colab. Luckily, there was already a tool for this. It's called the Colab Bazel generator. It's available since Colab 1.61. Now, the generator works like this. So if you execute the Colab install command to install all the third-party dependencies, the client will first read the Colab profile from your project, reload all the dependencies, download all the required libraries from the server, save them on the disk cache. Then it asks the Bazel generator to analyze those libraries and generate the Bazel build files automatically. The Bazel generator will also create a macro to load all the Colab dependencies. So it uses the local repository rule to load all the cache from the load all the libraries from the local Colab cache. This is the build file generated by the Bazel generator. It's actually very simple. Now, the generator was in experimental stage back then, but it was generally usable. We helped to fix a few minor issues. The most issue we encountered are due to incorrectly packed libraries. The real issue was that we had to call the Colab install command before Bazel build if we are not sure any of the third-party dependencies have been updated. But we really hope all our developers can build the engine with a single Bazel build command. So we decided to replace the local repository with HTTP archive. So when generating the macro, instead of using local repository, we use HTTP archive to download the library files from the Colab server directly. In this way, the macro and the build files all don't contain any local passes, so we can commit to the repository. Other developers can just use a single Bazel build command to build the whole engine. Now, we still need to call the Colab install command when we update the third-party dependencies. Now, I think we can write a repo role for this. So we can write a repo role to execute the Colab install command during the build in Bazel, something like this. But we have limited resource and we don't update our dependencies frequently. So the current solution is okay for us. Now, after we finished Bazel, the integration with Colab and CMake, the migration actually went pretty well. Most of the issues we encountered are due to NewX itself, and mainly fall into three categories. The first one is the include path that allows starting from the root of the repository. So we can get away with this by abusing the include attribute from the CC library, but we really want to take the chance to make our code more correct. So we decided to write a Python script to fix all the include passes. So first, we need to generate the compilation database for NewX project. That's all the tools we used for three target platforms. Now we got the compilation database. We can extract all the included directories for each source files. Now we can try to locate all the included header files in those directories and restore the correct full path. Now, this solution is not perfect. We still make up some incorrectly included paths, but those are quite a few. So we just manually fixed what's left. The second issue is missing the dependency declaration. In the CMake project, So this kind of issue is very easy to fix. We just add them back in the Bazel build file, but it will lead to the trickiest problem we have to solve: circular dependencies. So normally, if we want to break circular dependencies, we have to divide some large libraries. So for example, if library X and Y depends on each other, normally X is dependent upon a very small subset of Y. So we can move that subset from Y into another new library Z. Now, X and Y can both depend on library Z, and now library Y can safely depend on library X. But in practice, sometimes it's very difficult to move the subset out of the large library without significantly changing our code. But we were impatient. We don't want to hold our migration too long, so we decided to create some fake header ending files. So we move the header files from the library Y, but we keep the source files in library Y. Now, the library X built with the library Z cannot be used alone. That's why we call it fake header ending names. It has to be linked together with the library Y, but that's totally okay for migration. We still recommend you to fix this kind of issue after you finish the migration. Sadly, in the later stage, we found that include what you use can help a lot in this situation. We found out that many of the circular dependencies are false dependencies caused by developers copying includes from one source file to another source file. So after we remove those includes, with include what you use, the circular dependencies are already fixed. Besides the above issues, we also changed our linking model a little. For Android build, we switched to static linking for lab C++. Now, in order to use dynamic linking to C++, we need to copy the lab C++ shared SO file into the APK. Currently, Rose Android don't do this, so we cannot use dynamic linking here, but I think this can be easily implemented after we fully move the Rose Android to Starlock. Also, we switched to static linking to most of our labs on the Windows platform, or more correctly with MSVC. So generating and linking with DL needs some special care with Bazel, and we want to keep all the roles consistent for all our platforms. And we are okay with static linking, so we switched most of the libraries to static linking, and in some security-related library remained dynamic linking. But this did cause the linking time increased to 2 minutes. So recently we were thinking about switch back to dynamic linking, maybe with the help of Marcos. After we could build new X entirely with Bazel, we started to add IDE integration. For Android Studio, we use the official Bazel for Intelligent plugin. We don't use Android Studio heavily, but for our use cases, this plugin works quite well. So in order to debug a C++ code, we need to enable a special compilation flag. This flag is also required for you to debug a remote cached library. So I will talk about it later. For Xcode, we started with 2C and then later switched to Rose Xcode project. After 2C was deprecated, both of these tools works out of the box for our use cases. For VS, we found a tool named Lavender. Lavender can be used to generate a Visual Studio project from a Bazel project. It's no longer maintained anymore, but its code has solid foundation. We managed to fork it and update it to work in a short time. So we open sourced it here. This tool made a lot of assumptions about the new X project, so it may not work out of the box for your project, but you can take it as an implementation reference. Now, while adding the IDE integration, we were also working on adding remote cache support. If you enable sandboxing for your build, enabling remote cache should be quite easy and straightforward. So we highly recommend you enable sandboxing, at least for your CI builds. We started with Bazel Remote. It's very easy to set up, so very suitable for first trying the remote cache. Now, this is the C++ compilation flag we needed, the debugger compilation directory. Basically, it will convert the absolute path in the debugger symbols to relative ones that are relative to the repository. In this way, your debugger can find the source files correctly. For iOS, you will need an additional linker flag named also prefix, which basically does a similar thing. And the toolchain generated by Rose Apple already have 2 features defined for this, so you can just enable them. Now, enable remote cache on Windows is much trickier. So first, we failed to find some compilation flag like debugger compilation directory. So we have to turn off remote cache for link actions. So all the link actions are executed locally. We also need to change the debugger information format to the old style, which means Visual Studio will store the debugger information in the object files. But the most interesting issue we encountered is that enable strict action flag is not enabled for us to share the remote cache across the whole team. So when built with VS, Bazel will use the script provided by VS to get all the required environments. As you can see, those paths contain the installation path of the Visual Studio. So if 2 developers install Visual Studio at 2 different locations, you won't be able to share the cache between each other. We are a small team, so the fix is very easy. We just require all the developers to install Visual Studio at the default location. But even after that, we found that with some developers still failed to share the remote cache from other developers. And it turns out the values returned by the script are based on which components of the Visual Studio you installed. So, for example, this developer also installed the .NET SDK, and the path related to .NET SDK is also in the path, which is unused for C++ toolchain, but it will make this developer fail to share cache with other developers. Now requires all the developers to install exactly the same components of Visual Studio are much harder, we think, because sometimes developers may want to experiment with some new language for some special task. So we decided to manually remove all the unneeded values from the toolchain. Then we copy and commit the toolchain into our directory, a repository, and ask Bazel to build a Windows version with it. Now, in this way, we can finally share remote cache among our whole team. Of course, this can be handled better. Rose Android NDK and Rose Apple actually demonstrated 2 different ways for this. So Rose Android NDK use a rebel rule to map the local installed toolchain into external repositories. This is the preferred way, I think, because in this way, your remote workers won't need to install the toolchain again. But it requires all the toolchain related files in a single root directory, which is not the case for Xcode and Visual Studio. On the other hand, Apple use the placeholder environments. So those in the toolchain, those environments variables will be replaced with the real ones provided by the Xcode local in the provider. Now, I think we can do the same thing for MSVC, but this requires modifying the Bazel core, so that's not ideal either. Now, the final piece of the puzzle is the remote execution. We started with build farm. Build farm is very easy to set up. We used it for our iOS and Android build for like 3 months. When we tried it on the Windows platform, we occasionally get some file system related issue. Our team is not familiar with Java, so we failed to identify the root cause. We had to switch to other remote server implementations. But you mini work on Linux and macOS, build file is a great option. Later on, we tried build bar. There will be a talk dedicated to build bar tomorrow, so I won't go into too much detail here. Now, build bar has different kind of file system-based workers. For example, on Linux and Mac OS, it has virtual file system-based workers, which is super efficient. On Windows, it has native file system-based workers. Now, for large projects like LeoX, the native file system worker took too much time to prepare all the input trees, so we can't use it. Luckily, there is a very simple API defined between the build bus scheduler and the worker. There is only one gRPC call. This means we can easily implement our custom worker to work with the whole build bar cluster. That's what we did. So we open sourced the worker here, like the Lavender we open sourced. It made quite a lot of assumption about the LeoX project, so it may not work out of the box for you, but you can take it as an implementation reference. The worker is written with Python script. Now we learned from the build file to cache input trees instead of individual files across actions to construct a large input tree on Windows platform are quite expensive. Now, there is actually a very nice virtual file system API provided by Windows called Project FS. We always want to implement our worker with the Project FS, but we don't get the time, maybe in the future. And a special thanks to Ed Shorten. I don't know if you are here, you helped us a lot during the creation of the worker. Now we have workers running on both macOS and Windows. We need to match the build actions with the correct workers. This is the Bazel Remote API has a plan for properties defined for this. So if we have a worker defined a property named host OS with the value macOS, and in the actions that also contains the host OS value set to macOS can be accepted by this org. But we haven't moved to Bazel platforms yet. We have to wait those Android ADK, those Apple both move to Bazel platforms, which are already here recently. We are happy to see that. So instead, we use remote default execution properties to set the values. Now, the final piece of advice we have is that if you are just start to experiment with execution, remote execution, you can turn off remote strategy for all actions by default. In this way, if there is some actions in your build pipeline that are really hard to implement it for remote execution, it won't stop you from using remote execution to speed up the most expensive actions in your build. After that, you can slowly migrate your other actions to support remote execution. So that's it. After a year of work, we finally get our engine built with Bazel, with remote cache and remote execution support, fast and correct. Of course, we are not done with Bazel yet. In the future, we plan to move the resource cooking pipeline to Bazel. In a game engine, resource cooking pipeline means comparing shared code and compressed textures, which is perfect for Bazel. We want to move to Bazel mode and platform API in the future. And we actually use Python a lot as a script language. We plan to implement aspect rules for MyPy checks. We already did this with our client checks. That's it. Thanks.
Did you set up, include what you use? Did you use the compilation databases that you had mentioned in a slide earlier?
Yeah, we use it in the compilation database. We hope to use aspect rule, but that's more. We have limited source. Okay. Yeah,
that's what I was hoping you did, and then open source it or something, but that's great. Thank you.
Thank you. That's it. We're good. Thanks.
All right. Thanks again, Kai, for the talk. So yeah, I think we've had a lot of migration talks in BazelCon. I think game engine is probably first, this one. Very special in the case of Windows, very important for the game industry. So yeah, thanks again, Kai, for the talk. And now, next up, we have Pejman. Take it away.
Thanks so much. Okay. Good afternoon, everyone. It is great to be at BazelCon. Thank you for choosing to spend your time here with me today, and I hope you find this talk worthwhile and insightful. My name is Pejman, and I'm going to talk about how to build a great JavaScript build toolchain with Bazel. I would like to start that with briefly talking about a very well-known but seemingly elusive subject: developer productivity. This is a, I guess, longtime passion of mine. It's tempting, therefore, for me to ask what developer productivity is or how we could measure it. But we would likely end up with different answers and run the risk of getting too philosophical. It wouldn't be too productive. But we're all developers here, so let me instead ask a question that I'm sure we all give the same answer to. What does it feel like to be productive? We're productive when we're on a roll. Everything just works the way it's supposed to. And we accomplish what we set out to do without too much effort or distraction. And this occasional feeling of being in the flow of building and creating makes software development fun, right? So I like to think that this state of flow has two elements: performance and simplicity. To be productive, things need to work well, and they need to work fast so we can iterate quickly and feel that we're making progress. If you have to wait a long time to get feedback on the code change that we're making is working well or as expected, then it would be too long and boring to keep us in this state of flow. It would be easily distracted to check our phone or go grab coffee while our build is in progress or our tests are running. So short feedback cycles are incredibly important for developer productivity, but they're not enough. For us to remain in this state of flow, things need to be intuitive as well and straightforward. We don't want to get distracted by our tools and processes or how we are using those. So in an ideal state of flow, our sole focus is the job at hand. We can find successful examples of developer-friendly tools with these two characteristics in the JavaScript ecosystem. JavaScript developers are spoiled with options when it comes to intuitive tools with short feedback cycles. And thanks to this abundance of options, the tools in the JavaScript ecosystem have evolved to interoperate and play nicely with each other. Naturally, developers expect that from new tools and frameworks and expect that these tools find the right place in this ecosystem to fit the pattern of other tools and frameworks around them. So unlike this Museum of Arts building in Graz that screams incompatibility. Now, interoperability is important because Bazel is not a set it and forget it solution. It needs to be fitted and tailored for developers' use cases. And if developers cannot see how Bazel fits within their suite of tools and frameworks, it's only a matter of time for them to ask, wouldn't we be better off not using Bazel? So this treating Bazel as an additional layer of complexity is what drives them to ask this question. So, and that is not productive. In the next half hour, we're going to go beyond how to use Bazel to build our web applications and focus instead on how to make Bazel a better fit for the JavaScript ecosystem, to create a fast and seamless, friendly experience for developers that makes them more productive. Now, a little about me. I'm a staff software engineer at Aurora. I'm part of our technology foundations team, building tooling and infrastructure to improve developer experience and productivity. My team and I help accelerate the development of our web applications by maintaining our core libraries and build system toolchain. I have 8 years of experience in building and maintaining mission-critical software systems. I started my career at VMware Carbon Black, then moved to Canon to build medical imaging software for 3D visualization of CT and MRI datasets. Then left Canon to start a developer tools startup focused on continuous regression testing, which shut down after 2 years. And then I joined Aurora to do what I do today. At Aurora, our mission is to deliver the benefits of self-driving technology safely, quickly, and broadly. Every year, more than 40,000 people in the US and 1.5 million people around the world are killed in traffic accidents. We are building technology that provides an incredible opportunity to save lives, to make our roads safer, and give more people access to mobility. We are always looking for great engineers, so if you like to work for a noble cause and at the forefront of technology, I hope that you consider joining us. We use Bazel at a scale at Aurora to build our more than 300,000 targets locally or as part of our CI that runs more than 50,000 jobs per day. While most of our code base is written in C++, we have a diverse and ever-growing suite of almost 40 web applications that are growing fast. So these applications are growing in size and complexity as well. And every month, new applications get spun up and created and added to this list. These applications serve different purposes, from visualization to logistics management. They have varying business needs and business values and are developed and maintained by different teams with different development budgets and practices. Now, while we all make effort to maintain a consistently high software quality across all of our applications, there are always inconsistencies, which makes us end up with a collage of applications with different characteristics. And when it comes to the build process, these differences show up as different configurations and customization points. But we all know from the Hiram's law that anything that can be customized will be customized. And this is my point. Customization fosters complexity. So my team and I work to tame this complexity and to make it easier for the development teams to maintain their applications and develop features faster and easier. We treat other teams as our customers and perform a comprehensive survey every year to identify what their common significant pain points are that we should set out to solve. And the results of a recent survey that we did were loud and clear. Our developers were sharing as their top 2 most frustrating pain points that our builds were too slow and too complex. Naturally, over the past 6 months, my team and I have tried to solve these problems. So here's the story of what we've done and what you could do to make your builds faster and simpler. Now, let's start with the first problem, improving performance. And here's a shocker. You cannot improve what you cannot measure. Improving the performance of any process starts with really understanding it by measuring and profiling every step of that process. Fortunately, Bazel has a very rich set of tools for doing just that. You can use JSON trace profiling to get a detailed analysis of the build process for any given target. You can then feed that profile to Bazel Analyze profile to report the performance of various build phases. And you can then use crumb tracing to visualize your build profile and better understand what Bazel spent time on. Regardless of what you're using Bazel for, it is to your benefit to learn how to use these tools and use them effectively. So let me show you how. To generate the build performance profile, all you need is to pass -- generate JSON trace profile along with -- profile and the location where you want to write the generated file. At Aurora, we choose to pass a few extra options to get more detailed information and more deterministic results. Now, once you generate the build profile, you can use Bazel Analyze profile to produce a simple summary report. This report also includes the list of most time-consuming actions in the critical path of the Bazel build. But that part is not included in this slide. But the real insight comes from visualizing the build profile using crumb tracing. In this interactive flame graph, you can immediately identify the performance bottlenecks in your build logic and narrow your focus down to resolving those bottlenecks. What you see on this slide is the actual build profile of one of our most complex web applications at Aurora that used to take nearly 12 minutes to build from clean slate. You can see the long single-threaded action in pink here. That is just a single direct invocation of Webpack that is responsible for a better half of those 12 minutes. This visualized build profile was crucial in helping us improve the build performance of this application by nearly 20% just by upgrading Webpack to the latest version. Now, in any performance improvement project, there are usually a few low-hanging fruits. And we were fortunate to find quite a few low-hanging fruits when we started this task. And the reason was no one had ever started to have a concerted effort to reduce our build times. But in the process of finding those low-hanging fruits, we learned so much about our build process and the deeper underlying issues that resulted in the slow builds. In particular, we were using the JS library from the open source JS rule set developed by the aspect.dev team to package our shared libraries and application dependencies. These shared packages were then handed off to a simple custom macro that invoked Webpack via a sub-process call to transpile and type check all of our TypeScript source files using TSC and perform other operations like bundling and compression. As all these operations happen outside of Bazel and in the single sub-process call to Webpack, we barely had any opportunity to use the Bazel features and capabilities to optimize that process. So it was all done in one single black box. So we got to work, and in 2 short months, and through a myriad of little experiments, we came up with an improved version of our web application build toolchain that we call the Roadrunner. Roadrunner is intentionally designed as a series of loosely coupled improvements to various components of our existing build toolchain. We kept essential components like Webpack and Jest, but switched to using SWC along with the wonderful open source rule sets from aspect.dev to unlock 2x faster build times, 3x faster development server times, and 3x faster test execution times. 2x faster build times, 3x faster development server times, and 3x faster test execution times. I see you're all getting excited. Here you can see a visual representation of the performance improvements of Roadrunner for various developer workflows and its effects on various benchmarking metrics that we collect continuously. The green bars in every chart show the relative performance of our applications after upgrading to Roadrunner. So now that hopefully I've shown you that Roadrunner is living up to its name, let's see how it works and let's better understand what makes it so fast. The Roadrunner toolchain yields significantly faster build times by uploading the transpiling and type checking of packages to Bazel. Instead of packaging the TypeScript source files using JS library and invoking Webpack to process them using TS loader, we leverage the Bazel TS project of the rules TS repository to essentially transpile all TypeScript source files in Bazel using SWC for transpiling and TSC for type checking. We also changed the transformer used by Webpack from TS loader to SWC loader, which results in faster processing and execution of JavaScript files. Similarly, we use SWC Jest instead of TS Jest and leverage the rules Jest repository to enable faster test execution. Let's review these changes one by one. Starting with the TS project rule, a high-performance alternative to Bazel TypeScript from rules Node.js. In contrast to JS library that simply groups source files and declared dependencies together and doesn't run any action, such as transpiling and type checking, TS project performs multiple actions. It validates the content of our TS config file and checks that the listed dependencies are actual TS info providers. It transpiles TypeScript source files and generates JS files. And it performs type checking of all the source files, generating type declaration files and kicking off the type checking of dependent projects when required. Using TS project improves the build performance because it breaks up the work that we used to do in one long-lived invocation of Webpack into a set of smaller work that we can effectively orchestrate with Bazel. It fits the Bazel paradigm. But we can go one step further and configure TS project to use SWC that is written in Rust as a faster and more Bazel-friendly transpiler than TSC, which is written in Node. SWC is more Bazel-friendly because it is designed to do well in short-lived invocations to transpile a given module without too much overhead. This is unlike TSC, which takes a long time to warm up. And because SWC wants to be a drop-in replacement for transpiling with TSC, it is designed with interoperability in mind. So we can use other tools for other parts of the toolchain. Now, SWC is an excellent alternative to TSC for transpiling, but as of today, our industry really is short of good alternatives to TSC when it comes to type checking, which is inherently slow, compounded by the fact that TS project performs type checking of dependent projects in series. This technical limitation may be resolved in the near future if and when we get a new isolated declarations option in a future version of TypeScript. Now, fortunately, type checking does not need to be part of our critical path, and with TS project, it is not. So we don't need to pay any performance penalty when using TS project in workflows with tight developer loops. In fact, in our experience, developers are used to relying on their IDEs for finding and fixing type errors during the development stage. So type checking with Bazel mostly affects build performance in the CI. On top of using TS project, we found that setting isolated modules and skip lib check in the TS config file to slightly speed up transpiling and type checking respectively. The option isolated modules allows separate processing of the source files, which plays nicely with how Bazel invokes SWC. And skip lib check allows the skipping type checking of declaration files in transitive dependencies, which is really a compromise between performance and correctness. Let us now move on to a later stage of the build. Once our source files are transpiled and type checked, we still need Webpack for bundling and other things. But Roadrunner changes how we invoke Webpack. Instead of directly calling Webpack by custom macros, we opted to use the rules Webpack repository as another open source rule set developed and maintained by the Aspect team. While this rule set is less polished than rules TS, it enforces opinionated Bazel-friendly configurations to create more deterministic output and enable hermetic builds, both of which significantly improve the build performance. This is a clear example of how we take an established and mature toolchain component like Webpack and massage it to fit nicely with Bazel. Similarly, like how we changed TS project transpiler to work with SWC, we can squeeze more performance gain by switching the TypeScript loader that Webpack uses from the TS loader to SWC loader. The performance gain here is not as dramatic as our change to the TS project because we're going to use this loader on the already transpiled JavaScript files. But this change allows us to reuse the same SWC configuration that we used with TS project. Now, rules Webpack and SWC are also helpful in enabling shorter feedback cycles. Now, in this development workflow, we run the development server through iBazel to trigger a visual update of the web application on each change to the source code. But iBazel watches over the sandbox that only includes the transpiled JavaScript files. How do we make our changes to the TypeScript files trigger iBazel? To make this work, we need a little magic trick. We can declare our TypeScript files as assets to the TS project to be copied to the sandbox. This way, we can have iBazel watch over them too. But in this workflow, instead of rebuilding TS project on every code change, we can have the SWC loader in Webpack retranspile the single changed files, which in turn retriggers iBazel to pick up the transpiled file and initiate the visual application update. Here's how this works. We're moving our SWC loader rule into a function that we can call once to match the transpiled JavaScript files, and once in the development server mode to match our TypeScript file. This small trick enables bypassing TS project in this workflow and yields up to 2x faster feedback cycles for developers than they used to get with TS loader. So it's only fair that we also use SWC and when running our test. And it's natural to replace TS jest with SWC jest for running our unit test. And this is where SWC truly shines by delivering up to 5x faster test execution times, while almost being a drop-in replacement for TS jest. Now, I say almost for two reasons. One, because SWC jest does not perform type checking, and it's doing less work by skipping the type checking that TS jest does, which is why it's faster. But that's okay because developers can run, another Bazel target test target to perform type checking as needed. And 2, because SWC just handles mocking and spying of jest functions differently than TS jest. So getting things to work as before is not always trivial. Now that our tests are faster, we can go one step further and adopt rules jest to leverage Bazel features such as sharding and more effective caching. Rules jest also elegantly supports a snapshot testing out of the box, which makes it nice and intuitive to run higher level tests. And intuitive to basically for developers to use as well. This is another clear example of how we massage an existing toolchain component like jest this time to fit the Bazel model so we can unlock the benefits of using Bazel. And speaking of higher level tests, we use Playwright at Aurora to enable our developers to perform end-to-end visual regression testing of our web applications. Now, we have our own complex tooling around Playwright, whose details fall outside the scope of this talk. But I thought I'd share the end user interface of this framework here to show you how Bazel is helping us abstract away all of that complexity so that developers can run their high-level test with a simple Bazel run command. Now, this is a good segue to the second element we need to unlock. Developer productivity, simplicity. If you recall, I shared that our web developers identified the complexity of Bazel as their second most significant pain point. I'd like to share how we have tried to solve this problem with the design and rollout of our Roadrunner toolchain. We wanted Roadrunner to be fast to remove slow builds as a pain point for our developers. But while coming up with a nice and fast proof of concept prototype is always a good start, as we all know, the real work lies in delivering the benefits of that prototype into the hands of our developers at a scale, who are our customers, so to make a meaningful impact on their day-to-day life. We wanted to make our improvements easy to roll out and seamless for developers to adopt. So instead of reinventing the wheel, we chose to focus on improving our existing toolchain components like Jest and Webpack. But this rollout presented the perfect opportunity for us to reduce the complexity of our build toolchain by unifying the configuration options we use for our toolchain components across our 40+ web applications. By replacing application-specific configurations with consistent and reasonable organization-wide conventions, we wanted the Roadrunner to be the toolchain that just works. Now, one may argue that building an extra interface is just an abstraction layer that hides away the complexity of the underlying system, but it doesn't remove or reduce it. But building a minimal interface is introducing an abstraction layer with a commitment to revisit all of your customization points and ruthlessly eliminating them. And if you recall, customization points lead to inconsistencies, which foster complexity. So a minimal interface reduces the complexity and makes it difficult for end users to go wrong. And it facilitates further improvements to the overall system by reducing its maintenance and migration cost. And this macro here is the minimal interface that we introduced to our 40+ web applications one by one as we upgraded them to our improved build toolchain. A single macro that is easy to read and make it really difficult for developers to use it incorrectly. Now, this single macro takes the necessary information to generate the variety of build targets that each web application needs. These targets include a TS project for transpiling and type checking, Webpack targets for bundling and running development server, a test target to run unit tests, and a separate target to run our end-to-end test, along with many other targets that our applications use for packaging and deployment. But simplicity is not limited to designing high abstraction interfaces. It is also about removing friction and distraction in the tools that we use. So an example of this in web development is how we use package.json to declare application dependencies. This is, of course, very different than how we list dependencies with Bazel. But instead of forcing a change of habits, a good design is one that meets developers where they are. So is there a way to let them continue to rely on package.json and handle the mapping of those dependencies for Bazel behind the scene? Now, I'd like to say yes, and here's how. We can maintain a list of all of our web applications that include a package.json file and use that list as input to a custom rule that parses the package.json file and generates this big dictionary we call an npm dependencies that maps each project to its npm dependencies. And we can query this dictionary inside our single abstraction macro to make everything happen in the background and create a seamless experience for our end users. And as the cherry on top, and to complete the design of our toolchain, we can go one step further and package our toolchain components into separate packages. This way, our end users don't need to list common toolchain dependencies like Jest and Webpack and their plugins and every other node npm dependencies that they include in their package.json file. They get them as a reward of using our minimal interface macro. This modular design also makes it easy to upgrade our toolchain components and our dependencies or replace them with other tools. So I want to close with where we started and say that we can unlock developer productivity with Bazel by creating a build process that is fast and simple. Doing so for web development requires a deep understanding of the web development ecosystem, as well as the true character of Bazel itself. So we can design a build toolchain that fits nicely with Bazel by leveraging its features and benefits and conforming to its expectations. But this is a two-way street. To deliver a great developer experience, Bazel and any build system, for that matter, need to encapsulate their own complexity and get out of the developer's way by providing a simple and intuitive interface. Now, building this intuitive interface needs extra work and requires empathy and a willingness to compromise to make Bazel a good citizen in the ecosystem of tools that developers use every day. And with that, I'd like to thank you all once again for your time, and I invite you to share your thoughts and ask your questions. Thank you. Yes, here in the front.
That dictionary that you mentioned in one of the latter, yeah, that one. Is that is that a repo rule? Like, how are you?
It is a repository rule, correct?
It is.
Yes.
Oh, okay, okay.
Yes, correct. It's a repository. It's a custom rule implemented in Python that parses our package.json and creates this Bazel module that we can then load.
Gotcha. Okay, cool. Thank you.
Yeah, sure. Any other questions? Oh, yes, here. Matt.
How do you find the trade-off between what you said about simplicity with like that my web app?
That's right. Yeah, the macro, the high-level macro here.
Yeah, how do you find the
I can repeat the question.
how do you find like the simplicity between like the trade-off between the simplicity of like my web app and like the discoverability of the targets of that?
Yes. So the question is, how do you basically find a balance between the simplicity and abstraction that you are introducing versus the need for developers to know what targets are available to them for their application? I guess this is a very valid point. That need exists, and the trade-off that we are making is to say, hey, developers of this application, your workflow is to build your app, test your app, run your dev server, run your playwright server. Remember these 5 targets in your application. Essentially, if those 5 targets are exactly the same name in across our 40+ applications, then it's very easy for us to maintain them. And we don't have to basically go to teams and say, hey, please rename your target or whatever. Essentially, I think that trade-off is always basically the way to break that trade-off is always to think about the maintenance cost. Sometimes that maintenance cost is on the developer side, so you don't want to cost too much abstraction for them to basically have trouble maintaining their app. But in this particular case, and with Bazel in general, I think a lot of the complexity can be abstracted away from the developer's workflows. Another question? Is there any? All right. Well, oh, yep. One question there.
I think you said that for interactive type checking, you still rely on the IDE working for those purposes. Is that something that worked for you straightforward? Because in my experience, if you like heavily rely on Bazel and it's not buildable without Bazel anymore, you probably won't get like don't have like an intact node modules directory that actually works with IDEs that where type checking works. Did you?
Yes, that's a very good point. We try to solve that problem by doing the extra work on our team. So essentially, making sure that developers get that benefit when they're using their IDEs. That their path aliases always include some kind of like alias to the sandbox if need be for them to find their generated files like protobufs and others. So in general, I think yeah, go ahead.
So does that mean that essentially your projects are also still buildable without directly invoking Bazel?
I would say not necessarily, no. We are so heavily invested in Bazel that I don't think we need, at this point, we are not supporting any workflow outside of that.
Okay, thank you.
Yeah, sure. All right, unless there is another question, thank you again, and have a great BazelCon.
Thank you, Peshman. So we have another 15-minute break coming up. After that, we have a flurry of lightning talks ready for you, about 8, I think. Yeah, so feel free to go take a break. After this, there's also more office hours if you need them. Yeah. Okay.
Charge that one?
Yeah, probably. Been using this.
Hi, live stream people. All right, welcome back. We have a block of lightning talks starting now, and Tyler is going to kick us off with a talk about how Uber manages Go dependencies with BZL mod.
Hello. My name is Tyler. I work on Uber's Go developer experience team based out of New York. And today I'm going to talk about BZL mod and more specifically Go and how Uber migrated to Go with BZL mod. So first, I want to dive a little more into the Go BZL mod experience, how it was created and why it was created in such a way. So let's first take a look at how Go modules work. The Go modules ecosystem works using a go.mod file, which declares all of the dependencies needed to build all of the packages within that module. There's also a go.sum file, which has all of the integrity values to make sure that the downloads are correct. So with Gazelle, what we do in the workspace dependency system is we create these things called Go repository rules. And Go repository rules take the sum from the go.sum file, they take the version from the go.mod file, and they're generated with a command called Gazelle update repos. Now let's talk a little bit about the pains of Go repository rules. Go repository rules get really messy because they create really large files. Go repository rules are required to declare every single transitive repository needed to download, whereas the go.mod file doesn't need to do that. So now we have files that are like 20,000 lines long declaring these Go repository rules. They duplicate the information from the go.mod file, and then you have to keep them sync manually using Gazelle update repos. So let's now look at how Go modules works. So Go modules uses minimum version selection. This is done without a lock file because minimum version selection is deterministic, so there's no need to check this in. But there is the Go sum for integrity purposes. And then the root module file, the root Go mod file, is allowed to declare overrides. So it can replace certain versions and it can exclude certain versions. This looks a little bit similar, right? And yes, it's very similar to the way BZL mod is designed. BZL mod declares the direct dependencies. It then does version resolution using minimum version selection. It has no lock file, although now you can optionally include a lock file. And you can provide overrides, but these overrides are only usable in the root module. So we take a look at this BZL mod API. There's a direct dependency you declare with Bazel dep, and then there's the set of overrides. So we designed Go with BZL mod to follow a very similar API. We declare go.deps.module, which is a direct dependency. And then we provide 3 different overrides. They each do different things. One of them declares, Gazelle declares different directives you can create build files with. And then module applies patches. Archive can be used to download from a different resource. So this is great and all, but we still have to create a module for every direct dependency we use, which is inefficient. So we can use the go.mod file as a source of truth. And so we create this tag from file, which allows us to read a go mod file and generate the repos from this file. I heard PagerDuty, that's scary. And this allows us to deduplicate all that information from the go.mod file. We don't have to check in the versions in Go repository rules. We now have a much more simple way. We don't need to have all our sums in the module.bazel file. These are now loaded from the go.sum file. So we can rely on Go mod tidy also for version resolution, and we don't have to recopy over things using Gazelle update repos. So it's a big improvement here. One problem is we still have to use repo for every single direct dependency we use. This is just a drawback of how Go repositories work. We don't know what labels are in there when we first load it, so we will have to use this for a little bit. But overall, this looks a lot cleaner. We declare our go.mod file, whatever patches we want, and then we in the future can run a Bazel mod tidy, which will clean up our use repo commands. This should be here in 7 or 7.1. Cool, now let's talk about migration. There's a ghost because it's October and migrations are scary. And at Uber scale, migrations include over 1,000 direct Go dependencies. So there's a certain level of automation that we require if we want to migrate to BZL mod. Additionally, we need some sort of structure and organization because we have a really large repo. So teams need to be able to read and understand how to make modifications to dependencies without involving us every time. And similarly, not one team can't own every single dependency. So different teams, like the software networking team, need to be able to own their dependencies that they specifically depend on. So we need to support dependency ownership. Cool. So first design decision is, what do you do for an internal registry? First option is you depend only on the BCR. And this means that you rely on every module that's in the BCR only, and if you have any internal modules, let's say you have an internal rule set, you need to use internal overrides to do this. You can use the URL rewriter for mirrors, so you don't have to worry about integrity or availability of github.com, but we still have to depend on the BCR. So the next option is a partially internal registry. This is where you have your internal rule sets or things that you depend on internally that are versioned in your internal registry, but then you still depend on the BCR for all of the open source stuff like Rules Go and Rules Python. And this is a good option, but you still depend on the availability of the BCR host. So next is a completely internal version. This is where all of your modules that you depend on, you download and copy into a registry somewhere. And this just adds a lot of tooling, but it means you're isolated from BCR outages, which is good overall to be isolated. So initially, this was our plan. We start short term here, and we move to long term with a completely internal registry. But a good solution presented itself is that we can move from a partially internal to a completely internal registry almost by using a proxy caching layer. So we can use Artifactory's BCS repositories or something similar where we send a request to Artifactory. If it doesn't have it, it sends a request to BCR, caches it with some TTL. And now we don't depend on BCR and we eliminate the tooling. So that's our solution. So another design decision we looked at is, what repository rules do we want to use in module.bazel and which ones are a little inconvenient to use? So here's an example of an extension that we would use to load some HTTP files, for example, maybe some test data or some images. It's a little toilsome. You have to add a use repo call, and you have to add the artifact to an HTTP archive. So we decided to not use BZL mod for these dependencies. The rationale here is it's much simpler user experience. We don't want users to have to modify the core module.bazel file when they're adding a new repo. And we want to be able to keep this experience the same as it was, where you can put it in your team's directory and load the file. This is a little bit alleviated with use repo rule, but similarly, it's in the root module.bazel file. So we still have to be maintaining the organization there. Next, I want to talk about dependency ownership. This is an internal design we have where we place our Go repository rules in different directories based on their ownership. And this allows a team to own a certain repository rule. And then we have a metadata for each directory that applies reviewer permissions for that directory. I'm sure companies have other similar things. And so when someone modifies that repository rule, it requires a certain team's review. But this is not possible with the module.bazel because everything's in one file. So we need to find a new solution here. Currently, we're looking into dynamically assigning reviewers based on reading the changes and analyzing them to the module.bazel file. But that's a lot of tooling, and we'd rather just use directory structure. So what's missing? Overall, right now with Go, we've noticed that overrides are getting messy. If we have to apply 100 to 200 different overrides, that's not scalable. So if we can group a set of overrides, apply one directive to all of them, or even apply blanketed overrides to every dependency, that would be much more user-friendly. Additionally, we want to better structure our overrides. And this is similar to talking about module.bazel management, but even if we could load our overrides from a file, this might make things more organized and separate things out better. Additionally, module.bazel management is going to become a pain point. Ours is about 2,000 lines long right now, and it's only going to get longer. So if we have a way to structure it, organize it, so that any user knows how to make changes to it, and we don't have to apply a central review to these changes, that could scale much better. So these are things to think about. If you have any ideas for things that are missing, please file an issue either on RulesGo, Gazelle, or I guess Bazel. This is a very growing and in development area. So there's a lot of changes being made, and there's a lot of attention happening right now. So definitely please send your issues in. Yep, I wanted to give a special thanks to Jean Peng and Fabian. They've done a lot of incredible work on these rule sets, so that's great. I didn't think I'd have time for questions, but it looks like I'm a little under time, so I don't have, okay, never mind. Okay, Slack me, say hi. I guess that clock's, but thank you. I appreciate it.
Speaking of Fabian, we have Fabian with the talk about with config.
Does it work? Okay, it does. Yeah, let's get over to something completely different. This is with config.bazel. If you want to know how hard it is to rename things, look at the agenda for today. It's still called with config, so that was troublesome. This is about making transitions more accessible and also making their use more responsible by lowering the footprint. I'll start out with some concrete example that will guide us through this talk. So let's, okay, this doesn't work, whatever. So this is a general, like simplistic synthetic build setup where you have a CC test that has some code generation via again rule and has some data dependency and some other binary, some DApps, and then there's also a Go binary that also depends on some, in the end, common base library that both of these targets transitively depend on. And now let's say you want to instrument your test and all its dependencies with a certain compiler option. Because I have a background in fuzzing, this will be address sanitizer, which is a tool that sort of you can use to instrument your test and code to catch memory issues at runtime. How do you do that? Well, there are different ways. You can say, okay, I'll just set a copt of something. The concrete value doesn't matter here. When you do that and you still want your developers to be able to just build everything, which is the simplest thing to do, this copt will leak to, for example, the CC library that's only used by the Go binary, which is not something we want because maybe the Go binary can't even deal with this kind of instrumentation. So that's not so good. What can you do? You can tell your developers that, well, if you want to use this flag, please only build these particular targets, and then, I don't know, you maintain a Confluence page for that. But that's horrible if nobody wants to remember these flags and sets of targets. So you can get fancy. You can use transitions, which is a Bazel feature that essentially allows you to change settings for a target and all its dependencies, but to have that be isolated from all other usages of this dependency. Of course, that works, but that leads to certain things being built twice. So for example, that CC library, that's a common dependency, that will be built twice, which is necessary and okay. But then, for example, your general will run twice, potentially. Also, this still leaks to the data dependency. Do you want that to be instrumented? Probably not. So this is very leaky. You can do it, it works, it's correct, but it may increase your build times. So the idea is that we can have something more targeted. We have something that sort of removes the boilerplate, that allows you to easily wrap an existing rule with transitions, and gives you full control over the spread of these transitions. And that's where this Starlog library with config.bazel comes in. And the idea is that you get a flagless build where you just can do Bazel build everything, and the right flags are used in the right places. So yeah, it's a Starlog library. You can use your favorite rule as a base, and then tweak some Bazel settings for it. For example, have a Java library that always builds for Java 21 and resolves the correct toolchains for that. Or in file group that always builds everything with compilation mode opt if you want faster integration tests. And you can also configure automatically or manually, if you need more control, the way that this transition spreads to the individual attributes. So you can handle depths differently from, say, sources. And this supports Bazel 6.4 and later. So let's look at a concrete example. So this is essentially what we just looked at, just a bit more concretely. We will make a version of CC test that builds everything with address sanitizer. So what we do is we load essentially the single symbol provided by this library with config, and that gives us a builder. It's a bit uncommon for Python, but I think that it could work pretty well here. So we apply the with config function to the existing CC test rule. Because this is in a Bazel file, we need to use native.cctest to see that symbol. And then we can call the extend or set method. So there's a set method for modifying a setting, and the extend method for modifying a list-based setting, so for sort of appending compiler options instead of replacing all the ones that are there. And here, for example, we just append fsanitize address to the compiler options and the linker options. Then we call builder.build, and it spits out a new rule that we can use. This isn't exactly everything. There's one, well, Bazel restriction. There is an internal rule that this uses, and for some reason, I mean, for a good reason, but for a reason that's a bit annoying here, you need to assign this to some top-level variable in your .bazel file. But the name doesn't matter, and you don't have to use it. So if you just, this is sort of the boilerplate that you need to make this work. And it also supports selects. So if your values are a bit more complicated, if you say, okay, here, for example, on Windows, the linker complains about this flag and it doesn't need it. So you can actually hide that complexity in this new CC async test rule by using a select. That just works with all the existing Bazel configurability features. And now for the fun part, you can also say, I don't want this change of settings for certain attributes. So for example, you probably don't want async to leak to your source generation. And that's why you can also call this reset on address function, provide a list of attributes that you don't want to apply this change of settings to. And then, well, it will magically reset everything. And you also get, instead of this useless underscore rule that we had on the previous slide, you get a rule with which you can manually reset certain dependencies. For example, in your Java 21 library, maybe some target builds only with Java 7. I hope that's not the case for you, but reality says that this can happen. In that case, you can just wrap that target in this rule, and it will build with Java 7 just fine. And there's one target, this CC async test original settings. That's sort of a central place where your original settings are stored. That's just a target that you need to declare in some build file once and then forget about it. So in the end, you can use CC async test, and then you sort of get exactly the shape of the build graph that you want, and everything works with Bazel build // ... Yeah, thank you. This is how you can use this with BazelMod and the repo you can check out.
All right, next we have Alex talking about validation actions.
Hello. Let's see, does this work? Yeah, so hi, I'm Alex Chemesky. I work mostly on the Android rules, but sometimes I dabble in other parts of Bazel. So what I'm going to talk about today are validation actions. So firstly, what is a validation action? Sometimes you want to do things in a build that really don't produce any outputs necessarily. So you could think of things like linting or static analysis on files. And you can't really do this in Starlark because you don't have access to these files at analysis time. So you have to run these in the execution phase, which means actions. Now, ideally, you would not be increasing the build times with these actions because, again, they don't produce any outputs. So they wouldn't be used further on into the build. A good example of this might be Android lint. So this is a tool that we run internally on a lot of our code, mostly our Android app code, but also just our regular Java code. And this does a lot more than just like checking style and things like that. It actually checks the code for bugs, common error patterns that you might use in code. And importantly, Android lint can actually take longer to run than compiling those same sources. It runs, hundreds of checks, and as you add more checks, it could take more and more time. It can produce a file for reading what the errors are, but this is not something that's used in the rest of the build. So this might, you might now wonder, if an action doesn't produce any files, how do you actually get Bazel to run that action? Let's see. So historically, we have two kinds of workarounds that you could try to do to get a validation style action to run. What you might do is trick Bazel. You can have a dummy validate. You can have a validation action output at some dummy output. In fact, you might even have to wrap your action in like a shell script to produce an empty file, and then add that dummy output to the input of some other action in your build graph. And you can kind of imagine how bad that might be for the critical path, because you're artificially adding an action before some other action. Now, another kind of workaround is a little more clever. You might add a third action, and your main action's output goes into that artificial third action, and the validation action's output goes into that artificial third action. And all this action does is copy the real output to some other file, just to trick Bazel into running your validation action, something like Android lint or static analysis. And you can kind of see here how Bazel thinks that it needs to run the validation action before the copy action, but you're just tricking Bazel into running it. And so there are a lot of downsides to these kind of workarounds. It's inefficient, of course, because you're copying things you don't need to copy, really. More actions or more memory. It's confusing. You're reading your code, and why do you have these additional actions? You have more artifacts to think about, more code to think about, and it's brittle. As your code evolves, you have to remember these additional actions. So with all these drawbacks, we added a little bit better support for this class of action. Basically, a validation action is just like any other action, but you take its output, which again might be a dummy output that you add in. You add this output to a special validations output group. And real briefly, what an output group is it's sort of the set of all artifacts that you're requesting at the top level for Bazel to build. And there's the default output group, which you are asking for when you do Bazel build. So we added this special validations output group, which is always requested. So you're always building all of the artifacts in this output group. And importantly, all of the artifacts are collected automatically throughout your build that go into the validations output group. And what you can also do is run these validation actions even after your build is completed, because again, these aren't needed for your build. So when you're doing something like Bazel test, you could even run these validation actions concurrently with the test after all the regular actions have run. So here you can kind of see how this looks. So you'll have lots of regular main actions, validation actions, and their dummy outputs go in the validation output group, and the real outputs go into your regular output groups. And it's kind of pulling all the validation actions to the top of the action graph so they can be run at any time. So our experience with Android Lint internally, again, this is an action that typically takes longer to run than Java C or Kotlin C. And we don't really ever see this in the critical paths internally. The rest of the build pretty much acts as it does usually. So there are some limitations with this. One thing we observed internally is because Bazel wants to err on the side of caution with running validation actions, as you saw in the previous slide where you had the two output groups, all the validation actions are always going to be run if you touch any target that has a validation action in it, even if you don't actually use anything from that target. So we have a certain class of rules which will just look at the analysis time information for a build. It's just collecting like providers and looking at their information. It doesn't actually use any artifacts from that build. But the validation actions still run. Bazel, again, wants to err on the side of caution and validate everything in your build. And so you're still running actions even if you're just using information from providers and none of the actual artifacts. And this also means that any inputs to validation actions are also built, like anything on the, if the validation action needs class path information, that means you're potentially building all the jars that go into that validation action. So over triggering is one problem that we've seen. And another limitation is that you can only be as parallel as your resources allow. So, if you have 1,000 targets that you want to build and each of those has a validation action, well, that means you need to run on 1,000 additional actions. You may not have 1,000 machines all running in parallel to run all of those actions, all at once. So potential improvements we could have here. The validation output group is a little bit of a clunky API. You put a dummy artifact in this magic output group, and then suddenly it's a validation action. So improving the API to mark actions as actual validation actions would be nice. And providing better controls over the over-triggering problem I just mentioned. Perhaps some way, for example, to control when validation actions run in a more granular level, or enabling Bazel to run validation actions only when something within that target is actually used. This is documented. So if you go to the Bazel website and go to extending and then rules, there's a section that summarizes all of this with a little example. And that's all I have about validation actions. I may have time for a question or two. I'm not sure. Yeah, one question. Anyone have one question? Go ahead. I think you're the only one.
I'll just talk loudly.
Yeah. Or I'll repeat the question.
That dummy output group.
Yeah.
Is it possible to generate, say, like patch files that you could then take like file?
Oh yeah.
Like apply after the build?
Yeah, actually, yeah, you could absolutely do that. What's that? Oh, sorry. Yes, you can do that thing that he said. So the question was, let's say you had like Clang format, and Clang format would output a patch file or a diff, which could you then collect all of those files and then use that to just change, just update all of your code. And yes, you could do that. Because output groups, like that's kind of exactly what they're designed for. You're saying, Bazel, give me all of these files, and then you just have those files. I think there might be a way to actually query what the files actually are. You may have to experiment, see if that's actually true. All right, I have 1 minute apparently for another question, if anyone has another question. Yes.
Actually, I have one question. So this can also be achieved by aspect tool, right? So
yes.
What's the benefit or between using a validation action or an aspect tool?
Excellent question. In fact, that experimental flag that I showed, which enables you to run validation actions in parallel with tests, actually is implemented as an aspect, I think. Yeah, so actually it's totally the same how you could implement that. One reason we wanted to implement this slightly new feature is so that you didn't have to have the overhead of an aspect, because aspects increase memory a little bit. You're creating a new node in SkyGraph and so forth. Whereas with a validation action output group. That's an existing mechanism. Output groups have been around in Bazel for a very, very long time. So we wanted to leverage existing mechanisms and not have to have the overhead of remembering, having to add an aspect, having to have the additional memory cost, a little bit of additional analysis time to actually run the aspect. And now I'm over time. Okay, thank you. Thank you, everyone.
Before our next speaker, I want to invite anyone who's sitting on the floor, if you'd like, there are plenty of seats here and in the front. I'll give you a second to move up. There's another one over there. So be comfortable. And next we have Ben talking about visualizing the build graph with Skyscope.
You're going in the wrong direction.
Upside down. Cool. Hi, my name's Ben, and I work as a software engineer at Tweak. And today I want to tell you about Skyscope, which is a new tool that I've been working on. And Skyscope lets you visualize and explore Bazel skyframe graphs in your web browser. As to why you'd want to do this, maybe if you're debugging a tricky dependency issue, or you find yourself working in a new repository and you want to quickly gain an understanding of how it's structured, and which targets depend on each other, then it's quite useful to be able to see a visual representation of the build graph. So this is what it looks like. I'm going to show a video demo in a few minutes, but here's a preview first. So one way to characterize Skyscope is to say that it's an interactive front end to GraphViz. So I'm sure many of you are familiar with GraphViz, but if you're not, the basic idea is pretty simple. Instead of manually drawing out your graph in some diagram software, you describe its structure in a domain-specific language like this. So this example describes a graph with 5 nodes, A to E, and various edges. And then you run this through GraphViz, and it produces an image like the one on the right. So GraphViz has been around for a long time now, 20 years at least, and many different tools and libraries support it, including Bazel. So this post tells you how you can visualize your build graphs with Bazel. But the basic idea is that when you do a Bazel query, you can get to output in GraphViz format. And then when you run that through GraphViz, you'll get an image like this. So this one's taken from the Envoy repository. And that's pretty useful. Here's an example of a larger graph. You can't really read it at this scale, but if you zoomed in, it is legible. There's some crossover with the edges, but it's not too bad. The trouble is, as your graphs start getting larger and larger and more complex, the edges quickly become a tangled mess until it's basically impossible to make any sense of it all. So that's GraphViz. It's a great tool, but it does struggle with large graphs. And that's not really the fault of GraphViz. It's just that laying out graphs in 2D is inherently difficult. So pivoting now to Skyframe. I don't think I have to say much about this. We had a great talk this morning on Skyframe. So I guess I'll just say that Bazel lets you get access to the current state of the Skyframe graph with a Bazel dump command like this. And just to show you what that looks like, this is a very small snippet of what could potentially be hundreds of megabytes or even gigabytes of data of text. This isn't meant to make any sense to you really, but I'll just say it represents 5 nodes. 5 nodes with 4 edges in the graph. There's about 40 different types of nodes in a Skyframe graph, and they all correspond to the kind of things the Bazel needs to know about to do incremental builds. So yeah, it's great that we get access to this, but it's pretty hard to make any sense of. It'd be great if we could parse it and feed it through GraphViz and get a visual representation. But as I said, Skyframe graphs are huge, and there's no way that GraphViz is going to handle that much data. So the solution I came up with for Skyscope, it's fairly obvious, I guess. Instead of trying to render the entire thing, just render a tiny subset, say maybe 10 to 20 nodes at a time. And at that scale, GraphViz will work much better. It'll be fast, and the graphs it produces will be understandable. The key thing is, though, that the rendered graph is interactive, so you can click on various parts of it to show and hide nodes. And yeah, that's basically the idea behind it. Just before we come on to the video, a note about terminology. So Skyscope has this concept of expanded and collapsed nodes. When a node is expanded, you get to see all of its edges. The trouble is, some nodes might have hundreds or thousands of edges. And And so that's going to, even if you just have that one node visible, it's going to make a mess of the graph. So you can collapse nodes, and then only edges to other visible nodes are actually shown. So yeah, here's the video demo. The first thing you need to do is import the current state of the SkyFrame graph into Skyscope. The SkyFrame graph can get pretty huge, so it's usually a good idea to start with a Bazel shutdown. That clears the graph, and then you run the build command to populate the graph again with just the nodes that you're interested in. So here I'm building the Bazel binary itself. It was built before, so this is just going to, once it finishes loading and analyzing and checking the cached actions, it'll be done in another few seconds. And then when that finishes, you run a Skyscope import command, and that will dump the SkyFrame data, parse it, and bring it into Skyscope. So just another few seconds, I think. Yeah, there we go. So Skyscope import on its own is enough, but you can optionally pass query and a-query parameters to it. And if you do this, then Skyscope is able to import extra context for targets and actions, and that gives you a richer experience in Skyscope. So the extra context is stuff like which build file the target was defined in, or for action execution nodes, you get to see a nice, pretty mnemonic label instead of just action execution. It takes about a minute to import this on my laptop, but I've actually cut the video here. So there's 400,000 edges. You'll see it jump up. There we go. So this is finished now, and you get a link to open in your browser. When you first open it, no nodes are visible, so it's empty, but you can search for nodes to display in the top here. You can search by file name or label, basically anything that forms part of the Sky key, the key for the node. So here I've searched for the Bazel server Java binary target and made it visible. When it's initially visible, so if you hover over it, you can see which build file it's defined in. It's initially collapsed, so you don't see any edges, but by clicking on it, you can toggle it to be expanded. So now you see all the things that depend on it and that it depends on. If you hover over these, you can see their action executions. By clicking on one of these hidden nodes, it makes that node visible in the collapsed state. And so I'm going to click on this. Yeah, if you hover over it, you'll see the a-query output. By clicking on that, it becomes expanded. And then if you click on an expanded node, that collapses it again. So another feature to show you, I'm searching for a source file that I know the Bazel server target depends upon, cpp compile action.java. If I make the configure target for that visible, Skyscope knows there's a dependency there, so it will show you a dotted path between. And if you click on open, so yeah, that says there's two. If you click on open now, it will make all the nodes on the dependency path visible. So this is kind of like a sum path query, I think is what it's called. So yeah, if you hover over this, you can now see how the dependency works. We've got the Bazel server binary depends on the main library, which depends on the rules library, which depends on the CPP library, which depends on the file. You can hold shift and make a selection of nodes to crop the selection to that. So you can sort of zoom in on an area again. Double clicking on a node makes all of its neighbors visible. So we now see that 4 other targets depend on this source file, 2 file groups and 2 Java libraries. I think they're actually the same label, but different configurations or something. Just to demonstrate the crop to selection feature again, holding shift and clicking these 3 nodes, that will focus in on those. Some nodes have hundreds of edges, like this one. So you might click that, and even though there's not many nodes visible, it still kind of blows the graph up a bit. But Skyscope has fully integrated browser history, so you should feel free to explore, because if you get lost or make a mess, you can always go back and undo stuff. Forwards works as well, so I think in a minute I stop going backwards and start going forwards. Nearly at time now, but I think there's one more feature to show. Yeah, so we're back to here. So making this hidden node visible, this is Starlight built-ins. Every target in the graph depends on this particular node. So yeah, I click it to try and expand it, and we're going to be here a while if we actually wait for this, because I've never waited to see how long it takes to render. But if you get in this state, you can click the spinning hourglass in the lower right-hand corner, and that interrupts rendering and takes you back to the state you were in before. So yeah, I think that's pretty much everything I had to show you. Yeah, so thanks for listening, and please see you.
Okay, next we have Benjamin with a talk about remote output service, how not to have your bytes and eat them too.
So hello everyone, my name is Benjamin. I'm a co-founder and I work as jack of all trades at Marathon. So at Marathon, we help companies to speed up their builds, which usually involves diving into the nitty-gritty things and getting things to work well. But today, I'm just going to give a talk about the remote output service. The remote output service is a community-driven project, and it's there to help streamline output management of Bazel when working with very large builds. So to get there, we're going to have a little bit of a primer here and just the general shape of remote execution. The screens here are a bit staggered, but I hope you guys can see what it says. We have two parts. We have our dev machine and our remote cluster. On our dev machine, that's where Bazel's running. It fetches our source files, uploads them to the remote cache. Then the remote sends execution instructions to the remote execution system. And then the remote execution system pings back and forth with the remote cache with all of the partial results. Bazel then downloads them and puts them into Bazel out. The general phenomena here is just you have small inputs, your source files, which hopefully doesn't change very much over the time. You've already uploaded most of them. You just need to upload the changes to them. But you have large outputs. And this output can become terabytes of data. And it consists of a lot of different things. There's the intermediate results, debug symbols that were built on the way, any container image, flash image, basically anything that a developer at some point thought could be useful to build. So what we want to do here is we want to kind of simplify this. So if we pay attention to the graph here, we can kind of see that we don't really need the outputs. Like when we have the remote execution system, we can just let the remote execution system ping back and forth with the remote cache, and then we can skip all of the outputs. That's the general thought behind remote build without the bytes. It's a fairly long-standing project in Bazel. I think it's in 0.25 where it was introduced. And it is finally getting flipped on by default now. So now we're really certain that it works right now. And this basically allows Bazel to skip downloading and leave them on the remote cache server. That's really great. Then we don't have to download all of these bytes anymore and everything's great. The thing is, though, that usually you perform builds for reasons, not just because you want to see some machines work a lot. And that reason is usually because you want to see those bytes that are produced by the system. So to get them out, there is a little bit of tooling that you can use right out of the box. There's the remote download top level, which says, okay, but we just want to get the final result of each build. And there's the remote download regex, where you say, well, we want to get the results which match this regular expression or this collection of regular expression. Well, the problem here is that, well, once you start doing that, you start adding regexes to it, go to the top level. Turns out the top level results are those big container images and ISOs that you need. And the regexes that you might need will depend on, are you doing a debug at the moment? Oh, in that case, you need these symbols, which have all of the debug symbols. Or are you looking through the source code with a local tool that looks at the generated source code? Oh, then you need this other regex. It's a lot of hassle and things to think about. But, I mean, what are you going to do? Like, if you want your bytes, you have to download them. You can't just not have them and eat them too. Wasn't that the topic of the discussion? It was. So for this specific reason, we're introducing the remote output service. Here we move the remote downloads to be performed by an external service outside of Bazel, still running on your local machine, but we offload the task of actually downloading stuff from the remote cluster to the remote output service, and just sends like metadata about what, oh, we had the remote execution system build these things for us, please go fetch them. and put them in Bazel out. This wouldn't really help us with anything. We'd just be back into the situations where we produce a lot of stuff in the Bazel out folder. But what we can do is that we can use a bit smarter implementation of the remote output service in order to help us with this situation. One such example is BB Client D. And what BB Client D does is that instead of actually downloading the things into Bazel out, it just mounts a virtual file system there where it tells the user that, yeah, sure, I downloaded those files. Look, they're here. The virtual file system describes their exact topology, they have the correct size, and with a bit of effort, you can even check the hash of them without actually having to go fetch anything from the cache layer. And then a developer doesn't really have to think about which files are actually downloaded. From a user perspective, this is exactly the same as if you were doing a remote download all before, but the optimization is being done in the remote output service implementation here. That's the biggest advantage here, is that you can move the thought about which things do I need to download when performing these builds. You don't have to rerun Bazel because you forgot to download certain things. You just have them there if you need them. And since we've offloaded this into a separate process, this process can keep track of things in a much better way. It can deduplicate identical files, whether it was because you downloaded them yesterday or in a completely different workspace. You can control just how much of these remote files do I want to keep on my system. You can give it a fixed size to keep to, and it'll automatically manage to throw away old unused things. And that's fine, because if you need it, then it will go download it again. And another neat feature is that you can snapshot your exact build result. So as you have a description of your output directory, you get the ability to snapshot that small description of your output directory, offload that into a different system so that you can explore your CI system and sometime in the future see what it produced, or archive it if it's a very important build. And you don't have to keep track of multiple versions of output files which were produced by different CI systems. You just keep track of this small object which describes all of the outputs that were produced. So what's the current state? Well, the remote output service is an accepted proposal for Bazel. There is an implementation available, and it's in the process of being upstreamed. If you want to have a little bit of a preview, we pre-built a couple of versions of it that you can just add to your .bazel version, and you'll get a version of Bazel which is that exact version but with the remote output service. The server software, BB Client D, is a free open source project. It's available at buildbarn/bbclientd. It's created by the BuildBarn developers, but it's compatible with any remote execution system. Patches are welcome. So thank you all for your time. We've had pretty great results using the remote output service and BB and hope you guys can have it at too. There's going to be a discussion at the Birds of a Feather where we can talk a little bit about the details behind it, or you can just catch me in the hallway.
Next, we have Matsia with Bazel building an iOS app with a lot of frameworks.
Hello, everyone. My name is Maciej Piotrowski, and I work at Allegro. I am a mobile software developer, and at Allegro, I work for a mobile core team, which is a platform team, and we take care of the entire build process of an application. We take care of technical depth, and we also build in-house tools for developers. To begin with, let me tell you what Allegro actually is. We are an e-commerce application. Our biggest user base is based in Poland, but we also entered Czech market. The user base can be counted in millions for mobile applications. And for such a huge user base, you might expect a complicated code base, and it actually is like that. We use monorepository, and there are some statistics over the 5 years period of time. Our source lines of code grew for over 1 million. We gained new modules from 30 to 330. And we've been using 2 languages for development of an application, which are Objective-C and Swift. In the beginning, we had more Objective-C. Now we have more Swift than Objective-C. But in 2019, we discovered that our builds take a long time. And these metrics come from Intel-based machines. These are 6-core CPUs. And we were able to make the build times lower by using Bazel as a caching system. So back in 2019 and 2020, there was no possibility to easily build mixed source frameworks. We've been using Swift and Objective-C, and we were able to cache mixed source frameworks when it wasn't trendy and possible. And this quick story will be about how we've been able to do so. Before we started introducing Bazel as our build system and caching system, we had to perform a cleanup in our monorepository. So modules in the repository were unstructured. We had to unify the structure. The configuration was in project files. We had to extract it, and project files were checked in to the repository, which was kind of a mess. So after the cleanup, we unified the structure so that modules were located under the modules directory. Every module had a sources directory, test directory, configuration directory. And we extracted configuration settings from project files to xcconfig files. We removed Xcode projects. We generate them from manifests. And we use for that Xcode gen tool. But we still had Swift and Objective-C. So we created our command line interface, which is our in-house developed tool. Thanks God for Swift argument parser, which is a standard Apple library for writing command line tools. And it allowed us to provide a few commands for users to work with our workspace, with our projects. So we had a command that generate command that allows us to generate a new module based on a template. We can also generate a project file for a module. We can also dump dependencies from Bazel build file to manifest file so that these two are in sync. And our CLI serves as a bridge between Xcode build, which is a standard command line tool that Xcode, standard IDE from Apple, uses to build mobile applications for iOS. And CLI also serves as a bridge to Bazel so that we could kick off Bazel builds by using our CLI. There's one additional command in our CLI. It's called focus. We use that command to manipulate on the workspace that user works with when developing a feature. So whenever somebody wanted to work on a feature A and B, they call focus command, and these corresponding projects get into the workspace, and we also add over there every project that depends on these two modules. Our CLI also generates a file from which we would know what Bazel targets to build and which locations to copy from the binaries that get built. By default, our workspace contains only 2 projects, the application projects and the Bazel dependencies projects. The Bazel dependencies target that is located in the project gets built before every other target gets built. And this project has 2 run phases. They're called run Bazel and copy frameworks. And the run Bazel framework, the run Bazel script in a very simplified version is like that. We just read the targets that are going to be built by Bazel, and this file was prepared by our CLI by using focus command, and we use our bridge, our CLI, to kick off a Bazel build. We pass the modules to be built, some configuration files, and other settings. Then after every module requested gets built, we copy frameworks from Bazel bin directory to derived data directory, which is a standard directory under which in which Xcode searches for frameworks to be linked. And we also have some build files. So every module has a simple build file that uses our module macro. It has a name and a set of dependencies. And the implementation of a macro and an underlying rule extracts some stuff from context, such as the name of a project and the scheme to be built. We also create a list of dependencies and transitive dependencies, from which we create a config setting called framework search paths. And this config setting tells Xcode where to find the binary of a framework. We define some inputs, such as sources, such as Xcode version, with the binary should be built. And we define an empty output, and this will be the location in which the binary will be available after the build process. And we use an action. We run a command with our CLI tool. The command is called build, and we supply the command with the following arguments. We provide a project path and a scheme name, which is a module name to be built from that project, a set of other parameters, but also an output parameter, which will be used by our CLI to define a location under which the build framework should be put. And this is, of course, in Bazel bin. So to sum up, the build process is a bit complicated, but it starts in Xcode. We run Bazel script that calls our CLI Bazel build command. Then Bazel build gets kicked off. Then Bazel calls our CLI build command, and then our CLI calls Xcode build, which does the actual build of the binary. And then when all modules get built, we copy the frameworks to the standard Xcode location, derived data, and then the build continues in Xcode. Of course, this approach has a few pros and cons. One of the pros is that we have a CLI bridge that is suited for our modules. We were able to use Xcode build and to build mixed source framework. Yeah, it gives some overhead, around 10 seconds for copying. And this is a non-standard approach, so we can't benefit from standard rule set. Thank you very much.
The next talk is by Manuel. It's Planting Basil in Barren Soil, a Perl story.
Thank you. So my name is Manuel. I work at Booking, and I'm here to talk about how we actually replatform part of our Perl legacy monorepo and how Bazel actually helped us achieving that. So a bit of history about that so you can actually understand how we got there. So we are one of the largest travel agencies, online travel agency, OTAs. We were founded in '96. We started with very large monoliths in our single repo. Then we realized we needed more applications. So what we did is just, if you're running on this service, we're going to just make a decision. And we just took the entire code base on every single repository, on every single server. In 2017, we started adopting Kubernetes. And by then, deploying an entire code base of 4 gigabytes didn't scale anymore. Getting like 50, 60 dependencies for each one of them didn't scale anymore. And then realized, we need to do something. And a bit about how is Perl at Booking. So as I said, our code base is a bit messy. It used to be messier than what it is right now. We have around 10 million lines of Perl code. We didn't used to have dependency management back then. Literally, you could get anything everywhere. You will just put everything on a very gigantic Docker image, and we will just ship it over. Our first commit goes back all the way to 2002. And if you're wondering what happened between '96 and 2002, we actually rewrite the entire code base. In 2017, we started adopting GitLab. So this actually enabled us to start doing CI for real and to get ownership. We could actually, from this day, we could actually start getting code ownership. We used to have something based on Jenkins, but it didn't work that well. It was something that you would run it on demand, kind of. So you can imagine how it went. And then in 2020, we finally enabled merge requests and make that mandatory. Until that day, it was very common that you will pull the repo and push until you don't get any conflicts and it goes through. Yeah, it was that's what it happened. So this was the face of our developers on the first day at work. So you land on the repository, or you land on the repo, you open, there is this lib directory that has something like 48,000 files inside with no clear structure. And there was an Italian around in the area at that time, and then he came up with the concept of Project Ravioli. So if you we tend to speak of messy code base as spaghetti code. Well, ravioli is still pasta. I get it, it's pasta. It's still the same thing. You may be lucky and you may be able to tell the sauce apart from the spaghetti, but it looks better than spaghetti. It's a smaller chunks. You no longer get the entire code base. You can actually get your own ravioli, and you don't get all the rest. And we actually call these distributions. And this actually allows our developers to start looking at, hey, if I bring this thing, all of these other things comes with it. It allows us to be testable. Before this, it's I'm going to run this test if this file changes. But now it's as we know, we are actually doing Bazel. So we not only want to test when file changes, we also want to test when the entire transit dependency tree changes. But, or this is a plus, I don't know. It requires a build system. It requires an orchestrator. Perl by itself doesn't need a build system. It's literally, it's going to build when you start it. It doesn't need to build before. But when you're starting to put Docker images, when you're starting, you need external dependencies, when you start to put all of these things together, then you need a build system. Also, I forgot to mention, we have JavaScript on the repository as well, and we have to build the assets. So that was another plus for the build system. So let's adopt Bazel. Fine. Yeah, well, it's not that easy, but we actually managed to do it. And we also have to do it without major disruptions. We started Project Ravioli on Q2 of 2019. We started that in Bazel on Q1 2020. And we did a big bang migration on Q1 2021. That's when actually I joined the team for real. That's when we moved from that gigantic lib directory to something like 6,000 distributions. And it came with challenges. We knew Perl way better than what we knew Bazel back then. As different from other companies, we didn't start it with some Googlers joining us. We really liked the way Google was doing stuff, so we were reading the books that we knew about Blaze, and as soon as Bazel became open source, we went with it. I don't know. Okay, this is a part of it I don't know. I wasn't part of the team back then. I don't think there were Perl rules available back then. Now there's some on GitHub. They are not as good as ours, sorry. But our initial implementation had way too many symlinks. So a very small hello world will have something like 20 to 40,000 symlinks. Yes, exactly. Yes. And we started using Bazel DNF because we are using CentOS for most of our stuff. And Bazel DNF allows us to reuse the RPMs that were built before. this is something that our developers struggles a lot. It's legal, or well, I don't know if the word is legal, but you can on Perl get secret dependencies, and those are totally valid. Well, Bazel, for good reasons, doesn't allow you to do that. We have, for a transition period, we are allowing people to do secret dependencies at the runtime, but yeah, we're still gonna get there. And you need tooling to manage your Bazel files. And because I don't remember the exact details, whether it was because Gazelle plugins were not available back then, or just because we knew Perl way better than that, we actually wrote our own Starlark parser in Perl that is aware of all the Perl dependencies to the point where actually our developers don't have to care about the build of Bazel files. They make a change, they push to CI. On CI, we verify that already introducing any circular dependencies, and we're done. We just have some CI that actually push the build Bazel changes after. Maybe one day we will have Gazelle. We'll see. Well, GitLab runner support. This is, and we have heard this all the day long. Most of the CI solutions are not well set for Bazel. They're just not friendly enough. They all just start from clean stuff. And unfortunately, there's no open source solution for this. So we actually make our own bare metal based monster for GitLab that where we have Docker in there. I'm not gonna get there. And remote caching and BES and the BLS event service are critical. We started with JFrog as our remote caching support, tooling. After BazelCon last year, we started testing other things. We actually have a setup where we are using the open source build body for BES and remote caching. We're using Build Barn for RBE. We're still looking for vendors. There are some things inside the company where I cannot get it, but it's not part of this discussion. And RBE is trivial. Well, sorry, that's the typo that I have on the slide. RBE is not trivial at all, especially if you own your own rules. We haven't finished adopting RBE yet. We are doing something similar to what Python does with egg files, where we're just going to create a TARGC for each one of our libraries. And it turns out it's way more efficient to ship maybe 2,000 TARGCs of like 100 kilobytes and push in 40,000 files. And it works, but we haven't merged a branch. So some of our results. The first of all, as I mentioned before, 100% coverage that all our build Bazel files are auto-managed. And this actually made our developers' experience easier, better, in the sense they don't have to care about this. 55% of our services are already on Bazel, so in total we have something like 350 services, out of which 11% were created over the last 12 months. So, like, at least to me, I'm going to be humble, I think we succeeded. This is the most impressive one. So from the 2.2 gigabyte image we had in Docker where we shipped the entire code base, we can get the hello world for under 500 megabytes. And this is because we are still shipping an entire CentOS 7 that has RPM support and all of that. I'm actually working on doing this with Bazel DNF. We increased our CI usage. So we were running 800 shops on 2020. Now we're running 1.6 million per month. Our 19%, our 50%, not our 90, went down from 22 minutes to 2 minutes. So actually our developers are way happy, like they push a branch to our repo and they get the results in less than 5 minutes. Our test coverage started increasing. Like, turns out that if you allow your developers to write tests, you actually write a test. And they actually implemented 12.5% over the last 12 months, which is impressive. And yeah, Bazel was a crucial part for this entire trip. I think we can say our customers are happy. Like, it's always like the detractors are way louder than the adopters. And we're not getting much detractors. So I think people are happy. I don't know. Native caching features and native remote execution and instrumentation of your build systems are the things that you really need to get out. So Bazel was the right fit for this. And I'm very, very happy that no one wanted to do the stupid decision of implementing a build system in Perl just for the sake of implementing a build system. And thank you.
Okay, the final talk of the day is by Chris, and is about building without the public internet.
Hello. So I'm Chris. I'm a software engineer at Salesforce, and today I'm going to be talking about how we build without using the public internet. So I'm going to start off by giving a little bit of background. So our team primarily used to be focused on building microservice libraries. And then in 2017, we decided it was a good idea to also bring the clients of those libraries into a big monorepo where our libraries are built. So we have two shared repositories, one Java and one Golang. We're currently using Bazel 5, although I think this week, hopefully we're going to be on Bazel 6. And it sounds like we might need to start using Bazel mod soon as well. So we have various CI jobs that do different things. They build, test, and publish artifacts to different places, like our container images to our registry. And we also run validations like security scans. So a little bit about our team. This was us at BazelCon last year. Peter and Simon have given various talks at BazelCon before, for the first time in 2018, I believe. And it's great to be back at BazelCon this year. And this is my first time speaking at a conference. So thanks for listening. So now, what is this talk about? So we want our Bazel builds to work without needing to reach out to the public internet for any build dependencies. We already use internal mirrors for our Java and Golang dependencies. So this is about all of the other things that Bazel needs to pull during builds. This includes rule sets like rules OCI, but also all the transitive dependencies of those rule sets. So why do we want to do this? There's two reasons. The first is security. I care a lot about security, and that's why I have a very scary guard dog. He's very scary, right? So Bazel already has a lot of good security features built in, like checksum verification, and these features do reduce a lot of risk, but ultimately some of our builds did not reach out to the public internet at all, so this is why we want to do this. The second reason is reliability. If we're downloading a dependency from the public internet and the owner of that stops serving it, we don't want our builds to fail. So speaking about reliability for a minute, I think this came up earlier as well. So we obviously weren't the only people affected. In January of this year, there was an incident where the checksums of existing GitHub archives changed, and this caused a major issue for our builds because the checksum of our downloads didn't match what the workspace file expected. So given all of this, how do we actually achieve builds without the internet? So we started off with an initial attempt, and looking back, this was a little bit naive and wasn't perfect. So we built an artifact that included all build dependencies, and we baked this artifact into our CI image. And during CI builds, we extracted this artifact into a directory and pointed distdir to it. If you don't know what distdir is, it's basically a flag that you can use where Bazel will check for dependencies in a directory before it fetches them from the internet. So we soon realized that this solution didn't scale very well because anytime we updated or added a new build dependency, we needed to rebuild the CI build image and the artifact. So moving on to our current solution, it still isn't perfect, but it works well for us. So it's basically a semi-automated mirroring solution that uses some useful Bazel features. We start off by cataloging our build dependencies. Then we parse the catalog and perform some actions for each entry. Then we verify, and finally, we handle some edge cases. So starting off with how we catalog. So the Bazel sync command generates a snapshot of all repositories mentioned in the workspace. We have an optimized Bazel sync command that will comment out things that we don't care about. For example, OCI pulls, because we already know that our images are coming from a private Docker registry. So this is the output of the resolve BZL. And from the URL section, sorry, we're able to tell if a dependency is already mirrored or if we need to mirror this dependency. So next, we parse the catalog and perform some actions. So we have some custom scripting that parses the catalog and performs some actions. So it identifies files that haven't been mirrored yet. It downloads them and uploads them to our internal blob storage. And then we generate a new workspace include file that contains the mirrored URLs of the transitive. So we load this BZL file first, because it's important that this is loaded before any of the other rules. So you can see here in the workspace include file, we add the mirror path URL as well. So then we need to verify that everything is mirrored and working. So we have an extra full build and CI job that blocks access to the public internet, and it does this using the experimental downloader config. We utilize this flag a lot for different reasons, and this is just one of them. So this is our downloader config. It starts off by blocking access to everything, and then one by one, we allow access to our internal resources. So finally, we need to handle the edge cases. So there's some things that don't seem to work very well with this approach. So we find these out from the verify step because this CI job fails because it can't find any URLs that aren't blocked. So we're able to then handle these edge cases, again, using the Bazel downloader config, and we just rewrite those URLs. Thank you. And just to mention, we have a few open source projects that we work on. So if you're interested in any of them, please check them out.
Thank you. Before I let you go, I have two announcements. Don't forget to bring your badge tomorrow. You will get the new agenda at the registration. We will also have new office hours for C++. There's a couple people that asked for that. So be sure if you want to attend this office hour or any other one to sign up tomorrow morning at the registration as well when you get your new agenda. I think, well, for me personally, I enjoyed the day very much. I hope you did as well. Maybe you met a couple new people. The day will continue with the happy hour, looking for Helen and Justin. Next slide. It's on the slide, yes, but I want them to talk.
Okay, well, many of you already signed up for the happy hour, and if you have an invite, you have the instructions how to get there. If you don't have an invite, I can't promise we can let you in, but chances are okay. Yeah, chances are okay that we can let you in. And I want to just reiterate how to get there from here. It's pretty simple. You go to the S-Bahn Donnersberger Brücke. The S-Bahn goes right along here. There's a little bridge that goes up, and you can go down onto the Donnersberger Brücke platform. You have to watch out only to go in the right direction. The right direction is that one, Stadtauswärts, it says on the signs. Stadtauswärts, yeah. And yeah, and it should probably also say Lime on it. Lime, L-A-I-M. It's just 2 stops, and then you have to find this complex of green buildings and entry number 23. Google Maps does tell you how to get there. The important part to watch out is to not take S7. That will take you elsewhere. Every other S-Bahn will be fine. Yeah. That's all.
A few more things. So just what to expect. And also, it's raining. Don't forget to grab your umbrella in the swag room, along with other swag. There may also be still some Bazel flags cards, which may be used in a game night. So if you don't have one, you may still be able to get one. And what to expect, it's an experiment. We always like to do new things at BazelCon. So it's, food, drinks, and hanging out, plus a bunch of games. Matt Stark here from Google offered to host the games. A few others are welcome to do it. We'll have a collection of board games, card games, whatever you guys feel like, or just hang out and talk to each other. Thanks.
Wow. Have fun.
See you there.